On behalf of DataEngBytes Melbourne, I respectfully acknowledge that we are meeting on the traditional land of the Kulin Nation, and I pay my respects to the elders, both past and present, and elders from other communities who may be here today. We've been through a lot these last 3 years. 2020 started off kind of like any other year. We were heading back into the office after the end of year holidays, getting back into the meetup scene, doing conferences, parties, family get-togethers. It was all happening until it wasn't. Life as we knew it came to a grinding halt. We were all filled with fear from a terrible disease that was ripping through the globe, and although we were in a relatively safe haven, our protective barrier was paper thin at best. So we began the journey of working from home. We became school teachers for our kids, found new ways to socialize with our friends, and continue our tech community journey. As we became more physically contained within our home environment, our awareness grew more broadly into a global tech community which knew no barrier, be it time, language, nor border. We also grew tired of always being on, always being connected, and always having something to take up our attention. It was overwhelming. And now, as we find our feet in this new world, where we begin to engage with one another again in the physical space, we're embraced with a new challenge. One that requires us to set new boundaries around our time and challenges us to focus on what's important to ourselves, our careers, and our families. It challenges us to find connection.
Welcome to the stage, Riva Kanduri.
Thank you. Thank you, Peter, and good morning, everyone. And really grateful that you all guys took a day off to just attend our conference today. I welcome you all to the DataEngBytes conference, and my name is Riva, and it's my pleasure to, welcome you all for this day and have an amazing, fun interaction with your colleagues and peer engineers. We have a series of amazing talks lined up for the day, starting with Zainab Maleki, all the way from the Perth. She's joining us today. And we are ending our day with an interesting panel discussion hosted by Nitish Matthew, Director of Data Engineering and Afterpay. Some quick housekeeping rules. The emergency exits can be found at the back of the room, and you will find restrooms located in the hall between Village Roadshow Theatre and the Conversation Quarter. Our tea time and meal breaks are held in the Conversation Quarter, where you might also have seen our amazing sponsors setting up their booths to have a conversation with you all. At the back of your lanyards, you'll find a card with all our sponsor logos. All you have to do is have sparkling conversations with our sponsors, get a stamp on your card, get at least 6 stamps, and then you are eligible for a raffle for some amazing prizes. We will do the raffle at the end of the conference, and the drop-in box will be located in the Conversation Quarter. So without further ado, let's get started, and I invite Peter Hansens, the founder and the Meetup Conference founder for DataEngBytes.
Thank you very much. I just wanted to say a big thank you, first and foremost, to you all, and also to our wonderful sponsors, of whom this conference wouldn't be able to take place, because it's without their tremendous support. It's been massively instrumental. Data engineering has gone on a massive growth journey these last few years, and it's just been amazing over the last 5 years to see it grow from strength to strength. We started our first meetup in Sydney way back in 2017. A little recruitment company called the Onset Group hosted us. It was a very memorable night. They ordered the most ridiculous pizza slices I've ever seen at a meetup. It was just a really fun meetup. There was just 20 people. So it was almost something inconsequential that turned out to be something pretty amazing. It's just really heartwarming to see you all here today. And a little while after that, once we sort of started getting the meetup going, we soon started hosting meetups here in Sydney, and soon afterwards here in Melbourne, and soon afterwards we started thinking about hosting a conference. That was after about 3 years, and but then, we were just planning that all out, and a little old pandemic came along, and, lo and behold, we had to sort of quickly pivot to online. And so the last 2 years, we've been running an online conference called DataEngBytes. Obviously, you probably know where the data engineering side of things come from, but the bytes part of the word really came from this sense that we had from running the meetup over a couple of years, where we could see that, folks were a bit overwhelmed. They had information overload during the pandemic. There's lots of information coming to us all the time about what was going on, and really people wanted a concise way to consume information. And so we came up with this conference named DataEngBytes, and because we're in a tech field, we did a play on words, bytes with a Y. So that's a bit of an explanation of, how we came up with the name of DataEngBytes. So I guess, what are we looking for today? And here's some of our amazing meetup organizers across Australia. I wanted to just really acknowledge all of their hard work. We're now in Hobart, Brisbane, and Perth, and, it's just amazing to see that, so many people coming together, sharing, what they're learning in the field, and really growing our collective knowledge. So I guess for today, we've got lots of talks, amazing speakers and panelists and the like. And what I wanted to do is leave you with a bit of an inspiring thought for today, and to take with you beyond this conference, because it's very clear, looking around the room and looking at the speaker lineup that we've got, tremendous data engineering talent in Australia. We're doing amazing things. We'll be hearing from Nitish Matthew later today about, some of the amazing stuff that they're doing at Afterpay and the like. But I guess my challenge to you is, can we become, leaders in innovation in data engineering? We see sprinkles of that with some of the data engineering startups like Omnada and Carta, two fantastic Aussie data engineering startups that are really starting to gain some traction. But, my challenge to you is, will you be the next data engineering leader? So with that, I thank you, and I welcome you to enjoy this day of data engineering. Thank you.
Thank you, Peter. Good morning, everyone. I hope you're feeling the same energy that I am in the room today. It's great to see you all. I'm the least interesting person up on stage today, so we're going to quickly hand over to Zainab Maleki, who'll be speaking on bringing software engineering rigor to data. So Zainab is a principal DevOps and data engineer at Mechanical Rock, Australia's leading cloud-native consultancy. I'll hand over to her, and away we go. Thank you.
I have a confession to make. But before that, I want you to make a confession to me. I want you to raise your hand if you believe the way you're handling data in your organization is very, very efficient. Efficiency is a subjective term, right? Let's put it against some numbers, some facts, because we're data people, right? Let's say you're trying to ingest a new data set. From the time that You start your connection to your source till you get your data in through different layers of transformation, till you get it to different environments and you're testing, and you make it available in production to your consumers. The whole process takes you only a few hours. I want you to raise your hand if you believe the way you're handling your data is very, very efficient. Not many, right? What about moderate efficiency? Let's say this whole process takes you only a couple of days. Still no one. How about not efficient at all? Anything that takes you more than 2 days, it's considered as not efficient at all. And that's what I think where the industry is. Thank you for being honest with me. I also have a confession. I am not a data engineer. In fact, I don't have the skill set that you guys have in the actual data engineering. But what I'm really good at is helping data teams to become very, very efficient. I always say this to my client. I want you to develop fast. I want you to move fast and move with confidence. Because you don't want to keep moving fast and falling and tripping. You want to move fast and you want to move with confidence. Believing whatever you've done, it's not going to fail. Hi everyone, my name is Zainab Maleki and I'm a technical principal at a consultancy firm in Perth called Mechanical Rock. A bit of background about myself. I'm a software engineer by nature. I've done a lot of app development, a lot of front-end, back-end, infrastructure as code, DevOps and automations. But in the past 2 to 3 years, I've been involved in data area, helping clients to build data platforms on Snowflake, on Databricks, helping to set up security, patterns. But the main thing has been helping clients to move fast with their data. And that's what I'm here today. I'm going to be talking about how to bring software engineering rigor into data. Things that I was doing in building softwares that was helping us to move fast and move with confidence. I'm going to tell you how to apply them in data. I always say this to my client. You have to think of it as building a software application because it's no different. In software application development, you build some business logic, some functions, right? You give it an input, you expect an output. Same thing in data. You write some transformation logic. You give it input data, expected output data. And then you have to deploy it. And then you have to test it, push it to production. Same thing in data, right? But I also contradict myself. I also say it's not the same thing. The main difference that I see in data engineering and software application is the fact that if your software application fails, it's a lot easier, a lot less at stake. You push small changes, trunk-based development, small changes to production. If it fails, you cause an incident, you revert it back. Nothing happens, right? You get your production application healthy. What about data? Data is often in the middle, and we have so many consumers. We have our business peoples, we have our reports, we have our machine learning models, we have our third-party applications consuming the data that we generate. And imagine, what happens if you push the wrong data? If you push bad data, you go to your CEO and knock his door and say, hey, that report that I sent you last week, it was wrong. I messed it up. We actually didn't make money, we lost money. Do the same thing to your machine learning model. Say, you've been trained for the past 3 months with good data, but I made a change and I messed it up. Past week, whatever you've learned, remove it, unlearn it. Maybe you can. I'm not a data scientist, I don't know. Maybe you can reset your machine learning models. But what I'm trying to say is it's really, really hard. And it's very expensive to clean your bad data from your production. Same with your third-party applications. And that's why I always say testing is way more important than you think in data. Because it allows you to move with confidence. And that's what we want to do. We want to make sure that the transformation that we push, the logic that we push, it's not going to break anything. It's not going to generate bad data. When I started my journey in data, I was researching, because at Mechanical Rock, we do a lot of automated testing, a lot of unit tests, integration tests, end-to-end testing. So I was trying to do the same thing in data. I was Googling, researching, going to meetups, asking people, how do you do your automated testing? All I was hearing is, we do data quality checks. I was like, what? Data quality checks. Great expectation testing, DBT testing. They're all the same thing. It says, the specific column that I've got, data coming in, make sure that's unique. Or make sure the data that comes into other column matches a specific regex. But is that enough? Is that enough to give us confidence that the business logic that we've written, it's not going to fail? No, it's not. There are different ways of testing in data. There are data quality checks, gaps checking, querying random batches of data, testing your input and output. But what I love is black box testing. This is my input, this is my expected output, take it through the transformation, does it match? Who has heard of DORA metrics? Raise your hand if you've heard of DORA metrics. Okay, good, few people. DevOps research and assessment team. They're a team backed by Google. They've done 6 years of study to identify 4 key metrics that allows a software development team to move fast, that identifies the performance of a software development team. What are those metrics? Deployment frequency. How many times do you deploy to production? Lead time for a change. From the time that you push your change until you push it to different environment, until you run it through your testing and push it to your production, how long this process takes. That's called lead time. Change failure rate. How often does the change that you push cause a failure? And time to restore service. From the time that something fails, until you know about it, until you figure out where it's broken, until you push a fix, that's called time to restore. Does this apply to data? Yes or no? Yes, it does, right? Because we still do the same thing. We still deploy code to production. We still make failures. The data pipelines that we create, it fails, and it needs to be stable. Same thing applies. DORA teams, they say you're an elite or high-performing team if you're high-performing across all 4 metrics, because they correlate. You can't be high-performing in deployment frequency, constantly push changes without testing, and then cause your change failure rate to go up, or your time to restore to go up. So you have to be an elite team in all of those metrics. So they say, deployment frequency, you're an elite or high-performing team if you at least push more than once a day to production. Where do you think we are? Raise your hand if you think we're elite or high-performing data teams as an industry. This is where I think, because there's no data, it's my opinion. There's nothing online. I think from all the clients that I've seen, all the people that I've talked to in the data industry, I think we're in high or medium. We make changes to production. For new changes, new transformations, we make them quick. But then existing code. If you have an existing transformation made by someone else, 2 years ago, they left the company, some report is using it, and if that breaks, people start yelling at us, we're scared touching that. We don't make changes to it often. What about lead time? From the time that you commit your change to production, I actually think it's okay. We're not doing bad. For wrong reasons though, because we don't do enough testing. Well, I haven't seen much automated testing in the industry, and not even manual testing much in data. If you're not doing manual testing, well, you're fast. Just go straight to production. You don't even go to any other environments. Time to restore service. That's where I think we're really bad as an industry. I really think between 1 day to 1 week or more than that. When some data pipelines fail, it takes a long time to restore it and to fix it. And change failure rate. Again, I've heard that everywhere. Our data pipelines are not stable. Our data is untrustworthy. And that's because it keeps failing. Anything more than 15% of change failure rate, you're a low-performing team. DORA team, they have created these reports called Accelerated State of DevOps. Per year, they generate that report. 2021, they say, an elite performers, in comparison to low performers, they have 973 times more frequent code deployments to production. 973 times. And in terms of their lead time, they're 6,570 times faster to push their change to production. And 6,570 times faster to restore from a failure, from an incident. Now, if you think we're low performing in data, you can see where we can become if we become an elite team, right? So how do we become an elite data team? What's the thing that we can do to become a high-performing data team, right? In the next 20 minutes, I'm going to take you through 5 failure points that I've seen it happening over and over in the industry. And 5 strategies or principles that if you follow them, you can scale and you can become fast-moving teams. Point number 1, slow-moving data teams. What do you mean by that? Slow-moving platforms, actually. You might be familiar with this. This is taken from data mesh. Who knows about data mesh? Raise your hand. Okay, that's what I was expecting. A lot of people in data, they know about what data mesh is. For decades and years, we had these data platforms in the center, and physical resources. We had data producers pushing data into it. We had our consumers accessing data from that centralized platform. But we identified our physical resources are not scalable. They're not able to keep up with demand, and they're not scalable. So what we did was we pushed them into cloud. Cloud is scalable, right? It's elastic. So we thought that's going to help us to move faster. But it's not. We still have slow-moving data platforms. Why is that happening? Because those data teams, they're often managed and controlled by decentralized data teams. They're the ones who maintain the platform. Anything going into the data platform has to go through that central team. Anything going out of the platform has to go through that central team. And it's not fast. Or even worse, those central data teams, they do the whole thing of grabbing data, transforming it, pushing the data out. Grabbing more data, transforming it, pushing it out. Now think about enterprise level. Now how many data pipelines they have to build and surface? What happens if you build something? Who maintains it? Yourself, right? Now if you're a central team and you build so many data pipelines, you have to maintain all of them. And then it fails, because it always does. Don't tell me like I'll build a data pipeline that never fails, because it does. Our systems are evolving, our data are evolving. So our data pipelines fail, and you have to maintain them. And then I often see the central team, they're constantly firefighting. They're constantly trying to be under pressure because of all the things that fail. because of all the requests that they get, because of all the demands that they get. And that's not scalable. Our people are not scalable. Doesn't matter how many people you put in the middle, it's still not scalable. So how do we fix this? You need to start decentralizing your data engineering teams. If you already have a central data team, think about decentralizing them. They have to be embedded within each domain and business units. And that's what the data mesh tells you. Data mesh tells you that each domain, they have to do their own ingestion, they have to do their own processing, and their own serving of data. Does that mean that everyone does their own thing and then we get inconsistency in our platforms? No. There are still centralized pieces, and that's called the governance, controls, the platform consistency. Those bits are centralized. But the actual data engineering, ingestion, processing, serving the data has to be domain's responsibility. So you need to start separating what's centralized, what's not. What is the platform responsibility? What is the domain's responsibility? This is from data mesh architecture. Tells you domain is in the middle. That bit is domain's responsibility, creating data products, ingesting, serving. But the platform responsibility is policy automation, monitoring, access management, cataloging, storage, and query engine. We've got a guild over there that look after the governance and rules and policy. They create the policies, but data platform team automate it. And then there's an enabling team that helps the domain with good practices, with documentations, with how to get started, helping the domains to get started with the platform. If you want to think about different responsibilities, that's what I think the platform should do. Enabling the domains. What do I mean by that? I'm a domain, I want to get started with the platform. I need a few things. I need a database. I need a role. I need grants. I need access controls. All of those things have to be created for the domain for them to get started. Because we don't want to give admin access to the domain so they can do whatever they want. We want to have platform consistency and good RBAC architecture. So they control within the platform. Centralized access layer, consistency, auditing, and platform building templates, which I'm going to talk about later. But domains, they're responsible for ingesting data, transforming data, serving their data, observability on their data pipelines, automated testing on their data pipelines, and data masking and PII removal. Why data masking? Because they're the business owners, they're data owners, they know about their data. They're the best people to know what to remove and what not to remove, what's sensitive and what's not. You still think domains and platforms, okay? There's still coupling. When there's couplings between the teams, you can't move fast, right? So how do we remove this coupling between the two to allow the domains to go fast, to not needing to engage another team to do something for them in order to get started? The only way that you can move fast is by automating your platform responsibilities, by creating a self-served automated platforms. And that takes me to my second failure point. What I see is in data platforms teams, we don't often have enough capability. The capability required to automate things and to move fast. To build a strong platform team, you need to combine your capabilities. You need to combine your people, bring people with strong DevOps and automation capability and mix them up. I told you, I'm not a data engineer. I'm a DevOps engineer. I'm good at DevOps and automation, but I've learned data engineering working with other data engineers in the platform teams. I teach them DevOps and automation. They teach me data engineering. It works. We combine our skill sets and our capabilities. in order to build a fully self-served automated platforms. And that's the only way you can move fast and you can scale fast. Another failure point, slow platform adoptions by domains. The domains, they don't want to take responsibilities. They don't want to do more work. They don't understand data engineering. So how do we convince them to take on their own data engineering? You build it, you run it, you maintain it, you also take care of your own data. How do we do that? By automating domain capabilities to allow easy adoption. Remember the thing that I said about building templates? Platforms, one of their responsibilities is building templates. So close your eyes. I'm honest, close your eyes. Imagine I'm a domain. I go to this self-serve, fully automated platform. I fill out my form, could be a dashboard, could be a bot, could be anything. I fill out the form, my naming convention, name of data owners, details, and then press submit. And then automatically, I get everything that I need. I get all the resources that I need to get started. I get a pre-template GitHub repository with automated deployment built into it, with automated testing built into it, with automated CI/CD built into it. Everything, it's ready for me to get started. It's sample SQL transformations and sample testing. All I need to do is just changing that SQL. Say, this is my table name, this is my source, writing my SQL transformation. So you know how easy that becomes for them? They don't have to understand the integration, the plugging, the setup. It's all set up and ready for them. Ta-da, it's magic. Now they can go fast. Now they can adopt it really fast. Failure point number 4. Overprotective data teams. I see it all the time. They're like, our data is sensitive. We don't want to give access to anyone. We're scared. So what we do is we hide it. And then what happens? Our data becomes undiscoverable. And then what happens when your data is undiscoverable? You create multiple copies of the data, the same data. It's not there, so I think it's not there. I'll replicate it again. So how do we fix this issue? I had one client, it was hilarious, I swear to God. They had their testing, QA, in all different environments. But they're like, we don't give anyone access to any of those environments. We've created per domain, but we don't give them access. Because we're scared they will build production data into their QA database or test database. What? You can't stop people from being dumb. All you can do is to detect it, right? What happened? So strategy number 4, build security and data discoverability into the platform. Because you're the platform team, you give the domains everything that they need, including pre-built, predefined roles, access controls, everything. So you set up data discoverability and security already built in. And it's consistent for every domain. Instead of protecting your data and hiding it, assume everything is safe. Assume all data are non-sensitive, unless the domain defines it. Unless the domain team, they say this data is sensitive. You're like, what? That's lack of security. We don't want our sensitive data being leaked. Well, how do you fix that? By detective approach instead of protective approach. So instead of hiding your data, detect the ones that are being leaked. There's a lot of testing tools. Goes and checks for sensitive data in your databases and gives you a report. Automate those. Like for example, Alation does that. Plug into Alation API or any other tools that you want. run it through all of your data and identify the sensitive data that hasn't been masked or hasn't been removed. And then what you do? Remove them, hide them. It all happens automatically, right? So we protect our data, and then domains, we teach them from the start, you need to protect your sensitive data, otherwise we're going to delete it. Otherwise, it's going to go missing automatically. So they learn to do the right thing from the very start, rather than us being overprotective. Failure point number 5, cluster of mess. I say it over and over. You might have seen it even in your organization. This is an example, but true story. There's a report that we need, and this is our source database. In the past, we had a sub-million job transforming data, pushing it into Redshift. But that data is required for this report. And we don't know what's going on here, so we're scared of deleting it. At some point, we also pulled DMS to push the data into S3 bucket. And then God knows what this glue job is doing, but it's pushing some data into Redshift that we need. And then at some point, we thought Cloudera was a good thing. So we would like that lake on top of our S3 bucket. And we also did some proof of concept with Databricks, with DBT on a ECS that keeps going out of memory. And we also plugged that data into our report. Now imagine, one of these lines break. What happens? You get bad data in your report. You get missing data in your report, right? And then we thought, our problems are our tools. Let's just try something different. Maybe Redshift is not good. Let's go with Fivetran. Fivetran is SaaS product, right? You don't have to maintain infrastructure. It's scalable. It's good. Snowflake, SaaS again. I don't have to maintain infrastructure. Let's go with that. And who doesn't love DBT? We all love DBT. And then we hate Ginger, right? So we put DBT in there. But what people don't realize is it's another mess added to the top. So we create more mess and more mess. Unless you clean this, they all exist together. And we're too scared of cleaning because we don't know what's going to break, because we don't have enough observability, enough testing. I honestly have seen this. Even companies, they're doing the right thing. They don't have this mess. They use only one data warehouse, tools and technology. And they're doing ELT, good, extract, load, and then transform on top. But they still have mess inside that one data warehouse. Everyone doing their own thing. There's like lack of security. Things are messy. Things keep failing. Inconsistency. Why is that happening? Because we don't do it right first time. And that's what I say. Build it once and build it right. Spend enough time to build it right. Build the right infrastructure. Build the right architecture. Build the right security controls from the very start to allow you to move fast, to give you the confidence, to give you consistency. Unless you do it right, you'll be in the same situation again and again and again. Tools are not our problems. There are heaps of tools out there. The way of doing things are our problems. But good things take time. What are you telling me? You're telling me to change team topologies. You're telling me to just bring and hire DevOps engineers. They're too hard. That's not my job. I'm a data engineer. What do I do? Like, that's management decisions. Now, start small. Start small with things that you can do right now. Use Git for the love of God. If you're not using a version control, already use it. Because I've seen it. I've seen us going manually changing things inside a data warehouse. Oh my God, that's hard to debug. Other people won't know what we've done. And we create more errors. Don't do that. Just plug it to a version control. Set up automated deployments. So everything is consistently being deployed and pushed, and it's fast. Add automated testing. Data quality checks are not enough. Add enough automated testing to give you confidence to move fast. And separate platform administration from your data pipelines. So if you think data mesh is a good thing, if you believe in it, if you want to go with that pattern, start with separating at least your business logics. Separate whatever is required for platform administration from your data pipelines. And then when you start separating your codes and business logic, then you can start thinking of handing some of those over to the domains. And start capturing data about health of your data pipelines. The only way to be able to improve is to know where you are right now. It's really easy. DORA metrics that I talked about, mean time to recovery, mean time between failures. Those things are really easy to capture in your data pipelines. And we're data people, right? We want to capture data about your data. How stable is the thing that you build? How often does it fail? And remove your administration access, again, for the love of God. Because you're a data engineer, it doesn't mean that you should have admin access. It literally doesn't. No one needs admin access. What needs admin access is my service user that is connected to your automated pipeline that I can push high privileged actions. Not myself. I don't need admin. No one does. Here are some of the references. We've got a blog on Snowflake Data Ops. We use a lot of Snowflake in MakeRock. If you guys are interested how to set up automated pipeline, it's really easy to do that with AWS. There's some other blog posts about DORA, about data mesh, and these two books are highly recommended. They talk about the same concept, data management and scale. It talks about domain data-driven design, which is similar to data mesh. Highly recommend them, read them. There are some data mesh books, I think, out there in the sponsor desk. And yeah, call us. If you have any issues, we have helped a lot of clients in Mechanical Rock to set up data mesh, to go fast, to scale. If you have any questions, come and talk to myself or Hamish from Mechanical Rock. We're happy to answer any other questions. Thank you very much.
If you have any questions, it's a good time to ask. We can support one or two questions.
Thank you. That was an amazing talk. I really appreciate that. I'm curious to know whether hi all. I've got a booming enough voice, everyone can hear me. That's all right. I was curious to know, I love data mesh. It's a great concept and framework. I'm curious to know whether you've seen that successfully applied anywhere.
Yes. Not fully implemented because it's a long journey. It takes a lot to migrate everything in every way that we're working. But with one of the clients, they're almost there. They've started separating their business domains and setting up decentralized platform administrations. And each of the domain, they're doing their own ingestion and transformations. Another client, we're helping them to get there. I think, yes, I have seen it. It's possible. Yeah. Yes.
Excuse me. It won't come in the recording, so if you could, please pass it.
Thank you. Yeah, just a question. You had that diagram with the Wild West of all the different services and people doing whatever.
Mm-hmm.
Doesn't that become even worse in the data mesh framework when each of the teams is potentially doing their own thing again? So what are your thoughts on that, and how does that work in a distributed way?
Yeah, I often say this: control the things that are important and let go of the things that are not important. If the domain is deciding, like for example, we're creating templates for the domain as a template and pattern for them to get started fast. But if they want to go their own way, let them do it. Why does it matter? They maintain it, they take care of it, they're responsible for it, not me. And as long as that domain knows how to maintain it, it doesn't matter what tools or technology they're using for their transformation. And even if they want to do things manually, I don't suggest that. I don't do anything manually. But if they want to do that, it's their responsibility to maintain and take care of it. Let them do. So I always say, control the things that matters. Security, access control, high-level consistency. But then inside it, tools and technologies that they want to use, it's up to them.
Thank you.
Yes.
Yeah, so my question is very simple. So with the distributed Java team, how will the report line work? So for example, the team is distributed in the different team, the data engineering different, embedded in some software engineering team where a lot of software engineer. How will the report line generally work in that case?
As reporting management?
Yes.
Yeah.
Yes.
I think it will be part of that domain reporting. So each of the data engineers, they will have a different report line. Yeah, it doesn't have to be centralized.
So the report line doesn't have to be centralized as well. Okay.
Yeah.
It's competing.
A little bit similar to the previous question. So on this diagram, your work starts on the left, right? The database seems to be the sort of starting point of your pipeline.
Databricks?
No, the database on the left,
Oh,
right?
yeah,
That's
yeah.
your source.
Yeah,
and obviously there could be multiple different types of databases and multiple databases in one domain, and there could be streams, etc. But often data pipelines fail or they produce the wrong result because there are upstream changes.
Yeah.
And you talked about coupling before, and you'd probably say just make it the problem of the business domain people. But how do you solve that problem where, let's say, the team deploying the website or the web services or whatever, they deploy like multiple times a day, which often leads to inconsistencies in the source data, and then the team building the data transformations has to sort of catch up and build a pipeline that can interpret all the different ways the data was generated in the past. How do you, I guess, skill up the domain people and get them to change their way of addressing that?
I think data mesh was really good with that because you bring the data engineering and make it problem of the domain. So software engineers, that they build the application, they also help with the data. So when they help with the data, they understand the pain. They understand, just for God's sake, add a date column in your tables. They understand why we need that. And then they start thinking in advance the things that they should take care of if they're making a change. And they do the whole process. So what I'm saying is, like, if it's a domain problem, then they know about what's going on in the data area. So they're being more mindful of the things that breaks our sites. So they build their softwares in a way that
I think that would absolutely be ideal. But do you see pushback where they say, "But hey, you're slowing us down. We can't deploy as many changes as frequently because now we have to worry about the downstream stuff as well"?
I think it's a contract, right? So the place that I worked with, the software engineering team, they also take care of pushing the data into S3 bucket. And then there's versioning and there's things. So if they have a breaking change, they make sure that, like, it's a new version. So it's a contract between what's the upstream of what you're connecting and the data being pushed. And if it's all within one domain, it's a lot more manageable than being centralized. Yeah.
Cool. Thanks.
Yep.
Thank you for the wonderful presentation. It was really informative. My question is with regards to data mesh. So as you mentioned, it's for each domain, you have separate pipeline for in data mesh. Wouldn't there be challenges with regards to how you manage to upskill the data engineers? Because each of them would have to understand each domain's understanding. And also the second question, if each domain looks after their own infrastructure or ecosystem, what if there is cross dependencies and how to manage them?
What do you mean by cross dependency?
As in, there might be some reports which are cross dependent. So one domain, another domain, they may overlap at certain point in the pipeline to to give the report, unique report. So how do we manage that?
Yeah, cool. So in terms of cross-dependency, it's similar to how we work right now. We create data products, and then we create versions of data products. And there are consumers like analysts using specific versions, right? So same thing in the domains. When they manage creating that data products, they also have to make sure that they do it in a way that it doesn't break down streams. So their data products is consumed by themselves as well as other business domains, and as well as like reports that we need, like for example, cross domains. And what was your first question? Oh yeah, upscaling. I think it's easier. As being in the centralized team, you need to know the business domain of every domain and data about every domain. If you're only working in one area, it's a lot easier. You only need to know the business logic of that specific domain and data of that specific domain, rather than knowing everything. Yeah. Hey.
Hey, so what are some of the other big ideas or best practices in software engineering that you see moving into data engineering?
I think for now, like the one that I see a lot is DevOps automations and creating templates and patterns, because I see a lot of repetitions in data engineering. We're doing the same thing over and over, like connecting to source, we're deduplicating, we transform the data. Why can't we create templates and patterns? And yeah, so far that's the thing that I spend a lot of my time investigating. Yeah.
Thanks.
Thank you, Zainab, so much. We're conscious of the time and we would like to move to the next speaker.
Thank you.
I'm sure you all enjoyed the talk, also the visual appealing slides that I enjoyed the most. I would like to introduce our next set of speakers, Nigel and Ned, onto the stage. Nigel, he works for ThoughtWorks as a social data scientist. After 40 years of building technology solutions to solve human behavioral problems and largely failing, he wanted to join ThoughtWorks to redeem himself and make a difference. So he also co-hosted a podcast successfully. It's called AI Australia. Our second speaker, Ned, is currently also a data science engineer at ThoughtWorks, and he loves using data to solve tangible problems and focus on how organizations and teams can do better. So without further ado, I'll welcome you both.
Well, Ned, I'm excited. That's the best promotion I've had in a long time. I'm actually either a social scientist, not a data scientist, just not good enough at maths, basically.
Cool. Well, welcome everyone to Data Chess or Data Poker, thinking in bets for data teams. So our goal today is to introduce to you a new way of thinking about the investment of your time and resources. In other words, how you make decisions. And if nothing else, we're going to work out who are the chess players and who are the poker players.
And if nothing else, I will desperately try to avoid the controversy of having a topic that is probably the most inopportune time to be talking about chess and strategy. Those of you who are interested in chess and chess masters will understand a completely new definition of SQL injection. But this is us, isn't it? We've spent the last 982 days locked down at ThoughtWorks because we joined at the time of the pandemic, trying to solve intractable human problems with technology.
That's right. I'm Ned. I'm a data science engineer at ThoughtWorks as part of our data and AI practice, where we help our partners design and build data products and also uplift their data strategy to make more effective use of their data. And over my time in my data career, I've come to the conviction that we need to take a step back from the decision-making coalface and reflect on how we improve the quality of our decision-making processes.
I'm not a data scientist, but or a data engineer. I do love data, and I was looking here and going, oh my goodness, maybe that's the new version of the only language I'm endorsed on LinkedIn for, which is Fortran, which tells you a little bit about my age, but very disappointed it wasn't. For my sins, a former executive. So I worked at REA Group. I was the CIO and head of research and development. I worked at Lonely Planet as the head of technology there in the last 10. I've spent a lot of other people's money trying to figure out what to do with strategy. So startups, scale-ups, and a number of screw-ups along the way. Social scientist, a behavioral economist kind of thing, which means I talk fast and wave my hands well. You know, social scientists are the ones with the worst reputation, a complete inability to repeat any experiment we create at all. But I am most fascinated by the ethics and the political dimensions of data, the things you create and the messes I get into as a result.
Right, let's jump in.
Yeah, so the stakes are considerable. That's what I've learned in my career. And I go back to going to America in 2000, probably the dot-com revolution was fantastic. An Australian company, a startup called ePredicts, and was in the field of psychometric testing, which is really, you'd call it AI today. It's just called statistics back in those days. What we were doing was building incredibly predictive algorithms about who would make a good software engineer, bus driver, nurse, truck driver, all those kind of things. And using data, vast quantities, 40 years of data sets. And the psychometric tests, 5 factors. You probably know the 5-factor model and algorithm. It's extroversion, neuroticism, agreeableness, conscientiousness, and openness to experience. And combinations of those will predict who's going to make a great employee. And those are 2 case studies I'm quite familiar with, not responsible for, but quite familiar with, where Kmart, bankrupt twice in 40 years, went from a massive company to a very unsuccessful retailer. Not coincidentally, they had changed their employment. The 5 factors, they'd reweighted for the managers a little bit more extroversion and a little bit less conscientiousness to try and get them to sell more. And the resulting kind of behavioral changes were massive. Two bankruptcies. Wow, that was an interesting thing to observe. And then in my time in America, and Wells Fargo were a client, they adjusted famously their algorithm to get a little more extroversion and help their tellers sell more accounts. And if you Google that one, you'll know how that turned out. How about you, Ned?
Yeah, well, jumping onto this other example here, this one might be, maybe some of you had some experiences with this one. This is the, like to some degree, hopefully not too much, but this is the shiny new data platform that's been envisioned to pull data from across your organization, clean it, curate it, make it available for everyone to consume, self-serve to their heart's content. But over time, it's become a dark and murky data swamp, and people are making ad hoc tables, extracts, the provenance and context of which are unclear, and we're starting to see lower trust in data. So how did they get this way? Well, there were probably, just like in Nigel's scenario, lots of decisions made along the way or not made that helped contribute to this situation. So
I think the stakes are high for people in this room. Not as shiny as an ab's view of an incredible data structure, is it at all?
So when it comes to making decisions, we want to ask you a question. Which persona are you? When you need to make a decision, which record do you put on? Do you put on Mary Curie, the scientist, or do you put on Kenny Rogers, the gambler? Now, I suspect that a lot of us here are probably going to align more with the scientist persona. We value gathering data, experimentation, measuring uncertainty, A/B tests, thinking slow. We'd rather not align with the gambler, someone who maybe gets high on making high-stake bets in the face of radical uncertainty. But Nigel and I want to challenge this perception. And I guess to do that, think about an expert poker player. In order for them to be successful, not only do they have to master the rules of the game, but they also have to make fast-paced decisions under uncertainty, where they're balancing their investment with their risk. And so there's a lot of parallels here with the practical realities of driving and supporting an organization. We don't always have the luxury of being able to rigorously de-risk every decision. Making decisions under uncertainty is inevitable, and sometimes we do just have to think fast. Now, we're not trying to convince you to put on a waistcoat and sit down at the casino. What we are trying to argue is that poker players have a lot to teach us about making decisions under uncertainty.
There's a lot of people in the room in their heads going, you got to know when to hold them, know when to fold them. And that's probably all they'll take away from our talk now, Ned.
Right. But before we get to that, we want to talk a bit about some of the types of decisions that we're involved in as data practitioners.
Yeah, and this is me. This is my realm. We put out the bat signal for the scientists to come and the engineers to come and save us with some data. Part of the problem is we did enough a university to be dangerous. We actually are quite enamored by the science of probability, for example. So I've spent my 20 years as an executive in organizations asking people like Ned, well, Ned, what's the damn probability? Give me the probability of this market coming back before next year, and then just pressuring you into going 62.5% and me believing that. And that harnessing of data to make business decisions is a real problem area because the stakes are so high. I'm asking you to think fast. And, you know, as someone famously said, predictions are hard, especially about the future. So if I think of one particular example I'm involved with, you'll be able to pick who it was with. Our nightmare, our problem running this giant, multi-billion-dollar business was trying to predict the volume of the sales that we were making. All we wanted to do was figure out how many houses would come onto the Australian market for sale next month. 6 data scientists and a team of engineers, 9 months, $1 million, 3,000 variables, and we're so excited as the executive team, we're going to get the answer. We can now steer our ship for hiring and advertising and all these things to match our exact market. No result. Now that's not unusual, but in a world where we wanted to offload our sense of uncertainty and our discomfort with navigating without all the data, we did put a huge amount of pressure on data people. And I think that's taxing for data people. There's a bit of a history to this, right? It's like 2,000 years ago, the Greeks were going off to the soothsayers to try to find out from them what on earth was going to happen in the future. So executives have been doing this for a long time. And it is to do with our discomfort with uncertainty. We would rather invent certainty and live with the consequences than say, I don't know. And we've been doing that for a long time, whether it's the Greeks or whether it was simulmatics in the 1960s. That's the forerunner to Cambridge Analytica, trying to figure out what election results will be. And when working out there were correlations, trying to influence those damned elections. Trump would have loved those people. But that the unburdening of an executive mind onto your mind, so you bring logic and probability and data to the table, it's very appealing to me. And so I guess I'd probably say, don't do it, especially in these increasingly volatile, uncertain, complex, and ambiguous kind of times. That I don't know is much more the answer. And I love Dr. Linda Hill's work, a good podcast on being data-driven, which is what I hear it still today. It's the embarrassing thing. I go into executive meetings, we must be data-driven. Linda Hill says, no, data-informed is a much better thing. And the politics of this have become considerable because to be data-driven sort of takes all of the responsibility outside yourself. And hey, data-driven, I sound way cooler than you. And that's political. That's me. And I'm offloading that onto Ned.
And so more recently, we have the alluring account of Moneyball, the story of Billy Beane, the general manager of the Oakland Athletics, who brought data and metrics to baseball for the first time, transforming an underperforming and under-resourced team into a powerhouse.
We all want Moneyball as executives, I can tell you that.
Right. So the appeal for execs, and I know they've all watched it. You've got it on DVD, don't you?
No, I have it on VHS, young man. I'm a boomer.
The appeal is that there's low-hanging data fruit just sitting out there that we can pick up and start getting an immediate competitive advantage. But of course, the reality is, just as in baseball, this has just become part of the standard playbook. And if we're not already using data to inform how we make decisions effectively, we need to start just to catch up.
There's a data engineer 100 years ago, a guy called H.L. Mencken, a very cynical guy, said, for every complex problem, there is a solution that is clear, simple, and wrong.
So this brings us to the second type of decisions that as data practitioners we're involved in, and we might, people in the room might relate to a little bit more here. This is around how we make effective use of our data to support our organization's North Star goals. So as data teams, our mandate is to empower folks to make their business decisions with timely, relevant, and accurate information from teams like product analytics, partnerships, sales and finance, growth. And it's also, often to enable data science engineering teams with the infrastructure, services, and data required to build high-quality data-powered products. So,
Wow.
as data practitioners, we need to make decisions all the time about how we design, build, and run the information factory that meets the needs of our organization. Here are some examples of concrete decisions that we might have to make as data practitioners. Which data warehouse should we use? Do we need a streaming platform? If so, which one? Which BI tool should we standardize around? Do we want to jump on the analytics engineering bandwagon and adopt DBT? What about our data science teams? Which ML tool should they use, PyTorch or TensorFlow? And what about MLOps tools? Do we want any of them to help improve the way we manage the lifecycle of ML products?
We know the correct answer, whatever looks best on LinkedIn.
That's it. Resume-driven development.
Yep.
And then, I've heard about this metrics layer thing. Do we want one of them? And of course, cutting across all these decisions is the perennial, should we build or buy? Now, these are important data strategy decisions. We saw before with Zainab's talk, that spaghetti mess that we want to absolutely avoid. We really do want to build it once and build it right. But getting it right is hard. Up here we're looking at, evidence of the fact that we've seen a Cambrian explosion of tools and services in recent times. This is Matt Turk's ML, AI, and data landscape of 2021. And well, look, it's amazing that we have such a large range of tools and services to choose from. But with many of them offering nuanced feature sets, different trade-offs, strengths and weaknesses, it's not always, well, it's often the case that some are going to be better fits for the needs of our organization and our current tech stack than others. And we also know very well that implementing these things, even just adding a new service to our current stack, takes a lot of considerable time and effort. And there can also be a path dependency to these decisions. Earlier tooling options we might choose may kind of rule out or make other ones that turns out we'd prefer harder. So all these factors combine to mean that we can't always take as rigorous an experimental approach as we'd like when choosing tooling and architectures.
I did enjoy on Zanab's slide that at the end point, there was a Microsoft Excel spreadsheet. As someone who grew up doing this entire thing in Lotus 1, 2, 3, this explosion is incredibly difficult. And the part of the drama is social science, is that how dumb do you feel when you chose the wrong thing and you go down a dead end, or you buy into something and then Amazon Web Services offers it for free the next year and you have to ring up your open source mates and go, sorry, we can't buy that anymore from you because Amazon's chucking it in. Bless them.
Okay, so we're jumping to another type of decision here. This one's around data strategy supporting product strategy. And so this is one that I'm seeing coming up a fair bit, where people are asking, hey, could we use a chatbot to improve our product? And it's a compelling thing that we might think about because, text generation technologies have come a long way in the last few years. We've seen these massively, performant large language models producing quite fascinating and impressive output. But there's a bit of an unsolved problem that we have, which is around preventing it from hallucinating complete fantasy and also, spitting out abusive content that we don't want to expose to our customers or, let alone anyone. So we have some examples here. Here we have Meta's Blender bot, where it's happily informing us that Trump is serving a second term. And it's also owning up to the fact that there's a whole bunch of fake news on Facebook, which is not really a great look for Meta or Facebook. This other one over here is a fun example. This has happened a bit recently on Twitter. A remote job board company released a Twitter bot that listens to people posting about remote jobs and then replying to something on topic of what they're saying with a sort of a chirpy, upbeat comment about remote work. People worked out, though, that what the bot's doing is having that tweet fed into the prompt of the language model in its entirety, so making it vulnerable to prompt injection attacks, kind of like SQL injection attacks. And you can get it to do all sorts of things. So here we have someone convincing the bot to make a false accusation about a US politician. And over here we have a pretty fun one. Someone's actually managed to convince the bot to spit out the initial instructions that it was programmed with, revealing the sort of, sensitive details of what's going on.
And so this is what happens when people with IQs north of 120 get tools like the data science tools we saw. Unbelievable.
Right. So all of this sort of really goes to show, in particular when we're adopting these sort of, quite exciting, shiny and, cutting edge ML and AI techniques, it's super important that we understand the pronounced risks before we make decisions about incorporating it into our products.
I love the way you type that, should we? Because I think that's a really good question, because most often I'm asking, can we? Or when can we? And you've phrased it perfectly.
So this brings us to our hypothesis. Now that we've talked about the types of decisions that we need to make and the importance of getting them right, we want to ask the question, how can we as data practitioners make better decisions? We want to embrace, we want to, be that scientist, and that's great. But Nigel and I are encouraging you to also embrace the gambler persona. And that's not because we should be reckless, YOLO important decisions and bet the farm, but it's because we think that poker players have a lot to teach us about making decisions under uncertainty.
Now, when we say our hypothesis, that's a complete lie. It's Annie Duke's hypothesis, which we love. Incredible author, an incredible story of a woman who left university, had an unfinished degree she needed to fund, and spent the next few years with her brother becoming a professional poker player. She then went back to university, did a PhD, and now teaches in a school of management, applying the rules of poker to the world of big decision-making and strategy. And it's a tremendous book.
Yeah, great book. Definitely recommend reading it. But why are decisions bets? I think Annie Duke says it best herself, so I'm just going to read from the book. By treating decisions as bets, poker players explicitly realize they are deciding on alternative futures, each with benefits and risks. Every decision commits us to some course of action that by definition eliminates others. So when we make decisions, we are betting against all future versions of ourselves that we are not choosing.
I'm disappointed she didn't say every hand's a winner and every hand's a loser, but then I am a music fan, so that would be me. And so the essence of it is this applies to both kinds of decisions, the big executive business strategy decisions and the incredibly important ones around data strategy. So let's have a look at what her hypothesis and our hypothesis, which we love as well, is that strategy is not about chess. Now, I'm guessing this is a room of chess players. I'm a chess player. I'm a slow thinker. It's very difficult for me to play poker. Everyone gets very annoyed. And so chess is a game of skill, and chess contains no hidden information, no magical movement of pieces from the board. The little black square doesn't hold up and your queen falls through it. There's no dice involved. If you can know enough, you can know the entire layout. Everyone knows the rules. It's a completely transparent playing field. And so it's really just algorithmic computation, which is why chess games, like the one that was on the homepage of our slide, why they became vogue decades ago. That one's a Tandy. You can buy that in the 1980s from Radio Shack in the United States. And there's always an optimal move in every situation from here. And so that effectively, you've got this tight correlation between your decision and the outcome, though that is well known after hundreds and hundreds of years of chess. Poker, in comparison, is still a game of strategy, but a game of luck. That you do not have all the information. The other players around the table are holding cards you can't hope to know. There is a random nature of what's going to come next to you, and it's rapid decision-making under uncertainty over time. It's risk, and you have to guess and include the other player's mental states into your estimates, which is, this is not sounding very attractive if you're going to try and put that into a formula on a computer. You can make the very best decisions and still lose. You can have a crappy hand of cards and win at poker. And these are some of the things we think really do start to apply in this kind of decision-making. So you'll know that a computer program that could beat Annie Duke, for example, was really not in the market until very, very recently, which explains that sort of volatility, uncertainty, complexity, and ambiguity angles of playing poker. So, decision-making, not chess, poker. You're all going to be getting a little poker app so you can practice your decision-making.
Yeah, so let's lean into that a bit more. Because when we're making strategic decisions, we almost never have complete information. We're making decisions under uncertainty. Because just like in poker, the outcomes of our decisions are based on skills, which is to say the beliefs we have about the world, and also luck. Our strategic decisions don't play out on the vacuum of a chessboard, but rather they're enmeshed in a dynamic and messy world, which we largely don't have control over. But that's not to say that we should just give up and roll the dice. There's things that we can do. We can improve our skills, which is to say better calibrate our beliefs about the world. We can also get better at understanding and measuring the uncertainty involved. And when it comes to assessing the quality of our decision-making, we can also disentangle the role of skill and luck so that we don't confuse the outcome of a result of a decision we make as being down to good decision-making skills, when actually it could have just been a result of good luck. So let's dig into this skill versus luck thing a little bit more. So I want you to imagine that you're on a data team and you've made a few decisions that unfortunately haven't really panned out that well for you. So let's think about, in these scenarios, how much the role of skill versus luck came into play. So scenario one, after a whole lot of research, experimentation and research, you've gone all in on an open source data processing tool. Unfortunately, after about 12 months of using it and enjoying it, you're starting to see that the industry is a little bit less excited about this tool, and also there's some warning signs about the health of the open source project. What do we think about this situation? Skill or luck? Is this something where if we'd put more upfront research into the backers of the open source project, we could have seen those warning signs up front? Or is this just one of the inevitable risks of sometimes adopting an open source project? Scenario number two, you plan out the next quarter of work for your team, committing to a chunky investment in upgrading and putting some enhancements on your data platform that are much needed, only to find 2 weeks into the quarter that there's a new product feature going live and your data team is urgently needed to support it, so you have to drop work on the upgrade. What about this scenario? Is this skill or luck? Well, maybe if we'd had better communication internally and we'd known that this feature was coming up, then possibly that was a problem of skill and information. But also, sometimes this is just sort of one of the risks that we take on working in a fast-paced product company. Scenario number three, your team adopts a new vendor solution your team adopts a new vendor solution needed for a crucial data product, only to find after 6 months of development that it turns out it's missing a crucial feature that you need, making it not fit for purpose. So you have to go find another tool and do a whole bunch of rework for the integration. How do we feel about this one? Skill or luck? I feel like in this case, this is probably more down to the skill side of things. I think, it's, as we all know, it's important to do rigorous requirements analysis up front, but I'm sure there are folks out there who have been in this situation who really just unfortunately had to learn it the hard way.
I think you've scarred a few people, Ned, with that. Like, go, how does he know about my business? How does he know about my team? But I think a really good way of getting back into that poker mindset is let's do a little game. So what I want you to, and we're going to try and get a few poker skills along the way here. So what I want you to think about is, what is the worst decision you made in the last year? The worst decision. Just have a think about that for a couple of seconds. Go, yeah, that was a dumb one. That was terrible. I shouldn't have done that. That's good. Okay. So now, don't tell your neighbor, because we don't want to embarrass anyone, all those kind of things. But I'm pretty confident what you've actually done is figured out very quickly something that turned out really badly. So my worst decision of my life was to marry my wife. Now, it is the best outcome of my life. 35 years later, our success as a family with travel and, all of the things that, textbook fairy tale stuff. Incredible outcome. That intuitive, instinctive, dumb decision by a 24-year-old with no context, and we were married within 6 months of first meeting. That's a terrible decision-making process that I counsel my children to not do. And that's Annie Duke's point. That's called resulting. You're associating an outcome with the quality and skill of your decision. And when you're a poker player and you have a bad outcome with your cards, you take that, oh, I'm a shit decision maker, I'm a terrible poker player. You take that into the next hand, which is only happening 2 minutes later. And we are all doomed to do this. And it's key in separating these two in your practice as data engineers to learn to separate those two things.
So, why should data teams think in bets? Well, as we've been arguing, this is effectively what you're doing when you're making a decision. You're putting resources on the line and committing to one course of action against all the other ones. In effect, you're betting against the alternative, the future versions of yourselves that you didn't choose. But what are the benefits of leaning into this framing? Well, first of all, it encourages us to bring data to the table when we're making decisions. It also requires us to make explicit and socialize our uncertainty, which is, keeping us honest. And it also helps us to match our investment with the degree of risk. It also helps our team learn more effectively from the outcomes of our decisions. We're better able to see when a positive outcome is the result of skill rather than luck. And also, another one is that bets can be readily aligned with your organization's North Star goals. When adopted holistically, a structured framework based around making decisions as bets is a powerful tool for promoting organizational alignment. So Nigel, how can we get started?
Well, 3 cards. I think we should give our players 3 powerful cards to hold. And first card is from Annie Duke. And it's Annie Duke's inspiration to a little company called Spotify, who needed to reset the way they made business decisions. They needed a level playing field. They needed some new letters because they used to have Hippo as their decision-making, the highest paid person's opinion. And they needed to level that playing field. And what they did to avoid the waste they were experiencing around decisions was implement DIBS, which is hard for a Kiwi to say. It sounds like dubs, that's music, DIBS. Data, insight, belief, bet. You want something to get on the slate, whether that's a data science project or some product feature in the consumer side of their apps. You need to present this. What data have you observed that you think is relevant to the case? And what's your insight? So the humans don't go away. It's not all handed over to the robots to have the insights. This 3.5 inches becomes useful at this point to go, you know what, and the case they particularly talk about, they have many, is noticing in the data of the users in 2016 that users were migrating from desktop to mobile. The insight was, wow, if that continues, we have so few mobile developers, we're in trouble. The belief, the hypothesis, and maybe a number they could switch was, do you know what, we better get started on this. Recruitment's going to be hard in New York. Why don't we see if people are willing to change their careers through training and development? And we'll know it if we get actually people, our own people applying for mobile developer jobs. And the bet was they would run a course with people having time off, able to invest in new skills. And the learning loop would be, let's see what we learn from that. So they ran a first tranche through. And I've seen it used in a number of different places now. This is a very sensible methodology for figuring it out and how things could work.
So let's make it a bit more, relatable to folks here in the room, bring it home a bit. Let's imagine we're a data team and we're going to make some bets using the DIBS process. So let's jump in. We'll start with our data point, which is that it's taking a whopping 150 hours a month to produce some consolidated product reporting. And we're getting periodic issues of reports of inconsistencies in these reports. So that's our data. Our insight is that this is costing us money and opportunity costs for doing more high-value work than Excel wrangling, and that all that manual work is causing these issues in the reports. Our belief is that adopting a new reporting tool that has more automation involved is going to reduce the amount of time it takes to make these reports and also help fix the data inconsistencies in the reports. So that then informs our bet. Well, the belief. Wait, which one did I just do?
I think you had a hypothesis.
I had a hypothesis. Yeah, cool. So our bet is that we're going to trial a thin slice of one of the more complex reports, committing 3 people from our data team and time from 2 product analysts for 3 weeks.
It so resonates with me, this case study, because so many times I've had a colleague at an executive level go, what we need is a dashboard. Can you get your data scientists to produce an incredible dashboard? And you know what? 99% of dashboards I've seen ignored. And it's a tragedy. It is an incredible waste. So what's the loop back of that?
Yes,
I guess.
So let's fast forward in time. We've done the trial. We've run it for a couple of months. We're ready to do this learning loop and actually feed back the outputs from that bet into the next loop. So the data point from that is going to be that it turns out that this new report is actually reducing the amount of time. The new reporting tool is reducing the amount of time it takes to build. But we're still seeing inconsistencies in the reports. So the insight that we come from that is that the reporting tool is great, but we think that the data quality issues are coming from upstream in the data warehouse. So our belief is that uplifting the data modeling process in the warehouse is going to help address these issues. The bet we're going to make is that let's commit a squad now from the data team and time from those analysts to uplift the tables needed for modeling for that report into DBT. So hopefully you're getting the idea of this process. We can imagine if we went to do a third time round, we'd make a bigger bet and try and bring all the reports into DBT and the new reporting tool.
Yeah, this is definitely our Queen of Hearts. And Spotify call it a framework for an argument.
On to card number 2 for you to hold. Something you might have picked up on the previous scenario is that as we went through the loop, the size of our bets increased each time. This is because with each iteration, we get more data, which feeds into more insights, which increases the confidences of success. Just like in poker, we need to adjust the amount that we're betting based on our confidence in our hand. We can summarize this as the maxim, make bets that are proportionate with your degree of uncertainty. So Nigel, practical point, and I think we need to be quick.
Yep.
How can we get started?
So the simplest thing is that this is all about behavior and culture. This is where the social scientists overlaps in this talk, is that if you want to start working in this kind of way, start using the language. The language is the pivotal part of a new culture of thinking in this way. If you are in a place that's psychologically safe to say, I don't know, you're starting in a great place. But just by pitching this as I don't know, but here's an experiment we can do, you change the game. And you talk about doing, this is a great axiom, because I've spent my career making the biggest bets at the point in time I had the least amount of information, whether that was M&A or otherwise. And yeah, look, if you can actually imagine yourself talking about bets in your organization, then that's your simplest of starting points.
And on to card number 3, our final card to offer you. As you repeat your decision-making process, the outputs from previous decision feed back into new data into the next iteration. And this, but in order to do this effectively, we need to cultivate the ability to distinguish luck from skill in order to push the right feedback back into our learning loops. Now, there's other names for these types of learning loops. As Nigel can tell us, in Lean, we have plan, do, study, act.
Yeah, and William Edwards Deming, famous for saying, in God we trust, all others bring data.
And in Agile, we also have the idea of validated learning. And a question some of you might be thinking was, well, isn't all of this just Agile? And yeah, I think in a way there's some truth to that. But it's a different way of framing the iterative value-oriented process.
Yeah, and this is good Agile. And unfortunately, the world's adopted all sorts of other weird acronyms, and it's not good Agile. This was the intent of the founders of that movement back in the 1980s.
So we argue that by adopting a structured approach to framing our decisions as bets, it forces us to bring data to the table when making decisions. It forces us to be explicit about the knowledge and beliefs that informs a bet, while being transparent about the uncertainty that we hold. And doing this keeps us honest. It means that we're less likely to misattribute good outcomes from the result of a good decision when it was actually just luck. We strongly believe that if everyone leans into this approach, it will start to change how your teams and your organizations make decisions for the better. And it also offers a practical on-ramp into how we can actually start to become the learning organization that we all aspire to be.
Well, not much left to do, Ned, other than send you out into the world to go and place some bets, I guess. And you're lucky you're placing bets with other people's money. It's quite uncomfortable when it's your own money in startups. And look, here, actually, I love this. This is code from GitHub of one of the first open source poker playing very complex algorithmic solutions to doing it. So it's taken a long time to happen.
So remember, everyone, the 3 cards that we've given you to hold. 1, think in bets. Use a structured framework like DIBS. 2, make bets that are proportionate with your degree of uncertainty. And 3, calibrate your beliefs by pushing the right feedback into your learning loops.
And a little bit of extra homework there too. Lots of our own books there, like just call out for ThoughtWorks. You probably, if the t-shirts don't have it on the front much, but come by, have a chat there's a chance to win Shamark's book. And these are lots of my kind of weirdo things from the past that I've read that have been very inspiring to making the work that you do land for the most effect and the least waste in the organizations you work for.
So thanks very much for listening. And yeah, would love to get your feedback and any questions if we have time.
Thank you, Nigel. Thank you, Ned. As you walk off the stage, you'll have the opportunity to do Q&A with the both of you during the morning tea and lunchtime sessions and afternoon tea. Whatever you do, don't accept the invitation to play poker with either of these two men, though. That's going to end in failure. Thank you again, guys.
Thank you.
All right, so I hope you're feeling energized and ready to go. After this next speaker, we'll be breaking for morning tea, and so we'll have an opportunity to stretch your legs, get recaffeinated, and then come back in for the rest of the morning session. So right now, what I'd like to do is introduce Jinwei Jiang and Akira Wang, both of whom are from data engineers from Afterpay. Jinwei did her master's at ANU, specializing in data processing and AI, and enjoys hiking and boxing in her free time. And Akira is a gamer, and she's his favorite footy team,
Collingwood.
Magpies.
Yeah.
So what's the not too much support there, but anyway, I'll hand over to you.
It is what it is. Thank you. I just wanted to say, I guess we do have a bit of time, so if you actually just want to stand up and stretch just for this final speak, we've got a minute or two to spare. So feel free to do so while we get started. Cool. So yeah, give you a couple seconds. Now, feel free to stand up. Yeah, give yourself a stretch before the break. All good. We've got time to spare. I'm sure we're all a bit old and just want to, stand up a little bit. Yeah. No rush. Keep it chill. Keep it easy. All right. So while you're stretching and starting to sit down, welcome to our presentation on a metadata-driven framework for data discovery and data trust. I think our thing's not working. Maybe it's the other one. We'll see if this works. Beautiful. All right, I guess we've had the intros, but once again, I'm Akira. I'll be talking about data discovery. So Jinwei should be talking about data trust. So let's go through some of the well-known stresses of data. For example, what data do we even have? And likewise, can we even trust this data? I'm sure our fellow analysts and stakeholders, they probably ask themselves this question every day, right? So we thought, okay, why don't we help them? So welcome to data empowerment, which is the outcome-focused data management. And for us at Afterpay, this is to help data consumers find the data easily and ensure that they can actually trust the data. Now, because our team was relatively new, let's say 4 to 6 months ago, we've had two sizable challenges that we've faced. The first being limited time, right? We've got all these users and analysts who are suffering these problems every day. They need a solution now and not 3, 4 years down the track. And likewise, resource constraints. And actually, for the past 4 to 6 months, the team has really just been me, myself, and I. Jinwei and Nam, shout out to you guys. They've helped us from time to time as borrowed resources. But yes, that means our approach had to be efficient. And that is, we're going to reuse what we have and build what we don't. So let's go through the technical architecture at a high level. Very standard pipeline. We've got our source system, which then goes through ELT jobs to bring the data in, dump it into a data warehouse. We've got some data consumers who use their BI and SQL clients to run their queries. Now, when they have questions, and they always do, right, they go to Slack. If you've never heard of Slack, it's our method of communication. Think of it as an alternative to Microsoft Teams. Now, we do have source data, let's say subject matter experts, but they only answer questions on a best effort basis. So I'm sure we all know most of the time, in fact, all of the time, it's us to ask poor data engineers to answer these questions on our very busy schedule. So we decided, okay, we need a process to automate or help automate the answering of these questions. So we decided to create a metadata collection DAG, which uses Python, Spark, SQL, and Airflow. And to kickstart off this DAG, we decided to grab all the metadata from our data warehouse, which is Redshift. So we hit the system views. Now, because it is, let's say, a bit intense in computation, we hit it at night where it doesn't really impact other critical jobs. We then grab all the job statistics from Airflow, the metadata database in the back end, and we grab things like performance, runtime, schedule. Were there any errors? Awesome. We've got some basic metadata and statistics. But now we've got all these Slack questions, and we're like, okay, how do we automate the answering of these questions, or at least make our lives a bit easier? So, things like, Where is the data? When is it available? Who knows about that? So many questions, not enough time to answer. So we decided to create a Slack analysis DAG, and I'll talk about it in the next slide. But for now, just take my word for it. Now, this DAG then dumps everything into a central metadata database, and it's in Postgres, mostly stored in third normal form, and hopefully anything can integrate with it. It's interoperable. And then we reach our final goal, a Munson, the great explorer. But some of you are like, okay, well, what is a Munson with respect to, let's say, technology? Well, a Munson is an open source data discovery metadata catalog platform. And why did we choose it? Well, if we go back to our approach before, it's to reuse what we have and build what we don't. And now we just had a Munson sitting there at Afterpay as a proof of concept image. And we're like, okay, we don't have time, we don't have resources. Why don't we just experiment? Why don't we hedge our bets on it, let's say, right? And so we chose it. And the cool thing about a Munson is that it allows users to search for data, and it uses Elasticsearch. They can search for any table, any column, schema, and so on. And even better, it allows us to crowdsource data, right? You can allocate data owners on a Munson, and then it's up to them to fill it out. All the stuff that's stored in their brain or on a Confluence page no one reads about, we can chuck it onto a central location for everyone to see. And that's one of the key features of data discovery. And to top it off, we can also open up our central metadata database to integrate things like BI dashboards, let's say using Looker or Tableau. And you can open up APIs to other apps to use as well. So it's not just for us, but it's for everyone. Awesome. So somewhat, data consumers are happy, they've got their questions answered, and hopefully they're empowered to do the work. So let's talk about the Slack analysis DAG at a conceptual level. Right? And this is to automate the answering of questions because we hate answering these questions, right? It goes through our busy schedule. So rather than asking users to fill in a quarterly survey, like, how long did you spend on average getting your questions answered? Did they even answer your questions? We're like, okay, rather than wasting the analyst's time, we'll just automate it. So we decided to grab everything from our data support channel, which is hashtag AP data support on Slack. So grab all the latest questions, all the latest threads, whatever. And then we apply some very simple natural language processing. Things like, okay, categorize the type of question. Is it to do with an error? Is it to do with where is the data? When is the data available? All those kind of questions, right? And then we also apply some regex to extract some objects. And an object that Afterpay is any table, any view, any schema, column, database, and so on. We extract all of that information. And then we apply a very simple tagging and matching process back with our central metadata database. And this allows us to connect any data support question to any user who asked it to any object in our whole system. So it's pretty neat. And one of the key results we get is a simple dashboard that anyone can use, even up to the leadership team. And that's to prioritize metadata collection based on usage. So on the left-hand side, you'll see there are object priorities and the number of questions asked in Slack. And hopefully you can see a very simple solution already, right? Which is, okay, this table or this object has been asked 33 times. Why don't we prioritize the metadata collection for this table, right? Because the more metadata is available for everyone, hopefully the fewer questions will be asked. We definitely hope that's the case. Likewise with the problem categories, right? Let's go through knowledge as an example, right? A big chunk, 76 questions asked since February. Why don't we prioritize allocating data owners, filling in column descriptions, filling in table descriptions, so less people ask, who knows about it? What is the data? And so on. So to tie data discovery together, I just wanted to go through business as usual day at Afterpay using Slack and a Munson together. The first scenario, got an analyst going, hey, I'm trying to join these two tables together. What's the business logic? Who knows about it? And then you've got an engineer who responds, okay, here's two links to a Munson, just like that. And in fact, a Munson displays information about the most frequent users, like who queries the table, which analyst does that. So we tag those people as part of the data support thread as, let's say, additional support or future reference. And in scenario 2, we've got a self-service check data command. So analysts can go, okay, check data, input schema.table name. They get back the latest data quality checks, as well as a hyperlink to a Munson for the latest metadata. So let's go take a look at the Munson UI, shall we? Here we go. Now at the very top, you can see the search bar that uses Elasticsearch. Search for anything you want, that's available. And just below that is a preview. We've got the schema.table name. You can bookmark your favorite tables or views. There's a few badges. I'm not sure if you can read, But the top one on the very right is a view. So this is actually a view that we're talking about. Below that to the left, we've got programmatic description fields. So free text description fields, anyone can change an input, and we track those changes. There's also a metadata score that we've invented, as well as hyperlinks to Anomalon, which Xinwei will discuss. But the cool thing is, we've also got information on our Slack data support. For example, we can actually see that this view that I've got right here has appeared in our data support channel 46 times since February, and we've also hyperlinked the latest thread, right? Because the people who are interested in this table should be kept in the loop, right? They want to see the latest questions asked. On the right-hand side, we've got information about columns. In fact, we've got 73 columns in table. Each column has a free text description field where applicable. We've got things like data precision and data types, as well as badges. Was this a partition column because it came from an external table? Is it a joining key to another table? Things that, a lot of this stuff we don't know, as well as, let's say, business date keys, all the useful information. So that's data discovery in a nutshell. Hand it over to Xinwei to talk about data trust. Here you go.
Thank you, Akira. So now we found data in our Amazon and did some data discovery work. The next question people will ask is, can I trust this data? First, we believe transparency builds trust. In our framework, all the metrics or data quality checks are transparent to our user. If we keep all the metrics within the engineer team, then in the future, all the requests will come to the engineer team. This is not scalable over time with business growth. Then our second idea comes out. Data quality is everyone's responsibility rather than only engineers. However, sometimes it will turn out to be no one's responsibility. So in order to decentralize our data quality check and derived from research published by DAMA UK in 2013, 2 types and 6 dimensions are applied into our framework. The first type is operational type. It contains timeliness, completeness, and uniqueness. Those 3 dimensions are usually static, and our engineer team is responsible for those 3 dimensions. Based on our ETL jobs, our engineers can easily measure whether all data is refreshed and available on time, whether all received data is ingested into our database, and they also can check the unique value for the primary key column. The second type is business type. It contains accuracy and consistency. So those 2 dimensions are usually changing over time with business growth, which means our data consumer is responsible for those 2 dimensions. The 6th dimension is validity. It is a shared dimension across operational and business. Our engineer can have some validation checks on data types or non-value, and our data consumer can have their own validation checks based on their own business rule. Now we know that everyone can have a data quality check. The next question will be how we can create data quality check. Anomalon is an existing tool in our company, and it perfectly fit our purpose. First, it has a very simple UI. Our user can easily create their data quality checks through ClickOps. And it also has a lot of user-defined key metrics and validation rules. So the key metrics are the checks that monitor the key business metrics. For example, column sum is not anomalous. Column 0 value count is not anomalous. For the validation rule, it is the check that are the expectations about data. For example, column value fall into a range, or column is always greater than another. The third key feature is the automated data profiling. Before our user to use the table or design their own data quality check, they can always go to the Anomalon UI to see the table structure and check some sample data. Last but not least, our API connectivity. All the data quality checks can be created or updated through Post API. And also in our framework, we rely on the API to collect all the rule details and check results. So here is some example. This is a UI about how we can configure a table on Anomalon. Basically, we just need to fill in a description, set the schedule, and also pick a date column if you want to run your check based on certain date, and also pick the notification destination. Then all done, and then 8 automated baseline check will be set up, which fall under our operational type. In order to store all our metadata into a central database, API and Python SDK can be used in our ETL processes to collect all the root details and check readouts. Here we show how we integrating Anomalous with our framework by using simple API connectivity. When ETL jobs ingesting data into a new table, a post API can be used to configure a table on Anomalous, and then our metadata collection DAG can use a GET API to collect all the root details and check readouts and store in our central metadata database to connect the dots between the data quality check and business context. So here are the 8 baseline checks in Anomalous. So data freshness for timeliness dimension, data volume for completeness dimension. It also has check on missing data table anomalous. Our Anomalous also offer a lot of different metrics. For example, here we have row counts, column unique values. Anomalous also provide a lot of information on the field checks. In this example, you can see the green area is the prediction interval, and our actual value, which shows in red, is much lower than the prediction. Then there might be something wrong, and we have to do some investigation. And our API will return the same information. It told us the check was failed and which column caused the issue. Now we addressed the data discovery issue and the data trust issue so far. The next challenge is how to measure how well are we doing. Then a concept called the weighted score come into our framework. The weighted score for data discovery is the metadata score, which measure the completeness of the metadata fields. And for data trust, the score is the total number of field checks versus the total number of checks at an object level. So let's do some math. So a score at a high level is a metric between 0 and 100. For data discovery, the metadata score is a weighted sum of how much metadata is available, and the variance is the portion of non-metadata fields over the total number of metadata fields. For data trust, the score is a weighted sum of how many checks passed, and the variance is the portion of the number of field checks over the number of total checks. This is the dashboard we are using right now. This is the metadata scores. In this example, you can see that the object metadata score is 55.86, and it measures how complete is the object metadata. And our overall metadata score is calculated from the source score, object score, and column score. We hypothesize that if the score goes up, then our user can find more data easier. And we also have the historical snapshot of the score over time to monitor the long-term trends. And we also can measure our team's progress by KPIs and also assign KPIs to other teams to improve the metadata scores. So, and integrating our framework with the low-level detail from Anomalous, a high-level insight will be provided to the leadership team, and our data quality score can be used to help to set the goals or objectives. In this example, you can see that most of our scores are around 100 or 99, which means we're doing things right. And if the trend goes down, then which means there must be something wrong and we have to fix it. So before I talk about our big wins, I just want to emphasize that we just start our work 4 months ago. So our first win is around 30% of data-related questions we can use Anomalous and Amazon to answer in the past months and save a lot of time to investigate. Our second win is over 1,400 metadata fields are collected. And our third win is we enhance the user experience with transparent data metrics and self-serve capabilities. This is our future roadmap. A lot of interesting improvement and amazing projects are waiting for us, such as context-driven search, predictive model, and metadata chatbot. So if everyone is interested in our team or keen to know more information, please see us at the booth, and we are waiting for all of you. Thank you for listening, and this is our presentation. If you have any questions, feel free to ask.
Thank you so much for that. That's been amazing. One very quick question about the metadata that you're capturing. Is there a way for you to also capture whether this is a personal identifiable information or something like that, or is it just going about the data as the whole stack?
I don't think that's something I can answer right now. If you want to head over to the booth, I think someone can talk to you about sensitivity-related information, if that's all right.
Sure, thanks.
Thank you.
Great presentation, both of you. That was fantastic. I'm interested to know with your usage of Amundsen, I'm assuming that it's not purely metadata that populates it, that you're also enriching data through users adding in their own data. How do you find users being able to do that, encouraging them to do that? Often it's not something that they'll benefit from, it's the other person that will benefit from. So how do you encourage them to enrich that data so it's useful to the entire organization?
Yeah, I can answer this one. So the thing with the Munson is that it's just any tool that sits on top of our central metadata database. So if it disappears, first of all, it doesn't really matter. We just plug something on top. Now, in terms of what metadata has been added, there's an underlying Neo4j database. So it's a graph database, and we can actually export that stuff. We can capture it through an API and actually sync it back to our metadata database, and it doesn't take that much effort. Now, in terms of actually populating the stuff, generally speaking, right, it's for the analysts. At the end of the day, it's going to help them and the future people that come on board, right, the onboarders, because I'm sure we've all onboarded at companies like, oh my God, like, where do I start, right? So a Munson is their go-to. So generally speaking, the metadata they populate will be as accurate as possible from their knowledge, and it's going to benefit everyone. And so the ways we promote this is, first of all, we just send it to an analyst. If they ask a question like, all right, here's a Munson. If you find an answer from the frequent users of the table or you've talked around, please add it in for future. And in fact, that's where the 1,400 fields come from, right? They've just added in over time without us asking. In our future, we plan to do things like a hackathon, right? And it's kind of like, okay, you win a pizza, you spend a whole day just populating as much metadata as you can, right? And it's beneficial. It's a win-win for everyone. It's a win for us because, yes, we get more metadata. And it's a win for the teams because now they don't have a Confluence page sitting there in the archives, and it's just on a Munson. And if we get rid of a Munson, it's still in our central metadata database, and we can track all the history, all the changes, and who it was done by. Does that answer your question?
Yes, absolutely does. Thank you.
No worries.
How are you hosting a Munson? Is it just on a single instance, or are you hosting it like, are you sort of, like say, using Neptune or something, Neo4j managed or something like that?
Yeah, so to answer that, I'm actually not the infra guy. I'm the technical guy who does everything onwards. So if you want the infra stuff, please see us at the booth. I'm sure someone can answer that for you. Sorry about that.
Hi, fantastic presentation. Thanks for that. And how do you handle data linkage between the harvested metadata and the source systems? Because most of the times, the columns that that we have in source system and the way it get transported to different layers, it gets transformed and the name changes at this. So how do you handle that data linkage?
So I think data lineage by itself is a whole topic, right? I could spend a whole day talking about it. But in fact, if you want a brief overview, we do have a process to calculate lineage. And the cool thing about our process, I didn't have enough time to talk about today, is we actually have a process which updates metadata in a bidirectional manner. And we've got lineages for 93% of our engineering tables that we own. So for example, if you've got an upstream table and an engineer just populates one field, that will propagate all the way downwards. And the process we do is just very simple Python processing. We look at the DDLs and host it on Redshift and all that kind of stuff. And naming conventions are pretty important. Hopefully that kind of gives you an idea. If you want more talk, we can go to the booth and discuss it. Yeah, thanks.
Can I just follow up on that? How often do you run those jobs?
So most of the jobs are daily, but a lot of them are also just like run on a need-to basis because not many things update. But the things like objects and columns available, all that kind of stuff, that's just from Redshift directly. And if it doesn't work, it's okay if it fails one day because it's going to eventually be consistent. So it's not critical. Boohoo, if it dies one day, we just rerun it when we need to. And the aim is, hopefully it's eventually consistent because metadata is not always going to be, there live, right? It's impossible, I think. But eventually consistent, yes, very possible.
Another follow-up question to that. So is there like a scanning capability to just ingest the metadata from various key applications onto the central concentration?
Can you give her the mic if that's all right? Yeah. That's all good.
I just had a follow-up question to that. So is there like a scanning capability to ingest the metadata and the lineage from various key applications to the central repository? Because when you said that we can write jobs to keep on updating the metadata, because as you know, in today's world, it's so dynamic. We have so many technical implementations. There are database upgrades, and sometimes there are transition to the cloud platform as well. So personally, from my experience, like we find it very hard to keep the metadata in key systems consistent with what we have ingested in the repository. So just wondering if there is like a auto scanning system, and we can schedule the batch jobs and the metadata just keeps on uploading to the repository to be consistent with what metadata is contained in your key applications.
Okay, yeah, so right now, let's just say if it's a daily job, right? So every morning, just before the business starts for the average Afterpay user, everything's populated, all the lineage. It only takes a few minutes because it only updates when it needs to. And once it's updated, right, it doesn't really need to change, especially with the column descriptions. It's more of a once-off thing. So yeah, we do have a daily job that runs in the morning. And once it's updated, we have a history of it, and that's it. So I would say, yeah, it's not up to date in terms of live, but it is up to date just for enough for the users to do enough for the day. And we only just started, so for now, we think it's good enough. Yeah.
Very good presentation. Thank you.
Thank you. Any other questions? We can head off.
All right, a round of applause. Thank you.
Okay, I think that was very interesting conversations there, and seems like you guys have enjoyed it. We're going to take a break now, a tea time break now. We will see you guys about after 20 minutes from the tea time break. Please ensure that, don't forget to take your stamp cards, meet the sponsors, and have some conversations with them, because some of these guys that are presenting are also there at the booth. We will see you all at 11:35. See ya. Which one? Okay. Wait for one more minute. Okay. Thanks everyone for coming back and joining us now. I hope your tummies are relatively or a little bit filled up with some juice and some food. We do encourage you guys, like, people who are sitting in the back, please do come forward. There are a lot of seats here. You don't have to just hang by the wall and do anything like that. So I want to introduce our next speaker, Arpita Adhikari. She's in charge of establishing and leading a data governance function at ANZ Bank, where she focuses on effective data management practices and embedding data quality mindset and values in data practitioners for their everyday jobs. She enjoys practicing yoga and hiking and gardening in her free time. And let's hear from Arpita now.
Hello, everyone. Thanks very much for that introduction, and very thrilled to be here amongst you all and very energized by these exciting speeches so far this morning. So today, as I was listening to all the talks in the morning, there were few key messages which really hit to my core. And those are the ones that I just want to reiterate before I jump into data governance. So those three messages were: the importance of treating data as a strategic asset, how data quality is everyone's responsibility, and we need to measure what matters, and finally, organizations realizing that their aspirational data management goals are seldom met. So I want you all to keep these three messages in mind as we extrapolate and take it a little bit further as we learn about data governance. Now, data governance is an emerging trend in enterprise information management because organizations are soon becoming serious about the notion of treating data as a strategic asset. And this is so because there is intense competition to survive, and there is also enhanced importance in reporting from a single source of truth. Also, because of legislative mandates in Sarbanes-Oxley Act and Basel II, data governance as a topic has also gained prominence in practitioner conferences like the one held by the Data Warehousing Institute's World Conference and the Data Management Association's International Symposium. Research has evidenced that data governance is required for effective data management strategies. It is only by effective data management that organizations can ensure to produce good quality data, which can be measured by its accuracy, completeness, consistency, timeliness, trustworthiness, relevance, and having the right contextual definition. But studies have also shown that organizations which have implemented ad hoc data governance plans have witnessed their data management activities being hampered due to lack of clarity in roles and responsibilities and due to lack of mandate in pursuing data governance or data quality improvement initiatives. So today, the goal of my presentation is to introduce an overall data governance framework which organizations can use to design a cohesive data governance strategy, approach, and plan. A bit much, so how are we going to do that? Okay, so let us look at what are our key session objectives going to be. So first and foremost, we learn a little bit more about why we need to treat data as a strategic asset and what are the main barriers that organizations are facing to be able to do that. Then we learn about the need for data management as a discipline. Thirdly, we look at why do we need, what is the requirement for a data governance function in every organization? And last but not the least, we learn how to design a cohesive and effective data governance framework. So first thing first, data as a strategic asset. We have heard some about it in one of our previous talks already. To delve a little bit deeper, in today's world, where organizations are facing stiff competition, very smart cyber crimes, well, it's been in the news in the last couple of days already how there has been a major cyber attack in Australia just last week. Thirdly, because of the increased scrutiny from regulators. Because of these reasons, it's not sufficient for organizations only to know what data they have, but they need to implement proactive and robust data analytics and data management to gain important insights about their products, services, competitors, and the world at large. On the slide, you can see some of the benefits that in a recent poll, companies expressed that their organization will gain. And those benefits are also ranked here by the order of their preference. If you group those, the main benefits that the organizations think they will achieve when their data is treated as strategic asset are financial planning, analysis, reporting, improvement in overall data quality, improved employee morale, reduction in head count, as well as just understanding what data you have and becoming more competitive. Now, if organizations really believe that, then what is stopping us? Well, unfortunately, there are myriad of reasons. First and foremost, companies might have a very challenging system landscape. Overall, they might just have poor data quality. What that means is many companies are still using mainframe systems to capture their customer data. But in order to ingest it to smart GUIs, there are so many interfaces in place. Quite often it happens that the companies don't really understand their data lineage or data definition and how the data is flowing from the source to the ultimate point of consumption. And because of that, data integrity and data quality is often lost from source to the ultimate point of consumption. Finally, there is no consistent understanding of what a particular term or a business piece of business data really means. Companies quite often don't even know what data sets are critical to them. Because of all these myriad of reasons, it's quite often difficult for companies to really treat data as a strategic asset. Again, in a recent poll conducted by KPMG, the results are actually quite grim. Only 7% of the companies said that they were satisfied with how their data was being utilized as a strategic asset. 48% of the companies said that they felt somewhat neutral how their data management practices were. And a staggering 72% of the companies said that they still face challenges in treating data as a strategic asset, and they are not really realizing the full value or potential of the data that they have. So how do we move from here to there? How do we become from a very sad person to a happy person? Well, the answer lies in data management. So what is data management? Well, data management is the development, execution, and supervision of a set of policies, practices, and methodologies that various organizations can use to control, enhance, and protect the value of data throughout their life cycle. So if we break it down, what that means, well, what is the life cycle of a data? So a data originates, it gets transformed, then it gets used, or it gets stored, and then finally it gets destroyed. That's your typical data life cycle, right? So data management strategies would mean that at each of these points, companies have enough mechanisms to ensure that the data quality and data integrity is maintained, and the right data is being used as it is intended for its purposes. So overall, having the right data management practices would enable companies to capitalize on every opportunity, and it will also help them to protect their data as needed and protect themselves from cyber crimes or other regulatory fines that can be imposed due to data breaches. But this does not happen just in a vacuum or by incident. Data management really needs to be intentional, and it requires commitment, ongoing commitment from the management and the leadership team. So data management needs to be principle-based. So let us quickly learn at what are the key principles of data management. Firstly, the value of data needs to be expressed in terms of economic terms. If you just tell your leadership team that, oh, we need to manage data as a strategic asset, well, what does that really mean? So first and foremost, you need to create a business case and you need to quantify the value of your data. That could either be in terms of a revenue growth that you will realize when a particular product or service would be launched, or it can be savings in cost that you can evidence that if you are managing this piece of critical data effectively, then you can save so many $100,000 in fines which might be imposed. So data always needs to be expressed in terms of economic value. Secondly, managing data means managing data quality. Well, that's really the core of it. When you say managing data, it's all about quality and integrity that you are really speaking about. Thirdly, it takes metadata to manage data. Well, we are a group of data practitioners and we all know what metadata is. Metadata is, in simple terms, data about data. There can be two types of metadata. Business metadata, that is, what is the business definition? When you say customer name, what do you really mean by that? And customer name, as it means to the frontline teams, to the help desk team, use customer name as a term in the same context. Well, this kind of consistency in business understanding is very important to establish. Then there is technical metadata. That is the data lineage that flows from your source of origin to your authoritative source to your point of consumption. Is that technical metadata or technical lineage understood? Unless you strike a thorough understanding on your business metadata and technical metadata, data management practices cannot be effective. Then, data management is cross-functional. It requires range of skills and expertise. Data management does not only stop with data analysts. No, it requires range of other experiences. First and foremost, you need sponsorship and support from your executive team and your top bosses out there. Then you need a team of project managers to keep your data management strategies on time. You need data analysts, you need data architecture, you need SMEs to provide you with business requirements in terms of how your data management strategies should really shape up. So data management really requires an enterprise perspective that it needs to be aligned to your overall business strategy and your technical strategy, and it requires a range of skills and expertise. Then data management is about lifecycle management. Well, we just spoke about it, that at every point in your lifecycle, you really need to have robust data management strategies. Then managing data includes managing the risks associated with data. Well, this is what has been, the concept has been really introduced by your Basel II, BCBS 239 mandates, which lays down the principles of how every organization must understand their key data risks and then understand the relationship between how poor data quality is contributing to your data risks. And that is how, as you implement your remediation activities and reduce your data risk profile, you can design a very effective data management strategy. And finally, effective data management requires commitment and planning. It cannot happen if the leadership team does not endorse this. So what is data governance then? Well, I came across this analogy which I found quite interesting. What it says, as auditors, they do not themselves participate in financial management, but they always keep a check to ensure that your financial books of accounts are always kept up to date and it's accurately maintained. In a similar way, data governance teams, they do not participate in data management practices themselves, but what they do is that they establish oversight. They establish policies, standards, metrics, and framework to ensure that there is effective and sufficient controls and authority in data management practices in organization. So that's the difference. Data governance is the oversight and data management is execution. So what is then data governance really? So what we are going to do, we are going to divide this into two parts. First, we will look at how data governance can be established at foundational levels in organization, and then we will look at the more operational aspects of data governance. Firstly, how a data governance organization typically looks like. There are three functions. There are three key primary functions that a data governance organization will have. First and foremost, legislative-like functions. So this particular term, what it means, that there has to be an entity or a body in a data governance organization which will formulate your policies, standards, and all the data governance mandates that an organization needs to follow. Then judicial-like functions. That is the team which will ensure that issue management and escalations are properly being managed and they have the traction and the cadence that is required. And finally, executive functions, that is protecting and serving the administrative responsibilities. What it means that somebody is out there who is actually doing the admin part of it. They are actually implementing the data governance plans and policies which have been formulated by the legislative body in the organization. So that's an example of a data governance organization. If you look at it, you will see that it is headed by the chief data officer. And then The topmost or the most senior committee will be the Data Governance Steering Committee, which will take decisions like prioritization and funding of data governance initiatives in an organization. That typically consists of the very senior executives of the organization. Then, reporting to the steering committee, there will be a data governance council, which will formulate your data governance strategies and policies for the organization, keeping in mind the various businesses that are conducted by different units in the organization. Then there would be a data governance office. This will consist of the various data governance teams, which will provide guidance to the different data management teams in the organization as to how they can practically leverage and implement the data governance policies and standards into their day-to-day activities. So that consists of the legislative and the judicial-like functions. Then finally, also in the organization, there will be always a team of your IT teams who are actually working on your technical implementations and resolving the data quality issues, so on and so forth. So this is the team who is responsible for all the administrative responsibilities in actually carrying out and implementing the data governance policies and standards. So what are different types of data governance model types? Well, based on the size of the organization and the operating model, organizations must choose the right type of the right model. Otherwise, the data governance will always fail. For example, organizations which are smaller in size or which are more centralized in nature, they can go for a centralized model in which there is only one data governance function across the whole organization, and that oversees the implementation of data governance throughout seamlessly. Now, organizations which are slightly bigger, however, there is not much diversity across different business units, they can go for a replicated model. That is, each business unit would have the same data governance methodology applied for each and every business unit. However, organizations which are very large and complex and they have diverse kind of business units in them, they would ideally go for a federated model where there is one central data governance office. However, what it does is it coordinates with the data governance officers at various business units just to ensure that there is a consistency in the standards and policies which are implemented across all business units. However, every business unit will have its own variation of what the practical implementation of data governance policies and standards mean for them. So really, depending on your business model and overall strategy, organizations must choose what is the right model for them. Then, once we know how our overall organization will be designed, and we also know which operating model we are choosing, then we need to determine what is going to be our operating framework. Well, this is where organizations must do a good amount of feasibility analysis. First of all, the value of data to the organization. Organizations like Amazon and Facebook, to whom data is like their commodity, well, for their data governance will become really the backbone of them, and they really need a very advanced data governance framework to be implemented. On the other hand, organizations where data is just like an operational lubricant. Well, I'm not saying that data governance is not important for them. It is. But however, organizations for which data is like their commodity, for them, the data governance practices just need to be smarter and more intense. Secondly, business model. As I said in the previous slide, organizations must always do feasibility analysis on what is their overall business model and operating model before deciding the data governance framework. And finally, the cultural factors. Nobody likes discipline and governance, to be honest. However, there are organizations which will resist change more than others. So you need to do a feasibility analysis to understand how easy or difficult it will be for your organization to adapt to a set of discipline and governance policies. And accordingly, you must design a change management strategy which will be consistent with your overall data governance framework. And you also need to identify the number of advocates and champions that you will have depending on the cultural factor. Finally, impact of regulation. Well, I work with a bank, so we all know how regulators are always there scrutinizing our activities. So depending on the amount or the impact of regulation that your industry will have, you also need to determine how smart and sophisticated your data governance framework needs to be. So we have looked at the foundational aspects of data governance, establishing a data governance framework. Now we will look at some of the operational aspects. So once you know what your overall data governance framework and office is going to be, you need to understand what are your key data governance activities and what are the tools that you need to implement data governance effectively. The activities at the top, we need to bear in mind that this is iterative in nature. This is not just a one-time exercise. So first, it begins with defining. So define your data governance organization depending on the three main factors that we have seen in the previous slides. Then perform a readiness assessment. That is, understand what are your as-is data governance processes. What is the appetite? How do you think your data governance strategy is going to go? Do a discovery and performance readiness assessment for that. Thirdly, develop your organization touch points, your overall data governance strategy, implementation roadmap, goals, principles, and policies. Well, this is very self-explanatory, as you know, that you have to understand what is your overall implementation plan is going to be, and what are the key organizational touch points, advocates, champions, data governance offices that you need to establish. Then engage change management. As I said in my previous slide, depending on the quantum of change management you require, you need to have a really seamless training process, and this really needs to be iterative in nature. Then assess. I briefly mentioned about BCBS 239, which is your Basel Committee on Banking Supervision, and CPG 235 is one of the accounting standards established by APRA for banks in Australia. So again, depending on which industry you are, you need to assess what regulations or standards your company needs to abide by, and the data governance framework that you establish need to have key checkpoints taking into consideration the regulatory requirements. And finally, implement and embed. So implement your data governance framework, but how do you embed it? You do an iterative process all over again. So that is something you need to do iteratively, just so that you ensure that there is an ongoing business case for data governance in order to ensure that you have an ongoing commitment and sponsorship from your leadership team. So once you know the activities, how do you do it, right? You always need to have the tools and the smarts so that you create that transparency and shared clarity across your enterprise. So what tools does a typical data governance office needs to have? First and foremost, online presence. There needs to be a website, whether it's your Confluence, whether it's your company intranet, whatever is the appropriate platform. But you need to have a central place or a program website which will house your charter, your overall strategy, the key training, announcements, changes, linkages to your main data governance policies, standards, then whenever there are reviews and announcements. So there needs to be an online presence just to keep all your data governance offices across the enterprise always informed. Secondly, you need to have a business glossary. This is what I touched upon a little bit earlier when I was explaining metadata. When I say business metadata, and I gave an example of the customer name, right? Again, I work with a bank. Now, what customer name means to the frontline retail business, that may not be the same so I work with enterprise finance. So customer name might be a little bit different for us because we are one of the enablement functions. But the retail frontline team, they would understand customer name a little bit differently. So when this is a recipe for disaster, right? When different teams interpret different business terms in different ways. So you need to have a business glossary where all the key terms are stored, they are defined, and they are agreed upon by data governance officers from different business units. And then those business terms must be linked to the underlying critical data. And once that has been done, the technical lineage has to be also understood. That is, what is the database, what is the column, what is the table, what is the field. So you link all those to your critical data element, and that gets linked to your critical business term. So a business glossary with that sort of linkage to a smart enterprise metadata repository must be there. You need to have workflow tools, right? So there are so many data quality issues, but how you're ensuring that those data qualities are proactively being recorded, that they are being socialized at your executive committees, and they have the traction that they require to get a resolution in a timely and efficient manner. That's why you need robust workflow tools to establish that kind of shared clarity and transparency. Then a document management tool. Again, data governance can have this myriad of policies and standards, and very quickly it can get very confusing. So you need to have a really robust documentation process, a change control in place, so that the teams are always aware where to find what and which standard means what. Finally, a data governance scorecard. Just having the data governance practices and policies in place is not enough. What you also need to do is iteratively do a scoring and analysis of how your data governance practices are really going on in an organization. Over here, there is DCAM assessment also available. So you can go and have a read yourself. So there are various frameworks available in the market to help to assist data governance officers to conduct this scoring from time to time. But a scoring is always essential to pause and take a check of how effective your data governance strategies really are. So next, let us look at what are our implementation guidelines that we need to keep in mind. That is, we now know how to design an overall office. How do we choose a model? We know what our key activities and tools are. But what are really the implementation guidelines? Well, again, I have touched upon these a little bit earlier, so very briefly. Firstly, shift in organization culture. What we need to understand, that data governance is not something like you just leverage, you implement, and you walk away. No. To be able to do this effectively, you really need to bring a shift in the culture, that people need to start understanding data quality, and really imbibe the culture that data quality is everyone's responsibility. This really, really, really requires a culture shift and change. So data governance officers must become really champions, advocates, and mascots for this change. Then incremental rollout. Data governance is not something that you can bring 20 standards and policies, just give your implementation teams that, hey, you need to implement this and walk away. No. This needs to be incremental in nature, that you implement certain policies and then see what are the results, and then iteratively implement this. Adjustment, flexibility in approach, because not one size fits all. Training strategy needs to be really seamless to ensure that there is a shift in the culture and ongoing communication. We also need to ensure that when we do that scoring iteratively, what are the right metrics that we have in place? The metrics, now again, in one of our previous presentations, we saw that we need to measure what matters. So how do you ensure that you are measuring what matters from a data governance perspective? Firstly, your metric must always measure how your data risks are being reduced. What is the value or contribution that data governance is making to your organization? That must be expressed in some economic terms. Effectiveness. Having the data governance practices in place, what change that it is bringing to your operational day-to-day activities? Is it sustainable? All these policies that you have introduced, is it going to stay? Awareness. Are you creating an awareness across the organization? And finally, what is the ease of its operation and implementation? So these are some of the key factors that you need to bear in mind when you really determine what your metric going to be to measure your data governance. So that finally brings me to the data governance requirements. Every data governance office must have these requirements at its heart. First and foremost, you establish your data governance function, taking into consideration your framework, operating model, and the structure of your organization. Then, you must understand what your key data risks are. Not only understand, but prioritize them. Understand what are the causes of your data risks, and also have key controls and remediation activities in place. Understand what your metadata is, your business metadata, technical metadata, have a smart repository to capture them. Data quality management. Understand how to recognize and identify data quality issues, have a workflow tool to record them, and establish the relationship between your data quality issues and your data risks. Understand how remediating your data quality issues is reducing your data risk profile. That relationship is very important. Data quality metrics. Have metrics in place. When you identify a critical data element, what are the metrics by which you're measuring it? It could be any of those: timeliness, accuracy, completeness, but you do need to identify the primary metric by which you will measure the improvement in the quality of your critical data. Data accountability. You need to establish data owners and data stewards in every department. They need to be aware of their roles and responsibilities, and also need to understand what data they own and how they are going to ensure that the data they own are always accurate and they are of the right quality for use. Finally, education and awareness. I cannot harp upon this factor anymore, that a data governance will not succeed unless and until you have a very robust change management and training in place. And all this will become possible only if you always have a strong business case, so that you can win ongoing commitment from your leadership and your key sponsors. So that brings me to an end, and just want to share that all this content that you saw today, they have been mostly derived from the Data Management Association's DMBOK, that is Data Management Book of Knowledge. There are lots of other frameworks and books available, guides available as well. However, what I have found that this particular book, I can really relate my practical experiences to this very well. So anybody who's interested in data governance framework, I'll strongly urge them to go and take a look. With that, thank you very much for having me here. I thoroughly enjoyed my presentation today.
Thank you very much for a fascinating talk on data governance. Can I just put it out to the audience if we have any questions on data governance? We've got one question here.
Thank you. I guess just with the pendulum swinging back towards having sort of distributed data products, right? It's sort of quite popular to push that sort of power at the moment. Are there any particular challenges that distributing data products across an organisation might bring from a data governance perspective?
Thank you for that question. Yes, there are definitely a lot of challenges. To be honest, I do not have much practical experience in that because we are just embarking on this journey. However, some of the teething issues that we face, and it's mostly what I just expressed over here, right? Because organizations, it's more about how do you prepare the data for any type of data product, and it could be on any model, it could be distributed, centralized, or anything. So how do you really design your strategy to really ingest the data into the data product and data mesh? So that is where the challenge lies, and that is why you have these data governance practices, so that you can understand how you remediate your data properly prepare it for ingestion to data products. So I wouldn't really say that there is a recipe for success per se, like for data products, but if you have the right data governance strategies in place, that will definitely help you to prepare your data for your data products in data mesh, and that will just make your journey successful. So that's where I would stand here.
Thank you all. Really appreciate it.
Thank you.
All right. So now I believe we've got Alan Clark, who has got a fantastic job title. He's AI ontologist. And right. Okay. Well, Peter, you can come up and
apologies, Noel. We've had to think on our feet today with a few sort of speaker changes and how things are with COVID and the like. But Alan Clark's from Bermuda. I'm sure he will give you the spiel on what a muter is and all about and stuff like that.
There you go. And there's Dave.
How to automate data governance and access. So I think it's probably quite fitting after Peter's talk. So once you're all set, Alan.
Yep, good to go. Hear me okay?
What I was going to say was that Jonathan Gomez's talk, we'll try to make that available to you all. As sort of like
it's a time to reset.
He's just, took ill, with a throat infection or something like that. So, thank you. Take it away, Alan.
All right. All right, it was there, but it's gone.
Extend this one stuff. Just the mirror displays. I'm just going to PowerPoint back into it. Yeah, go first. So to get back into it. Slideshow. Let me just escape from that. Now let's go back to this. We're getting something. I think it's something. There we go. Just turn it upside down. Yeah, now put it up.
Sometimes it's maybe you need to downscale the resolution.
We're getting it. It's only when the PowerPoint comes up it's disappearing.
Okay.
That's a new one.
So I'll just try it and then I can just, if we can't do slides, I'll just.
If it's doing it at 1080p, we won't accept that kind of. That's why we don't like other people's laptops. We've got all set up for a certain.
I can just do the.
Does it have to be? Does it have to be down here with you? Can we take it up to the bio or is it quicker?
Yeah. Something to do
This is your present.
Yeah.
Do you want to just play off my laptop, see if that works?
Yep. I can try that.
Because this, I've seen it pop up, but every time you go into present mode, we did lose it.
Is it the line or? Yeah. So I'm going to just try my laptop.
Yeah.
Just wait.
Yeah. an engineering conference. We can solve this.
Open a ticket. Yeah, I'll try to work off
Try?
it. Yeah. I'm going to do my demo, but that's okay.
Yeah. See whether this works.
Hmm.
Is that coming through?
Come down on the bottom.
Maybe it's this dongle, is it? Doesn't like this. You don't want to use the slide deck that we sent through earlier.
Mm.
Do you have any more dongles?
Has anyone got a spare dongle?
USB-C.
USB-C dongle in the house? You got one? Yeah, bring it up. Let's give it a go. Try. Or should we plug it in upstairs? Because you had the other laptop. Mm.
Give me that there.
Okay.
Yeah, okay. Oh,
give me that dongle.
Oh, yeah. 2 more seconds, folks. Just use your clicker and you'll control your laptop from the clicker, but it will be upstairs.
Yep, it's just right in the back forward.
Yeah.
Oh, no worries. Any second now. Someone say KFC? Impromptu. It's all part of the act. Take your time. You back to the start? Something. We start at the beginning. Oh, I think it's coming. Oh, the clicker's not working. Yeah, there we are. The next slide. I think we're good to go. Hi, everybody. My name is Alan Clark. I'm a solution architect at Immuta, and what I'm hoping to cover off today is just give everybody an explanation of what Immuta is, who we are, and what problem we solve. So Immuta is a company. We've been based out of Boston. We've been in business for about 2014, and what we do is we do data access and governance control. We've worked with a lot of big customers. It's only in the last probably 8 months that we've kind of breached into Australia. I've been with Immuta now 8 months, and we've already had a lot of success in this region. So what we do is we give access we connect to a lot of the, next slide. So Immuta is a data management governance tool that sits above your data platform. So we typically integrate with likes of Snowflake, Databricks, Synapse, Redshift, and Google BigQuery. And what that does is we kind of sit above those platforms and we can write access policies. So today, a lot of customers come to us when they've already invested heavily in their data platform. So they have already invested in a big cloud platform. They have hundreds and thousands of tables in there. There are a lot of users using the data. But what they struggle with is actually providing access to that at scale. And that's where they come to Immuta. So typically, your customer come to us and they have like 15,000 tables, 500 users, and they're currently manually building these policies, either using by hand, doing grant select statements on tables, writing row access policies, column filtering policies, or they're writing some sort of code to do it and they're babysitting that code. And it becomes a challenge for organizations to manage that at scale. And that's where they come to Immuta. So what Immuta is that we're a policy creation engine. And what we do is we integrate with a lot of the big platforms, such as I said, Redshift and Databricks. Next slide, please. So how we do that is that, take for example, you have a Snowflake environment and you have thousands of tables in there. You stand up Immuta, you connect Immuta to your Snowflake instance, and you tell Immuta what tables do I want to manage and govern control on. And that's what we call the first stage. That's our data and classify section. So in there, we would look at your tables, your 10,000, whatever tables it is. We would ingest them into Immuta. We would run our fingerprint process over them, and we would tag and classify that data. So that would connect to any data source, and we centralize your metadata. And it's what previous speaker spoke around, how your metadata is your key. So we would scan that table and understand what's in there, and we apply standard tagging. So you can see there in this table here that we have these columns. Unfortunately, I was hoping to do a live demo, but since of AV restrictions, I can't do it. So I'll just talk as best I can through the process. So we would tag all that information. So if you had a table that had such information such as customer's first name, customer's last name, credit card information, their home address, their email address, their ABN number, a lot of vital, a lot of personal information in there. And if you have that data spread across all your tables, a lot of your tables in your data platform, finding all that information and tagging it becomes quite a chore. So that's where the Immuta sensitive data discovery, our fingerprint process comes in. So out of the box, Immuta comes with 80 classifiers. So for Australian region, we have the Australian driver's license, the Australian passport, TFN. So what that will allow you to do is to connect to your data source, and Immuta will scan your tables, and using 3 forms of classifiers. So we will check the column name, and we'll go a step deeper where we'll actually go through your column cell by cell and scan it and identify what's in your table. So that could be a credit card number if it was a 16-digit number, started with a 4 or a 5. I'm not sure an ABN starts it, but we can also do passport number. You can also build and extend on that and add your own classifiers as well. So if your company had a specific customer ID format, you could build and classify that. And we can do that at scale. And the end result of that is that Immuta knows what's in your data. So we've gone through and tagged all that information. So if you had 400 tables that had credit card information, Immuta will know that you have 400 tables that had credit card information because we've gone through and scanned that. The second part of that is that your users. So Immuta will connect to your Active Directory or any SAML compliant engine. And if it's SCIM enabled, we'll be able to get access to all your information. So that would typically be your users will have all their attributes in their profile, they'll have the groups, and we'll get access to all that information. So at this point, Immuta knows about your data. So we know what's in your data, all your credit card information. We also know about all your users. And the next thing you want to do is writing policies or access control at scale. So typically, if you're a data engineer and it's your job to open tickets and give access to tables, you come in the morning, you have 10 tickets in your queue, and you have to go through and add each user to that. Immuta will build a subscription policy to automate that process. So how that would work is that if you were a user in your organization and you were a member of the IT team, and we tagged all your tables with IT, we would go through and by a subscription policy to allow you access to that. So that's automated and done at the start. So we would build the policy once and apply it across all your tables. And that's just a table level access. And that would be if you managed multiple data platforms. So if you had the Redshift and the Snowflake environment, we could manage all of them subscription policies and access policies from Immuta. So we centralized access control. So that's just at a table level. You can also extend on that to do row and column level filtering. So typically, if you want to do row and level column filtering today, all of the major platforms have the tooling and the levers to enable that and make that to happen. But it becomes quite a mandrolic process where you have to actually create the row access policy, assign it to a table, make sure the roles is correct. And as your users and tables grow, that becomes unmanageable, what we found. So what we would do is take, for example, a credit card information. So you had 400 tables in your organization that had credit card information. And you want to write a policy to say, okay, I want to ensure that only a certain subset of my users within my organization can see that credit card information. And then we're going to base that on whether that's their attributes or what group they're in. So we've gone through the process of connecting to your data, and we've gone and tagged it with credit card information, which is the first step is discover and classify. So Immuta knows about those 400 tables. The second part of that is knowing when to apply to that. So from your users, which are in Active Directory or Okta, whatever your compliant protocol is, we can get all that information and write a policy. So we would write a simple masking policy to say, I want to mask all that data in credit card information, and I want to apply this hashing algorithm. So we could do a SHA, or we could do a change to a null or a constant. And as soon as we enforce that policy, we push that down onto the platform. And we applied those policies natively. And the key feature of native means that traditionally, when we originally started doing this, we did a lot of proxy. So we'd have to proxy the request through Immuta to say, what do we need to do to this user to give them access? But now we do it natively on these platforms. We actually enforce the policy on Snowflake, on Databricks. It's as if you were actually writing the query yourself in this UI. So that really, so there's no impact to performance when you're querying the data. So when your end users query the data, they will actually run the query in Snowflake or whatever engine you want that we support and manage, and they query, and the policy is enforced on that table. There's no, the data path is not going out of Immuta, not out of your data platform into Immuta. It's all imposed natively if you're doing it. So the beauty of that is that if Immuta lights out, which it never does, in the unlikely scenario that we ever had an outage, your policy will still be enforced. And all your access controls will still be in place, even if Immuta was not running. So it really centralizes. And secondly, for performance, there's no impact to your performance when you run your query. And then we can also write row level filtering policies. So we can actually create a view of your data where one user has a specific set of attributes. And when they query the same table, they will get a different view of the data. So if I was a member of the security team, I would be able to see the credit card information. And then if I wasn't a member of the security team, that credit card information would be hashed out for me. So quite easily, Immuta allows you to have, provide that governance control at scale, which is hard to do. But also more importantly is that it can also be, we also provide rich auditing capability. So every operation that's completed within Immuta, so a data engineer or data steward will actually write a policy, we'll track that information and log that information. And then also who's querying your data, you can actually query, you can actually see who's querying your data, what query they ran and what time they ran, and what their attributes were and what access they had at that time. So what that allows you to do is give you that really fine forensic analysis of if you want to inspect your data. So for argument's sake, you want to say between 2 o'clock and 4 o'clock on a Friday, I want to see everything that happened on this data source. Not just what the data steward did, but actually what the end user queried. So you could run a report to say on this data source, which is the client data here, I see at 2:04, the data steward, he turned off all the masking policies, the global masking policies. So the credit card information was available for everyone in your organization to see. And then between 2:15 and 2:17, there's one user query that all those tables, credit card information, and got all that information. And then at 2:19, the data steward re-enabled the masking control. So it gives you that really, so as a data steward, data owner, it really gives you that benefit of actually seeing what's happening within your data platform. And again, as a developer, I have a development background. I come from a programming background, Java, and I moved into data. And obviously the first thing you see when you look at a UI platform is, oh, it's clunky. How do I do this at scale? So Immuta has what we call a policy as code, where every policy we write, you can actually, it's just essentially a YAML file, and you can apply that YAML file. So typically if you had like multiple environments, a dev environment, a UAT environment, a pre-production environment, you can version control these policies and build them into your pipeline. So if you had a release pipeline for building a new table, you can actually trigger a callback into Immuta to say, okay, we've got this new table, I want you to scan it. So consider an example where you've set up a policy that will mask credit card information, and tomorrow you create 5 new tables that contain credit card information. Because we've already created the policies in Immuta to scan, to identify credit card and write the policy, those 5 new tables will become available within, Immuta will know about these 5 policies. We will run our sensitive data discovery over, we'll identify those 5 tables have credit card information, and we will automatically apply those policies to those tables. So you can kind of future-proof yourself with knowing that you've mastered all these credit card policies, and you don't have to go and start adding grants, apply that row access policy or column level policy on that table. So it really allows you to do that at scale. We also have the concept of approve to promote. So if you have a typical software release process where you go through a peer review or a pull request and the code is reviewed, you can build that same functionality into your data security or data governance framework. In that scenario, you could have one environment where you build your policy, you export it into your Bitbucket, will trigger off a pull request, your data steward or your colleagues will review that, and then you can actually apply that and you can roll that out as part of your release process. And again, this allows you to, when we say automate and policy as code, you can actually write your policies in code. You don't have to use the UI. So if you really wanted to integrate this with your existing DBT data pipelines, whatever your CI/CD pipelines are, you can embed them in there without much issue. The other thing is that we have the number of reports as well for the data governance. We have a number of canned reports that we can actually display to users. So if you wanted to understand what user has actually accessed your data, you could run a report to say, run a report for this user and see every data source that user has access over the past, and you can give access to that. So that's kind of, it's a bit hard for me to talk through because I was hoping to do a demo and talk you through all this, but I guess the key takeaway points from understanding what Immuta does is that we do policy and governance at scale. So if you have lots of data that you need to apply governance policies to, whether that's a table access level or column and row filtering policy, Immuta is the tool to do that for you. And then secondly, as an automation tool and as a mature development framework, we have a very rich set of APIs. So any use case that you can think of or build, we can build that into the pipelines of your existing tool sets. So it's quite a powerful tool to understand, to apply your data policies and governance across all your data platforms. So if you have, and it also runs that if you have multiple data platforms, we can also manage that across those also. So if you have Databricks, if you manage Databricks and Snowflake, you write the policy once and we'll enforce it across both of those data platforms. Next slide. Again, this is just a kind of rehash of the monitoring, and like we track every user activity, we monitor the compliance and reports. So if you want to run an anomaly report to say we're seeing some unusual behavior in your data. Okay. Also polyactivation history and alerts and notifications. So as I said, we have a very rich set of APIs. So a lot of our customers you see, they will actually take the audit information and use it downstream in their monitoring system. So if you have a Sumo Logic or a Datadog platform, you can build triggers alarms in there to alert when you're having, like when a policy is being revoked or access is being removed from a user. So it gives that full end-to-end data governance tooling to provide access control and role-level capabilities on your database. So I know I've only a couple of minutes remaining. If any questions?
I'm interested. This is a fantastic tool, and thank you for your presentation.
Yeah.
I'm interested to know whether a muter does data lineage, and just by the collection of metadata that you use.
Yeah, so we do data lineage, and we more so probably schema detection and changes to the data. So if you have a table in your platform, you've enabled the schema monitoring on it. As soon as a new column is added or removed, that will trigger an alert, and that will notify a data governor going, the change has been happened on your table. You can either automatically handle that scenario to say, okay, I want to enforce a policy and restrict data access when that happens, or I can just automatically allow that to happen. So we have this concept of schema monitoring on both new tables are created and when a new column is added.
Thank you. And as a follow-up to that, do you see, who are your users of this product? Do you see data stewards, for instance, using it, or is it typically mainly data engineers?
No, data stewards is the main user. So we have our explainable policy builder. So you can build policies that happen to be a DBA or a data engineer. So they're kind of the ones that manage the data. So the idea, one of the goals of the product is that it doesn't require a data engineer or a DBA to actually write the policies. You can be a data governor, data steward, you can build the policies. And then secondly, you can also then, using the explainable policies builder, if you have an auditor or somebody you want to explain, these are the policies I've enforced on my tables, you can do the policy builder. So that's kind of who would build the policies, but then also a lot of data engineers would integrate with it and write, as I said, use the APIs through the pipelines, build into existing release processes. And then actually the end user will be the data consumer. So these are people who actually will query the data, your BI user, your data engineers, and they typically wouldn't know about a muter. It's all hidden from them. So they're the people that you're actually restricting data access from. So they're the three kind of type of users that we would manage.
Okay, one very quick one up the back, and then
I just want to ask about the, so you mentioned about program protection, what are kind of sensitive information in your community?
Seriously?
just a little bit closer to your face,
Yeah, just on the sensitive detection, so
yep.
you create out there, what are kind of information you can detect?
So at the moment, we can detect sort of like address, state, location information, IP addresses, email, and those type. But the classifier is just essentially a regex that you can build. So if you wanted to identify any pattern within your data, you could write a regular expression for that. So if you had a customer ID that started with 4 characters and had it ended in 4 numbers, you could write a regular expression to capture that information. And then you could also write a classifier to identify a column name. Or the third option is a data dictionary, where if you wanted to write a classifier for the Australian states, you'd have those in an array of like New South Wales, and then if it found those values in a column, we'd tag it with state information. So we come with 80 classifiers out of the box, but essentially you can write and expand that as many as you want to whatever type of data you're trying to identify within your organization.
So you can run your custom classifier?
Absolutely, yeah. You can build them and execute those, and then you can run them for new data, but also you can rerun them on your old data as well.
Thanks very much, Alan. Now, I have one last round of applause. Now, data engineering isn't typically considered a dangerous sport, but I have a dangerous task because I need to make a couple of short announcements between now and lunch. Now, we're about to break for a super yummy lunch, but I just wanted to make a couple of really quick reminders. Firstly, when you registered, you would have got one of these passes. Now, this pass is a great way to interact with our fantastic sponsors. I'm hoping you'll have the time and the energy and the inclination to speak to all of our sponsors today. But as a little bit of incentive, if you get a stamp against each of those, you'll be able to go in a prize draw later for an absolutely incredible prize. And I'm really looking forward to that. So please take the time after lunch and during lunch to meet, connect with colleagues, and also speak to our wonderful sponsors. And as a second thing, a second task over lunch, we have Joe Rees joining us in Melbourne at the moment. And Joe Rees is one of the co-authors of this fabulous book, Fundamentals of Data Engineering. Now, Joe is out there. He's a fantastic person to go and talk to. And he's also doing a couple of book signings. So if you have a chance, please find Joe. He's actually got a bunch of books beside him. He's happy to sign them, and he might be giving a couple of them away. So we're going to break for a yummy lunch. We'll be coming back at 1:40. That's 1:40 p.m. Please enjoy your lunch, and we'll look forward to seeing you after then. Thanks very much.
Right. Welcome back, everyone. Hope you all had a good lunch and are all set for the second session of DataEngBytes Melbourne. My name is Aditya. I'm a senior data consultant with CMD Solutions at Mantle Group. Rhiannon Fowler and I will be your host for the today's afternoon session. I would also like to take this opportunity to thank our sponsors for extending their support to the community, without whom this event wouldn't have been possible. Now, getting to the talks, one of the key aspects to consider while designing a data platform is to establish good data security practices. And our next speaker is going to speak exactly about that. Jenna Alovcic is a solutions architect from Fivetran, who has had experience in ad tech, BI, and more recently into data pipelines. She's a cybersecurity enthusiast. And a fun fact about her, she's also a part-time karate instructor. How cool is that? So without further ado, please join me in welcoming Jenna Alovcic.
Hi, everyone. My name is Jenna. You're probably waiting with bated breath for an answer. especially with the recent breaches. I'm sure that my timing is impeccable, if not coincidental. So the agenda today, I'll give you a bit of a prequel about my journey in cybersecurity. It's still going, obviously. The objective, intro to data security, so we're all on the same page. Threat modeling mindset, to risk and then exploit, and then a bit of a wrap up. So the prequel. Today, I really struggled in defining what data security meant for data engineers. I didn't want to provide a shopping list extracted from Wikipedia of dataset tools or give you some sort of generic list that you can do. For example, everyone knows encryption in transit, encryption at rest. That's a given rule. So I wanted to bring on sort of my experience from the cybersecurity bootcamp that I did for the past 6 months. It's more about critical thinking from the attacker's perspective rather than from your perspective. And you would ask, why data engineers and not the security teams? It's a valid question. I think because one, you are handling the raw data unaggregated with all the PII. Naturally, you're in the thick of it. So, why not handle it? The other aspect is that security teams actually stretch thin. Data engineers' skill set is rare, but cybersecurity skill set is also rare. And you're a lucky company if you have a security team. So I feel like security is a shared responsibility. Yes, I did steal that from the cloud responsibility model. Moving on. So about my journey, the path to becoming a paranoid individual, that has been interesting for sure. So I've been interested in cybersecurity for quite a while now, but I was kind of overwhelmed and intimidated by the technology as well as the terminology. Dockers, what are they? What do they do? VMs, no idea. Obviously, have learnt over time, as well as my role in Fivetran has probably facilitated and boosted me in terms of my confidence, understanding, setting up a VM, setting up a database, all the basics. So the objective today is to give an overview of data security, concepts of threat modeling, as well as threat modeling in action. So going through a bit of a hypothetical scenario. The other thing I wanted to point out at the same time is the Fivetran company itself has been undergoing a bit of a shift in terms of its security. So security is more than just the product. It's also our behaviors and our practices. So they have actually understood that, and our head of AdSec has introduced a team champion security model. So now there are individuals across Fivetran that are interested in cybersecurity, technical and non-technical, who are being trained on security topics, understanding how to identify phishing, phishing scams, as well as vulnerabilities, and leveraging that to really scrutinize our behaviors and practices in daily life, I guess. Moving on, the intro. So, everyone is probably familiar with these concepts, so I'm not going to read them out to you. But in terms of remembering them, I don't really remember definitions very well, so I like to use a story or a scenario. So one story is, for example, that a hacker has accessed a database, obviously unauthorized, with PII data. Say that PII data has actually been hashed within that database, and so they can't make sense of what it is, and they can't dehash it because it's one way. Great. Are we safe? Nope. What they decide to do is they load ransomware. And instead, they have decided that, or in some sort of way in their investigation, they have assumed that this data is critical to business operations. So with ransomware, you have 1,000 Bitcoin ransom being demanded, and you don't get a decryption key unless you're obviously given that over. So did data governance actually prevent that? No. That's the point of data security, and that's how I like to sort of convey that. More definitions. Sorry, this is not a dictionary. Vulnerabilities. So just to point out at a high level, vulnerabilities are not actually malicious. This is making the application do something it is not intended or expected to do. it might be an error of the programmer, or they just can't account for the entire scenario of what the language can do. I'm sure ThoughtWorks found that out when they did that particular bot use case. Something else to explore is that exploit is the actual taking advantage of that vulnerability, and the malicious part is the action or activity is against the law. Cybersecurity stats. No, this was introduced more for, I guess, fear-mongering from my aspect. I did not see the new breaches coming my way before this speech, but that has worked in my favor. One thing I want to highlight is humans are abysmal at security. Right. Sorry, guys. It's not all you. So I am all for Zainab when she said automation was the key. Automating is the key in terms of reducing that human error. The other thing that was quite shocking to me was the number of steps it actually took for a non-error breach to occur from a sample of 258 breaches. This was across the globe from a specific Verizon report for 2022. Surely we can do better than that. I mean, you can question what does a step, what does it contain? I don't have an answer for that, actually. I'm also curious, but it's still quite a few number of steps compared to what it should be in terms of our data security. So I wanted to take a bit of a detour and help sort of facilitate that understanding of the hacking mindset. First of all, targeted and opportunistic attacks. They are slightly different in the way they work. Opportunistic, for example, thief walks up to the house, checks if the doorknob is actually locked. If it's locked, walks away, tries again in another house. If it's unlocked, gets in. Simple concept. In terms of cybersecurity, it may be that an ex-employee still has those credentials and they can still actually use them and it works, which is horrible. Targeted obviously requires a little bit more recon. So they've done investigation. That could be a simple, going through the website, see who works there, see what tech they use from all of your job descriptions. So those LinkedIn ads that contain, or your tech stack, because you want that specific unicorn engineer, they are looking at those ads and saying, oh, these guys use AWS. Oh, they've got a Postgres database somewhere. So plenty of information for them to look up. So I want you to step in the shoes of the attacker right now. So instead of thinking, who is attacking me? What would they be interested in? You would think the opposite. What would I attack? What would I be interested in when you're looking at your own architecture, when you're looking at your own pipelines? So one thing is company growth. If you have some sort of startup that has this billion-dollar valuation and is heavily marketing its, that Series B funding that you just got, you are cashed up. And these guys are focused, I guess, on shipping features, shipping products, hiring. They're not focused on security. That's a cost center. Also looking at previous breaches. So there's a website called breach2.2 where it contains a number of databases and credentials that you can leverage. And also a Shodan database. So a lot of opportunistic attacks actually come out from Shodan database because you can literally look up any devices that are online that have an open port. And that's where usually attack starts. Port scanning. So IP and port scanning, they're looking for open ports, attached services. Simple nmap command can actually bring up the versions as well. Then all they have to do is actually look up the CVEs that you've got in the database. And once they've got the CVEs, they can try and exploit and see if they can do the remote code execution. I wrote seasonality, which is kind of a bit of a weird one, but if you think about it, it makes sense. So people go away on Christmas, right? You're going to be off guard, you're going to be switched off, you want to spend time with your families. So seasonality might kick in the sense that attackers are most likely to attack at that point in time because people are away or they're switched off or off their guard. Coming on to threat modeling. So this is more than just a framework, it's a mindset. As I mentioned before, security is spread thin. They can have the best intrusion detection tools. They can have their extensive logging set up. They can have their alerts. But if you have someone on the other end doing bad practices, storing credentials in Git, storing your secrets, API tokens, storing credentials unencrypted, it's all counterproductive, really. So, threat modeling for data engineers, it might not be a usual practice for you. It might be something that you want to think about incorporating into your practices as part of maybe your every second sprint or every third sprint if you're using Agile. So where would you even begin looking at this? These are, I guess, the stack that data engineers could touch. So you might touch maybe the first third or the entire pipeline all the way through. Considering all that, it could be quite overwhelming looking at that and saying, actually, this is too hard basket. I'm going to leave it. It's fine. We'll be fine. Nope. I guess, advice that I have read and would give is that start from your next project, start from your next feature. That is probably the best place to start. And then moving forward, I'd imagine that all your projects moving forward and all your features moving forward, you would have developed a database or, I guess, a library of common issues, common problems, and reusable mitigation strategies. So then looking back at your backlog, they probably cover the same sort of pipelines, and you probably have already 85% coverage at that point in time. Of course, you have edge cases, but that's okay. You can look at those and address those incrementally over time. 5 steps, pretty much 5 steps of threat modeling. I've simplified it. So what do we want to accomplish? What are we building? What can go wrong? What are we going to do about it? A review, did we do a good job? In my scenario, I'm looking at what are we building, what can go wrong, and what are we going to do about it, just because we've only got 15 minutes to go through this. So there are many, many frameworks under threat modeling itself. You can really go in depth and academic, if anything. One of them is Stride, which is a more mature model that was developed by Microsoft developers a while ago. A few odd named ones, such as Pastor and Dread and Vast, which focus on or do different things. But for the sake of time and simplicity, I want to make this accessible to everyone. So I'm just going to focus on the 5 questions in that scenario. You can, I guess, work with your security teams and consult with them and understand what is probably the best framework that you can leverage or the most efficient in terms of making sure that you have set up a secure pipeline. 2, risks and exploit. So wherever there is code, there is a way, and that's what I feel is pretty much correct. I've set up a scenario. So for example, data engineer 1 is tasked to build some sort of custom pipeline using the API. Data engineer 2 will build out a machine learning model with scikit-learn, etc. So yep, think about what do these activities involve? What would you attack? Assume that Murphy's Law will kick into gear. So risk matrix, based on that scenario, I've picked 3 vulnerabilities. So credentials in code, stolen credentials. Number 1, that happens quite a bit. Dependencies, importing packages that you're not fully aware of, packages that you haven't really looked into. And, Log4j was a big one. Then there's a pickle vulnerability as part of data models. Not everyone talks a lot about data models being malicious or containing malicious code even. And that might be for a reason, because you wouldn't see it out in the wild, I guess, frequently. But doesn't mean that it won't happen and it's not there or have really high risk or consequential risks. What can go wrong? So nothing fancy. Everyone knows it takes 1 Git commit and a little bit of pressure. Say you're an engineer, you want to, you have this deadline you're working towards, you're under a bit of pressure, that business stakeholder is tapping you on the shoulder, when's it ready? You forget that you've got test credentials sitting in that repo or going to be pushed to that repo. It happens. New engineer. So there's a junior engineer, they're not exactly, up on the security practices. They want to impress you, but really they're just building to make shit work. Or hopefully not, no established practices. And why, you may ask, if it's not a public repo, why is this a problem? Well, it's still a problem because if there is a breach from some other team in your company, which happens, people do stupid things, you can't prevent that. At least you won't have your credentials sitting in the repo. But if there are, obviously the breach will cause a bit of a panic attack, considering that you've just given away all the credentials to your very sensitive data. So I see cybersecurity really much as a game of unforced errors, pretty much like tennis. What are we going to do about it? Implement some sort of credential storage procedures. Yes, that's a very generic measure, but that's going to really depend on what tool you're using. So I felt like I couldn't really specify one. Secret stores is one that can be specified, but it's considered expensive. Another thing is that if procedures fail, and they usually will, there are tools that exist to actually help find credentials within your GitHub repo or code. For example, GitHub Secret Scanner, and I'm sure there are a bunch of other tools that do the same thing. And integrate these checks into your CI/CD pipeline, as well as inducting your new engineers. As mentioned before, you've got some sort of junior engineer or a new engineer not up on the practices. You want to make sure that they are informed when they are actually building. The meme on the right is not recommended. What else can go wrong? Dependencies. So everyone loves open source. It's great. It really helps the company evolve, so they can just focus on building that app. They don't have to actually focus on building additional capability. So there are more than 150 vulnerabilities found in over 40% of packages in PyPy, which can be concerning. And there are obviously open source, components that can be considered malicious, where hackers actually do implement typo squatting, which means that they spell something as similar as something that's very popular as a package. So one day I was searching for pandas, import pandas into my local environment. I found something called brew panda. I thought that must be it. Nope. I read the description. Luckily, the description told me something else. So whilst that was not malicious, I can see that definitely happening. And on the right there, I've got some few mitigation strategies that I've listed out, including using a safety dependency checker specifically for Python, Open Web Application Source Project, dependency checker. It's built and maintained by the community, so they definitely know the nuances of security. And finally, the machine learning model. So where there is code, there is a way. In that snippet there is a function called reduce, which can actually execute arbitrary code. And if someone decides to amend and upload a model with this particular command, that sets up and creates a reverse shell connection with the attacker IP based on port 444. The attacker is listening on port 444 for your connection. And pretty much they have a shell and access to your system. Avoid pickle data. That is simple. But obviously, if it's considered that it's low risk, or in the sense that you don't use machine learning models often, that you might not even have a mitigation strategy. You might just say, we accept the risk, we acknowledge it, we will continue to use it for this purpose only. And at the end, you have some sort of, repository of practices, as well as, how this could be implemented in a specific program. And this is just a diagram of what that would look like. So for the wrap up, there are probably 3 or 4 points that I want you to remember. Security is a shared responsibility. Threat modeling is a proactive form of defense. Not all risks have to be fixed. It's not feasible. And automation is key, which is the last one. Thank you.
Thank you, Jenna, for that excellent talk on data security. Really, really, really cool to watch. For those that don't know me, I'm Rhiannon Fowler. I'm a senior solution architect from Fivetran, based out of Sydney. I am thrilled to be co-hosting with Aditha here this afternoon. And I'm really excited about introducing our next talk. This is a speaker who will be talking to us today about the well architecture framework and its importance when working with machine learning. Now, I guess without further ado, it's with my pleasure to be introducing Vikas Rajput, who is a principal engineer at Microsoft, who is innately curious and loves how data tells us a story. Please welcome him on stage.
Good afternoon, everyone. Feeling low? No? Okay, good. Thanks a lot to all the members who have been organizing the event. It's been really, really fascinating, and for all the members who are here to attend as well, and of course, the very kind sponsors who have made this all possible. It's really good for me because there are so many members who have talked about some of the building blocks that we will be talking about in this session as well, right? We had members talking about automation, we had members talking about security, just the one before this as well, and then we have also talked about some parts of how some of the solutions can use ML and some of the data governance and principles. How does that all kind of work? We have seen some of that in action. With this particular session, what I'm going to do is I'm going to look at how do you go and really kind of bring this all together. How do you bring a structure to something like this? I'm a data person. I've been doing this for 18 plus years so far, and one of the inherent reasons I do data is because I like things being simple. So let's try to make this simple as well, and let's talk about this. So some introduction has already happened, so I'll probably skip through this. Predominantly on data engineering side, architecture is something that I've done quite a bit as well. I firmly believe in being a builder from the perspectives of teams, product, business values, and obviously storytelling as well. So we said simple. Let's look at very kind of targeted objective that we will have. We will talk about WAF, which is well-architected framework, right? We will also talk about MLOps. The intent is not to kind of really go into the nitty-gritties of that. It's a very brisk conversation on what exactly that is. And then the key crux of the material is actually on the last one, which is WAF plus MLOps. That's where I want to focus on, right? So let's carry on with this. Now, when it comes to well-architected framework, right, you go and look at any solution, something that you have inherited, something that you're creating from scratch, something that you're building with your partners. How do you go and approach architecture? How do you go and make sure that the solution that you're building on has an end-to-end perspective? And the perspectives, they can only be looked upon by having 5 lenses or 5 sides of what exactly are you looking at. Any solution, it has to be secured. You have to look at what cost optimization methodologies or approaches you can use to keep it kind of within the cost. You can also be considering about operational excellence. How are you going to operationalizing it, right? How, when you have put it in production, one of the things that I generally go and tell my teams and to clients as well, that don't think about what you're doing today, what problem you're solving today. Imagine you have it in production, what you're going to do then. How it's going to look then when it's in production, right? And that's what is the all rigor about operationalizing. And then you have to think about reliability. Now, not everything has to be 24/7 by 365, right? What exactly is it that you're trying to do? How reliable you want the solution to be? And then, of course, around performance efficiency as well. Now, all these different 5 pillars, they have their own specific branches. Let's not be scared. We will elaborate that a bit more once we get onto that, right? But the key aspect is that these are the 5 key pillars. These are the 5 key lenses which can inform you on how your architecture is looking, where you want to be, and where you should be going. And then within that, you have specific elements that you can think about,
Now let's jump on to machine learning. Quick show of hands. How many of you associate yourself being a data engineer? Good, okay. Quick show of hands, how many of you associate as absolute machine learning or data science or AI person? Okay, that's good. Quick show of hands for the people who think they're none. Either of these two. Awesome. So let's quickly talk about what machine learning is when it comes to machine learning operations. Again, a very layman lingo. So those who are ML experts, please pardon me, bear with me. Those who are data experts, again, the same thing. Hopefully you will pick up something here. But at the same time, this is more about going towards generalizing the conversation for understanding and building the understanding itself. So when it comes to machine learning, the delivery lifecycle is something that you start with business understanding. You know, what sort of business domain that you're in. Are you retail? Are you anti-money laundering? Are you security? Are you banking? Are you insurance? Whatever that is. And within that as well, what is the aspect of the business that you're trying to target? What is the problem that you think that a traditional application or a software or data warehouse or a data engineering platform, whatever, is not going to solve? And you have to have a machine learning model for that. Once you have that understanding, once you have basically built your understanding of the business, you go towards the data infrastructure, platform building, things like environment setup, things like wrangling of the data, pipelines and stuff like that. So there is a lot of data engineering work, which is almost like on the borders of, data engineering, but with Python and a few other bits and pieces that you probably have seen and, heard about. These two components together is what contributes to what we call upon as model development. You have the understanding of the business, you understand the business context, you understand the problem that you're trying to solve, you now understand the data as well, you have a platform for that somehow, right? Presume that's there. That's when you start going towards, okay, let's build some models which solves that, which resolve the problem that you're targeting basically. And this is where you go, you do the development, you do the training, you basically go and kind of experiment. And once there is a confidence of, yes, this is going well, you basically then go towards deployment or serving that. So you pick one golden version or one golden goose, which is a model which you know is ready, and that is what is going to solve my problem. You basically go and deploy that, and then the new data set comes in, which basically gets exposed to it, and prediction and references or inferences or whatever that happens on top of it. So that's how, kind of the very, very loosely speaking, what we see in ML lifecycle. And this is what, once you have exposed this, presumably it's exposed to your end users externally or internally through a web service or through some other mechanisms. Again, very generalized. So what's about this whole MLOps thing in this, right? The ML aspect is definitely around what we have as, business data, all those aspects of, what's going on in infrastructure, what models you want to work with. But then development is about training and testing as well. And that's where the CI and CD aspect comes about. We will have a different visual, which will basically elaborate that as well, just to kind of, again, simplify and show visually how I see this happening. So once you have the continuous integration and deployment going on, that's where you go towards the continuous delivery. This is where the ops part comes about, where you want to look at the feedback loop, which is more like you have done something, deployed something as a production service, you get an output, how do you go and feed it back to the main business so that they can also, continue to consume that. And then, of course, monitoring it. I probably prefer this visual because this kind of, elaborates that a bit more specifically. Now, don't get lost in the whole trail that's there. It has a very specific train if you think about it. So on the left side, you have the source systems, right? Can be anything.
You go and get the ingestion train going from there. So ingestion train is where you go and do certain aspects like cleaning it, validating it, transforming it, labeling it, and a few other bits and pieces. Again, as I said, it's a very generalized version. There are 10 more things that I can add to this. It can be very, very noisy picture. That's not the intent. Once you have that, you basically go and then lead to the next train, which is more around generating the train model, which is where you do some iterative experimentation, training, and tuning of the models. There are multiple ways to do that, right? Not getting into that. But the key aspect is this whole train of getting the data, transforming it, validating it, labeling it, getting it ready for experimentation, then training it and testing it and tuning it and having the model ready. Because then you can do the scoring on the model, right? That's the whole process which you can do as a continuous integration. In a continuous integration, otherwise in a software world, what will happen? You will go and have certain binaries or different code objects written by different people, and a service will come, it will build that, and then that build will basically be exposed to certain tests, which hopefully have been coded as well. And if the tests are successful, the system says, yes, this build is successful, and leave it at that, and then go to the next rate, right? You can go and say, once a build is successful, you go and deploy to production. And that's what the continuous deployment is all about. The next train which comes after that is the one which is basically continuously taking it to the deployment stage. That continuous deployment stage is also kind of, going and putting that model more like a binary object, think of that, putting that binary object in a way and at a place where that can be exposed through a web service, through an API endpoint, or through a Docker image, or through a Kubernetes cluster, whatever, or through Databricks, or whatever that you have going in the business that can be exposed to the end services and end consumers, basically. Now, this is all kind of there, which is more about not just this, but the key aspect here when you think about this is the elements which are highlighted in yellow, right? These are your milestones. These are your key systems. The process we talked about all of what, right? Since the morning, we're talking about that as well. You have systems, source systems. You have compute infrastructure, which is basically for dev and train. Then you have Git repository or code repository. Down below, you have your storage services. You have your compute infrastructure, which is used for actual staging or production, right? And then you have a security monitoring services as well. And plus, there is a model registry. These are different elements which are key components, tangibles, if I may say, of your solution, of your architecture. And these are the ones that you need to look at from architecture point of view, right? So let's look at what happens. And again, as I said, it's been good that the session on security was right before this. We're going to go and talk about 5 WAF pillars, and we'll start with security. That obviously is one of the biggest in terms of how you go and structure that. So again, the key intent here is to not go and elaborate that to the nth level of detail. This is not it. There are tons of other things that can go beyond this. My intent is to kind of give a flavor of what it entails, basically. So when it comes to security, when I look at any solution from security point of view, I start looking at it from a couple of different areas. How is identity being managed? How is access being managed? Identity and access are 2 different things, by the way, right? Then network or the surface, how are they being managed? How is the protection for data itself is kind of weaved into the solution? How monitoring is weaved specifically for security? So for example, when it comes to identity, do you have a centralized identity access management, or do you have more like a couple of different ways that people can come in and authenticate themselves with? There was a mention of storing your credentials in a secure place. How do you go and manage your keys and credentials centrally, right? How do you go and leverage SSO? So these are the different aspects. Now, when I say all of this, I want to, again, bring some flash of the memory that we just talked about previously. The one visual, which is more like an ellipse on the top, is actually a reminder of what we talked about earlier. We have what we have. We have source systems, we have compute, We have code repository, storage, security monitoring. We have model registry, service endpoint, which is basically exposed to your end consumption tier. And then you have your compute, which is for your serve tier as well, right? Compute tier can be Kubernetes, containers, servers, Databricks, whatever that is. When you look at all these different elements, you can basically pick up just any of these sub-branches on security and put that to all of these different elements that we just talked about. These are the tangibles, as I said, of my architecture. Generally, these will definitely be there, right? Code repository. How do you go and manage your keys? If your ML models are sitting in Git repository, how will you go and access that? Is it central or not? Again, the point that was mentioned, are you storing your credentials in your repository, right? Those kind of things will come about in something that you can work with. Next one is around cost optimization. Again, this can go into so many different ways. We'll probably go on the reverse on this one, because generally resourcing is something that we associate ourselves to quite a lot. So resourcing is what, right? When you talk about costing, you can use managed services, you can use experimentation, you can use different other elements of costing. But the key aspect is not just that. It's not just about right sizing. It's also about planning and tracking as well, and reporting on that, right? How are you thinking of your estimates? How are you tracking it? Do you have some mechanism of doing it? And again, think of this from ML models perspective. You have an experiment running on, which can last up to a day or a week. How do you think the cost is going to look like? Is it going to breach the numbers? Is it still intact? If it doesn't breach the numbers, then what do you do, right? Those are the aspects that you need to think about. Moving on to operations excellence, again, automation is something that we have been talking about and hearing about quite a bit. There are certain kind of principles that I generally work with. I've managed productions, I've worked in productions, code everything, but then modularize iteratively as well. Just coding everything doesn't get the job done. You then have to consolidate as well. At some point, you have to think about refactoring. When you modularize it, you can reuse your code. That's the whole intent of doing coding, right? Define your iteration and versioning strategy for data, for model, for environment. All these different elements, they will add to this. And then at the same time, tear down every time. Persistence is luxury when it comes to data. Again, I'm not saying go and drop your databases. What we're doing machine learning operations right now, right? You don't want the whole machine learning extract available all the time. If you're thinking that, then probably you should revisit that. That's not the intent. Okay. And the last one is around reliability, which is more about, if I just jump on quickly, know your numbers. Again, planning is a big aspect in this. What are your SLAs? What are your SLO? What is MTTR, MTDBF? If you don't know these things, think about them. They apply to machine learning as well. You may not be thinking of it from development point of view, but the moment you go and hit production, you need to think about these. If you don't, IT director will ask you to do that. So just be conscious of that. From SRE perspective, think about immutable infrastructure. And obviously, I think that's the one key aspect, automated everything as much as possible, including testing. And then lastly is around performance efficiency. Again, the same aspect, what are your numbers? What are you targeting for? You want a performance system, but how much performant? Do you want everything come back to you in seconds? If not, then how much? It's hard question business do not know the answers for, unfortunately, and we need to help them on that. And it applies to machine learning as well. And lastly is around monitoring. One bit I'll say on monitoring, not just for performance, but for other aspects of pillars as well. Don't just look at what is my workload, what is my occupancy looking like right now? How much resources I'm consuming? Think of throughput. Think of how much resources you have provided, how much data it has consumed and processed, because that will give you a better indication of what's happening. Because you can get a job done in 10 seconds by using a service which is going to be $10,000 a month, but you can't afford that, right? So think on those lines. Monitoring is not just about monitoring the resources, it actually is about monitoring the throughput, because that's the right value out of this all. Cool. So look, I know I'm a bit short on time. I think I've gone over as well. Apologies for that. Don't be shy. This is the whole thing. If you have any questions, please grab me, and we can definitely talk a bit more on this. Thank you so much.
Thank you, Vikas, for that very informative talk. In the interest of time, like you said, we're going to move on to the next speakers. Next up, we have two speakers from AWS presenting about simplifying data management using data manifold. First up, we have Timothy Downs, who is a solutions architect, and his fun fact is that he grew up on a Kiwi farm. And joining him, we have Jane Uy, who, along with being a solutions architect, has a 1-year-old toddler and 2 pet rabbits. Over to you guys.
Thanks very much. So what I'd like to talk to you about today is an open source solution that we've released over the last few weeks called ADA, or Automated Data Analytics. This is for simplified data management on AWS. So for this, I want to introduce the real star of our presentation, which is not myself or Jane. It's the data engineer. So I listened to Jenna's talk, and we took the Wikipedia list of what a data engineer needs to consider. A data engineer needs to consider so many things every day. It's a tough job. So what is a day in the life of a data engineer? Because what we want to look at is, what are the challenges? What are the problems that data engineers are facing currently? And let's look at a day in the life. Keeping in mind, the data engineer needs to consider about all of the things we just talked about in this previous slide. The data engineer needs to think about the governance, security, monitoring, all of these things. Let's consider their day. The business comes up to our data engineer. Marketing team, are our customers churning? The data scientists, can you give us real-time data for our ML models? Finance, the board needs lead conversion numbers. And this is just in the morning. What they're really saying is, give us good quality, updated, compliant, secured, and clean data, and we want it yesterday. So this is what we face every day as a data engineer. So a data engineer wants to solve all of these challenges. A data engineer would like to create a data platform to solve this. To create a data platform, at AWS, we have a lot of native services to solve this. So we may want to have real-time data streaming. For real-time data streaming, we may ingest our data from Kinesis. We may flow through from Kinesis to, let's say, Kinesis Data Analytics to join that to other streams. There's a lot of things to consider here. To create a mature data pipeline, we have a lot of services. Keeping in mind what a data engineer needs to consider, and then we look at, let's say, a mature architectural diagram of how they might deliver this, we hit a bit of a snag. So we need to give marketing their conversion data. We need to get the board report ready. And now we need a data platform. Can we please have the data platform by this afternoon as well? Hang on. So can you guys produce this by 6 p.m. today, please? Does that seem doable? It's a hard task. We need to consider so many different problems. We need to create a mature platform using many of the tools we have at our disposal. This is why we've published an open source package, ADA, or Automated Data Analytics. So this is something which we've published over the last few weeks. And this is a one-click deployment. And let's have a look at how this can help the data engineer with their rather difficult day. So ADA is a platform that takes the native AWS services that we provide, and it provides that without needing to understand the details of how those things are put together. The data engineer doesn't need to write a line of code or understand how an IAM role works. However, they can still keep the data running within their own AWS environment using AWS native services. So under the hood, this will store the data on S3. Under the hood, it will use Glue to transform the data. The data engineer doesn't need to consider that. They can have a data platform in their AWS account using native AWS services, and they can have this without writing a line of code. And it's an open source tool. So what does this data platform give the data engineer? This platform, and we'll give a demo in a moment so this all makes a bit more sense. This data platform will ingest data from a list of sources. So that's AWS sources or third-party data sources. It's an open source connector framework. So if you need a source that's not covered, you can create a connector relatively easily. Ada will redact your PII data. You can make sure that the emails are not viewable by an attacker. It integrates with your access control system. It doesn't require coding, and it gives you a very granular security control. So, native AWS services without having to configure them yourself, one-click deployment. Let's get to a demo. I'm going to hand over to my colleague Jane, who's going to take us through what it looks like.
Yeah, hi everyone, I'm Jane. In the real world, we would like to give you a live demo, but due to time constraints, we'll just walk you through the code. But if you have time later and you're interested, we have a booth and we have people that are happy to walk you through a live demo there. So on to Ada. So I'm going to put together a scenario where you've been handed two files as a data engineer. Say marketing has run a campaign. They've picked up some new customers. They've also got some, conversion rate numbers, right? So two CSV files and they've gone, give us a report, right? So let's walk through this scenario and how it will look like in Ada. So the ask from marketing, customer conversion rate from a recent campaign. That's a very common question. So logging into Ada, this is what you get. So this is our dashboard. You can see down here, it's a list of data products that's already in Ada. If you look on the list, you see, so we've pre-prepared some. You see different source types. So this is the connectors that Tim was talking about. So we've got files coming from file uploads. We've got files sitting in the S3 buckets. We've got files sitting outside of S3, maybe in a different cloud provider as well. You could write a custom connector, get it in there. Out of the box, there's a few that's already supported. So as a data engineer or even marketing person coming into Ada, not knowing any code, I could easily come in here and go, you know what, I'm going to create a new data product based on the campaign that we've recently ran. And this is how it looks like, right? So you go over here, go create data product, and you get this pop-up screen going. All right, give us a domain for your data product. That's just a way we've grouped products together. So we've gone, all right, this is the unicorn marketing team. So that's our domain. We're naming our data product customer, to be more specific. You come in here and choose the source type that you've got, right? So it's kind of, it is really ClickOps to get it true. So in our case, we'll do a file upload. And that's all you need to do to get your file into the platform that Tim showed just now. We'll come back to this automatic PII data a bit later. So on to the next screen. You've loaded your data, you've uploaded your file. I've picked my file, dragged and dropped it. The ingestion phase gives you a schema preview. So this is Ada processing your data, going, this is the schema that we've worked out from your data, from your CSV file. So we've worked out that you've got email address, a country, a registration, and a favorite color. And all good. Now you could take it as it is, or you could do a bit of transformation. So in our case, if you remember, registration was a date, and it's come back as a string here. So what we could do is we could then just go, you know what, I'm going to apply some transformation. So go on to the next step, and we've got built-in transformations here that you can just drag and drop. So in our case, we've done the apply mapping, and we've changed registration into a created date with a date format instead. Don't need to do anything else, but just for purpose of the demo, you can drop fields, relationalize stuff, select fields, and so on and so forth. So open source connectors, plugins kind of thing, build your own if it's not here. But in our case, we're happy. The preview looks about right. We're off to the next slide. Now that's all you need to do to get the data into Ada. So you've done the campaign data as well, and that's all this. Next step is go off to the query workbench, and you can query your data. You can join it with existing data products that you have access to within your database. And off you go, really. So marketing can go wild here and write their own SQL queries. If they're not familiar with that, you could write the SQL query for them, or the best bit is it also connects out to other third-party kind of visualization too, like QuickSight, Power BI, and so forth, so on and so forth. So that's it. That's our use case done, right? And doesn't require, I guess, a data engineer to set anything up at all. Now, if you look closely into this email field, you'll notice that it's all hashed, right? So you don't get any email address leaked out here. So Ada had that feature. Remember that toggle that we said we'll get back to previously, the one that redacted PII data. So if you switch that on, it will automatically go and look for PII data. And then according to your settings, it will either hide it or hash it for different user groups. So in this case, if I go into the governance tab of Ada, I have previously set this up. So if it finds an email address, it will hide it for default users, and it will hash it for power users and admins. So I'm an admin user, so when I query the data, it would appear hash. But if a normal user goes in, they won't be able to see our email address. And you can set up all these governance attributes through Ada. And this is an example of one that has been set up already. So PII reduction kind of automatically done for you as well. So that's the original menu. We've done data product, we've done the query workbench, we've done governance. So we're doing a bit about identity provider now. So Ada can connect to your existing data identity provider. So you can federate them into Ada and manage them here, manage your users here, and you can set them up into groups. Out of the box, we have 3 groups set up for you with different access level. It's up to you how you manage it. You can also set up custom groups based on your different use case and give people access to kind of different things. Fairly straightforward. Another last feature I'll call out is we've got a cost explorer as well, because one question we get a lot when we work with customers is, how much does my data platform cost? Ada gives it to you, as well as the running cost of Ada as well here. You can see on an account level how much you've spent on Ada, and all the underlying infrastructure is spun up for you. There is also a cost section broken down by service. So you can look at the EC2 cost, the KMS cost, Kinesis cost, and all to what Ada has spun up for you in the background. So the beauty of it is it's all AWS native services that you are probably familiar with from your day-to-day managing them. And Ada is really just a light layer on top of it to take away the heavy lifting of having to set things up over and over again for yourself. So for those interested, this is our open source solution repo. You scan the QR code, it will link you to it. But otherwise, we're more than happy to show you a live demo or talk to you about it at our booth after this. I'm going to leave it at this slide, but that's all the content we have to present. So we have a bit of time for questions, if there's any. Yes.
you said to set up a new pipeline. Can you automate that with the SQL CloudFormation or any sort of automated?
Under the hood, it's CloudFormation. So the whole solution is a CloudFormation. It's a stack. So after that point, it's ClickOps. So if you mean, can you deploy? So you deploy the whole stack as CloudFormation. If you were to deploy a new pipeline in that as CloudFormation, is that what your question is?
I think you can't at the moment, mainly because ADA's got very strict architecture and kind of everything that we heard from the well-architected review. So we've got very strong opinion. It's very strong opinionated on security, governance, and all. So it requires things to be set up a certain way, so that you don't have to worry about, have I put my data in the right place? Have I got the right IAM rows and S3 buckets set up? So with that, it doesn't, I guess, make so much sense to be allowing imports of, CloudFormation stack into it, unless we find a way of validating it. Then again, it's an open source solution, so happy to, see what the community asks us and support it that way too.
Yeah.
One more question. What about the access to the dashboard? Is it posted on a domain, or like how do people get access? Do you have to give them access to AWS accounts?
It doesn't require access to your AWS console. So the beauty of Ada is your users do not need to necessarily use the AWS console. It can hook up to your SSO instead, and it actually runs within the account that you install it to. And it's hosted from that AWS account. So under the hood, it's running Lambdas and so on, and whichever domain you configure it to when you're setting it up.
Okay, awesome. Thanks, guys.
Thank you, Jane and Timothy. So looking forward to our next speaker. We have a veteran here who's spent about 34 years in the industry. It's specifically in data integration, databases, and BI. Andrew Conacher, who is a solution consultant at Neo4j, will be speaking to us about the customer journey analytics using graph technology. And they're running away.
Cool. Okay. Thank you. Everyone here okay? All right. Show in the room. Hands up anyone who's heard of Neo4j before we all use it. Give your hands up if you use it. Still looks like about a quarter to a third of the people who are here. Okay, so I'm going to spend the next 20 minutes going through some examples of observing customer journeys and how we can use Neo4j platform to look at that, and to actually do some data engineering and to manufacture some more information about what we know about our customers. And we'll also touch on roast chicken along the way as well. So analysing it, so I'm going to talk a little bit about graphs, and we'll look at what we can understand about our customers, look at their interactions and how they interact with your business. I've got a couple of examples, one of retail and one in telco, what we can learn from these customers, and how we can arrive at mutually beneficial outcomes. I'll start there with a bit about graphs. So I joined Neo4j almost a year ago. I've got a history of working in databases in the past. I've worked at IBM and worked in industry models. And when I first looked at graphs, they looked like to me a logical, very high-level, logical, conceptual view of a system. What I rapidly learned was that they're actually a lot more than that. This is the actual data. It's what the data looks like. So a graph stores information. A native property graph like Neo4j stores information very, very differently. It's stored using these constructs. Oops, excuse me, let me put this point on. These constructs such as nodes. So I'm going to go through these now. So a node is the key plank of storage within a graph. It represents an entity. We have relationships which connect nodes together. That's what we're seeing here with these arrows, S and owners. We have properties which describe the node relationship. These are like attributes. A label is a way of classifying a node. So we've got in this example here, we've got person nodes, we've got and a node with that represents a location and a residence. We can actually have multiple labels. And then finally, there's the relationship type itself. So in the example here we've got married to, lives that owns. These are all examples of relationships. And if you've done any looked at any literature, any literature on graphs, you'll hear about vertices and edges, or in this world, a node is a vertex and a relationship is an edge. You'll see that those terms come up frequently. So a couple of things I want to point out. There's multiple relationships, so you'll see that Michelle and Andre, these two people, they're person nodes. They're married and they live together. You also see we've got some properties there. They've got their name, they've got their date of birth. One's got a Twitter handle and one's got a status, so it's schemaless. We're not imposing a rigid set of properties on every possible node. So it can be absolutely mutually exclusive properties there. So I'm going to move on to the next. And what I want to stress is that physically this is what's being stored. All of these components here are first-class citizens, specifically the relationships. When you're thinking about graphs, it's the relationships and the links and the persistence of those, and those becoming part of the data and letting you address the data, which we're going to shortly, which are the key tenet for using graph technology. There's no graph-like view over a veneer over a document or a relational structure going on here. We actually are storing this information with pointers assisting on this, which will lead to something like this. Now, there's multiple domains here. If you look carefully, you'll see we've got a customer. This is a meta model, so I'm only showing the label. The actual model with real data would be a lot easier. We've got a customer. We've got employees who have interacted with the customer, potentially by devices. If you look carefully, you'll see lots of the people having sessions, placing orders. There's lots and lots of different domains here. So very quickly, as your graph evolves, and it can evolve from a very simple state and then evolve and very extensible, very easily extended to look something like this. But it can look complex and start to get complex. So I guess it's starting to get complex. So how do we reach into that and address that and use it? Well, we have a dialog called Cypher. There's actually a project called Cypher as well. It's our query language we use to reach in and get data out of our graph. It's very much like, so it's not like SQL. It's like SQL graphs. It's not like SQL, but it's a language for graphs, which is inspired by SQL. So we focus, allows us to focus on what we want to pull out. So those relationships you've seen there, we're going to go and address it. We're going to go and address the graph in that way. So if we look at this query down the bottom here, it's funny, we've got the beginning, so there's a very basic one. We'll say keyword is match. Match, you see something like in there for J. Match the label person with the person with the name Dan. He's a love relationship. We actually don't know who this is. We can just say whom, and that's a variable that gets returned. We can interrogate that and see if it is in fact the Dan loves. So just to look at some examples of Cypher in action, who owns the house in this particular street? So the same picture we saw before. The query looks like this. We're addressing a couple of nodes. We're matching the person who owns the residence, where the address is. 475 Broad Street, return P, and P is actually that person. Okay, so we would get Michelle back. Just to extend on that, who's married to the person who owns the house? Query gets a little more complex. Same query, just a little bit more information. We say, using referencing the married to relationship to this other person with P2, and we return P2. Our name is giving us this person, Andre, who's married to Michelle, who owns the house. So there's some basic examples of Cypher in action. Why is customer journey analytics important? Well, if we understand our interactions with customers, so our interactions with our business and remember them, then we can have a personalised relationship with that customer, and they're going to value that relationship with your business. From a business point of view, if have an overview of the customer's experience, then you can go and exploit those points that work. You can go and use those channels, departments or things, channels, and derive value, which is beneficial for not only yourself but for your customer. So a broader customer journey analytics model would have multiple domains. Customer is central to the model. Like you may have heard of the term customer 360. This is an example of a customer 360 model. There's multiple domains. We've got their web activity, their tweets, any promotions that have been served to them, their friends, their households, householding, so relationships of people living under the same roof, for instance, any support interactions that they have. So it gets very rich. But what I'm going to do now, because we're at a data engineering conference in a moment, giving some examples of how we can do some data engineering functions on the data in graph. I'm going to compare it back to quite a simple example, shopping example, and spend a few minutes on that. So we've got this, excuse me, problem. We've got this individual, Albert. He's been shopping. He's made 3 trips to a supermarket to do some shopping. Okay, three different purchases on 3 different occasions. On each occasion, he's bought roast chicken. So this is the roast chicken I was referring to earlier. And a couple of occasions he's bought product. He's bought beer nuts as well. He shopped at McKinnon and he shopped at Bentley. For those who know the area, they're geographically quite close to each other. Now, looking at this data, we can see that every time he shopped, he's gone and bought roast chicken. So we can make an inference from that Albert really likes roast chicken. And he also likes beer nuts as well. So what we can do with Neo4j, not only query, you can also go, as I was alluding to before, you can also go manufacture other relationships and build out your graph to be more addressable and more useful. So what we've got is a bit of code here. I'm not going to step through the whole thing, but it's what we call that cipher code. And the key thing here is we do a bit of aggregation, decide to look at how often they're actually making a purchase, and then build a strength attribute. And then this merge command lets me create a new relationship. So I'm going to create a relationship between customer and product. I'm going to set a strength with something strongly liked or meaning or they're indifferent. What happens in our model is we actually get a new set of relationships. These 2 likes now directly from Albert to these customers. Now, if you look at this, that's just a really simple example. You go back to that really complex customer analytics example, have the multiple domains. You think about use your imagination, think of the sort of things you can do to evolve that graph and go and build more and more relationships in it and make it become more addressable and more useful. I'm just going to step through a couple more examples. They also, you may want to attribute your customers. So some customers in retail have heard the term pantry stuffer. So where customers buy something more of something when it's on sale. So we can run some analysis to see if that's in fact the case, and we can set the shopper type to be a pantry stuffer, and then the attributes for Albert is now being classified as a pantry stuffer, and we can use this, and I'm going to come back to that and use this in a moment. Final one is to set what's their favourite store or domicile store. When I worked in database marketing many years ago, this was the thing they used to refer to as a domicile store, the one that was central, the one they used the most. We're setting a new relationship type here. So the graph has now evolved. This really simple subgraph has now evolved to have these three other relationships here now. We can use those to drive new questions. You don't even have to touch the other information. So reaching out to customers now. I'm just going to go back a moment. Yeah, have a look here. There's also a flooding event at a particular store. McKinnon had a flooding event. There's probably some customers are impacted by that. So we could reach out and say, well, match those events and the store, who had their favourite store, and the particular products that they like. So who was affected by the flooding event in McKinnon? Let's proactively reach out and with an offer for the products they like. The marketing offers customers, so that using a pantry shop, for example, I just spoke about, we match products to the customers at a particular store, and you might make offers for them to go into that store. So there's any number of different applications of that. I hope I'm getting the message across. All the while, using these new relationships that I've derived just by doing a little bit of engineering of the data. So back to our model, we wind up with, once I said, I want you to consider when you've got a model with more domains and the types of things you can do, think about those examples I just gave, and then think about your world of the with multiple domains and customer. It doesn't have to be customer, it could be something else, it could be products, it could be some other type of 360 view. But use this as just hopefully to inspire some thought there. Now I've got another example which is slightly different. It's a telco. This is a path. So graph databases down there, Neo4j, particularly do this very well. Does very well. Is we can build a relationship. It's actually a simple relationship. It's not someone bought a product. It's actually a chain of events. So there was a service subscription which was someone established with a business, and all of these little pink nodes are all effectively a monthly statement of usage. The larger, more obvious ones are the ones where the customers had an adverse relationship. And you'll see, if you look carefully, you'll see there's been customer phone calls, there's been help desk contacts. Ultimately, though, what happened was we had a non-renewal event at the end, 13 months later. And that's a consequence of, very likely to be a consequence of the experience they've had, which included, in fact, a no service impact towards the back end, about 2/3 of the way through their journey. Now, this sort of information can be used in data science. Our intuition looking at this data can get us so far. We also have data science capabilities within Neo4j to take us further. So if we were to, that churn prediction you just saw a moment ago, we could take that sequence of events and use that as an input into some models to then go and look at things like trend prediction and link prediction. So we actually have link prediction algorithms that can assist us with that. We've also got, there's multiple use cases. Just highlight a couple of other ones. Disambiguation, just read it. And segmentation. In an age now where we don't have, where cookies are getting harvested, we're starting to use, maybe limited to using things like device IDs and locations and browser types and things like this to try and identify who someone might be. You may not ever actually know who the person is, but you can build a profile of that person when you see that person come along and do some collaborative filtering. Often they make them offers, give them personalised recommendations. I think if you look back to what we were doing earlier on in the graph and looking at what people like, that's a step towards. That's one of the steps towards building out a recommendation engine, which is one of the key uses of graphs. I know if you're interested in disambiguation, I've got it right, and recommendations and the like, I encourage you to have a look at a case study called Meredith Corporation in the US. Now we have over 65 algorithms, highlighted the link prediction one, which we could potentially use for looking for things like churn or non-renewal, for instance. We encourage you to look at these. We have online readily available online information and many courses on Medium which discuss the application of this. To get data in, we're getting back on the engineering trial, getting data in and out of Neo4j. We've got a number of different ways. We've got that Cypher language that you saw. I can read CSV files there. We have a stored procedure library called APOC. We've got some tools that you'll be familiar with. So real time, things like Kafka. We've got some older traditional tools like Talent, and newer ones like Hop. We've got Apache Arrow. There's Apache Arrow's Apache Arrow project has a sub-project called Flight, which is a fast data transfer mechanism. We're using that. We've also got a GraphQL library, so if you want to build a GraphQL-based application on top of Neo4j, you're able to. We support a whole lot of different drivers, Java, Python. The other day I was just using Spark and Databricks. We use that as well. I was using it just the other day with Jupyter to load the Neo4j. Thank you. There's also some community developed drivers. There's actually more than that available as well. So to get started with Neo4j and learn about it, there's a couple of links. I encourage you to have a look at it. If you're interested, come and talk to us afterwards. You can also visit the Graph Academy, neo4j.com, and we also have you can deploy Neo4j on premises or use our managed service or as we do have a free version for Airbnb as well that you can use indefinitely without certain constraints. So with that, I'm done. I think I've got a couple of minutes to go. If anyone's got questions? Or does anyone want to go to coffee? Thanks for that. Looking at that event path that you wrote earlier, now, obviously you can hand stitch that yourself, and there was a brief slide about the very sort of methods that are available. Is it possible within the Cypher language to say, match on this attribute and then use this attribute to sort of discriminate time, building me a chain block? Yes, it's fantastic. Because looking at my hand would be a real pain in the ass, so good. That was actually based on time, yeah.
Do we have any more questions? Yeah.
Hi, first and after presentation, thanks for that. Just one question. Since it has a lot of models, like it supports a lot of models and languages, does it have capability to suggest the most optimized method of modeling? Because based on the data sets, I think one of the most time-consuming parts to identify which would be the, based on the data set, which would be the most suitable modeling technique. So does it provide the optimization method?
We do have tools that help you with that. So you will start with a use case, and your model will be driven, your model design will be driven by your usage, but we also do have the ability to get reports that we run out of logs to look at the way the platform's being used and suggest things, and we can look at cardinalities and how things being accessed and other recommendations.
Awesome, thank you.
Just a quick question for me. How does it work with really large data sets?
Works really well for really large data sets. You're going to need a bit of memory. We've got customers who've got billions of nodes running on a single instance chain. So we do big data.
Awesome. Thanks, Andrew, for giving us insights into Neo4j. We will now be breaking for a quick afternoon tea break. We'll be returning at 3:30 sharp. Hope you all have been collecting your sponsor stamps. This will be a last chance to collect them. And remember that we need at least 6 to enter the raffle. So.
I just wanted to add a few things. Thank you so much, Lydia. A couple of the sponsors are doing raffle draws. They said that they were going to do the raffle draw at say 4 o'clock in the afternoon. The raffle draw is going to be right now in the afternoon tea break. Because when we wrap up the conference, we're going to head down for the after party down at the Mo pretty much directly, so there won't be much time to get along to any of that. So we do those raffle draws in the break, and then after the break, once you've sort of put through all your stamp cards, we're going to do the raffle draw for the Legos as well, because what's the data engineering conference without some Lego, right? Okay, enjoy the break. Cheers, bye.
Yo, 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 testing. Party started. No, no, no. The power one. It was better. Charge it back. Yes, I just want to walk. It's on. That's pretty
Mr. Dale, any luck on that line? No. No, it's okay. We're going to bring laptops to the bio.
can we start? Happy winners this afternoon. There's VR headsets and a few other bits and pieces that are pretty awesome. So we've got a couple more prizes. We've got 2 Lego kits up on stage, so there can be more winners for sure. Who would like to come up on stage and draw the winner? Aditya, would you like to read out the first person? You've got the magic hands.
Okay. And the first winner is Kai Richardson.
Wow, didn't you win something before? Congratulations. All right. It's been a successful day, my friend. Yeah. So you've got your choice
of the NASA lunar lander, or the beautiful bonsai tree.
Oh, I'm going to go to lander.
The lander?
Yeah, absolutely. Thank you very much.
You're absolutely most welcome. Thanks for coming along today. All right, Aditya, we got another one.
Yep. Second winner is Caleb Hikes. Do we have? Oh my God!
My goodness. What's in the water that they serve?
I didn't get the book.
Okay. Well, we've got a bonsai tree. That looks amazing.
Thank you very, very much.
Congratulations. Well done. Awesome. All right, I might let you, Aditya, take it away, or do the introduction. Yep. Well, you're going to do that one?
Yep.
All right.
All right, welcome back everyone to the late afternoon session. Our next speaker will be hearing about setting your data streams in motion in the ocean. From Warren Vela, a solutions engineer at Confluent, who has a background in enterprise architecture and operation mission critical systems, but as well is also involved in a community focused on building smart homes. Please welcome Warren to the stage.
Thank you, thank you, thank you. Hope you're feeling a bit more refreshed and energized after a fix of coffee. It's a tough slot to be talking late in the day, but I think you're going to be a bit more energized after you see this demo, because who doesn't love seeing some flashing LEDs? My name is Warren Vela. I'm a solutions engineer at Confluent. And if you're not familiar with Confluent, Confluent is a data streaming platform that was built by the founders of Apache Kafka. And working at Confluent in this region has really given me the opportunity to see many customers and many interesting use cases solving some really unique challenges. So over the next about 20 minutes or so, we're going to take a look at a bit of an interesting application of a data streaming pipeline of real-time edge processing that is being used to solve, I think, a pretty interesting problem. So the challenge was set. How do we prevent equipment failure and provide real-time analytics on a ship that's sailing in the middle of the ocean without any connectivity to the internet? And of course, when a challenge like this arises, there's no better opportunity to use that as an excuse to play around with a 3D printer and a Raspberry Pi. So I set off and I said, I'm going to build this little demo to see how we can actually simulate this using a technique around processing event streams in real time on an edge device. So the first question I asked myself was, how can we actually do this using event streaming patterns? So Raspberry Pi and Confluent is just a match made in heaven. And of course, there's some key event streaming capabilities here that we can use, starting off with Apache Kafka. Now, Apache Kafka is a storage layer used to support publishing and subscription of data streams. And it's not just about moving events around through like a queue. Kafka is actually a storage layer. So you can kind of think of Apache Kafka in this scenario as kind of like a flight recorder for the IoT data that's being generated on the actual device itself. But then we need a bit of a layer to process this data. So using stream processing, we can use KSQL DB as a stream processing layer to do some really interesting processing on the actual device. So we can do things like filtering out data streams, masking data, joining data from multiple streams together to create some interesting data sets. And we'll look at how we're using KSQL DB to generate some reactions on this device itself. Of course, we need a way to specify and introduce some data quality into the streams of our data. And using a schema registry, we can use things like Avro and JSON schemas to really ensure that our data streams are of a certain quality and that we can describe the events that are actually flowing through the streams themselves. But we need to get the data off the ship somehow, right? So using cluster linking, we can take a certain set of data streams off the actual device and send that into cloud, in this case, for further upstream processing. And that could be for analytics purposes, as we'll see in the demo. And then lastly, using pre-built connectors, we want to send this data and do some interesting things with this data that we're generating. So using the Confluent pre-built connectors, we want to connect this into some dashboarding tool to actually see this data in a live dashboard. And all of this is running on a Raspberry Pi on the device, and we'll see how we're sending that up into the cloud. So here we have a very highly technical drawing of the ship. And we're just going to talk through the kind of concept and the architecture of the demo, and then we're actually going to dive a little bit deeper into how it's actually running. So the idea is that on the Raspberry Pi, which is located on the actual ship itself, we're running the core components that we need. So we're running Apache Kafka, we're running KSQL DB, and we're running an instance of the schema registry. The core components that we need to be able to process these event streams. We take data from a temperature probe, which is this little guy that's sticking out the top here, that's recording the current temperature in this room as we speak every 1 second to a topic within Kafka. And that data is just being logged every second, the current temperature. We've also got some other probes on the ship. They're just simple Python microservices that are doing things like testing internet connectivity, testing the health of the Confluent platform, and just testing out the temperature so we can turn on and off these lights. But this temperature probe is just logging the data on the ship. And the idea here is that we take this raw data, which is just a stream of temperature readings, and we do some processing on the ship for things like, is there a spike in temperature in the last minute or so? And let's react to that event, right? And so we've got a KSQL DB application that's running in real time that's measuring a change in temperature. And if there is a change, generate another event. And we have another service that's just listening for those warning events that will trigger off a sequence of lights here, which is just simulating a warning signal like something's gone wrong. And we've also got other sensors as well that's just checking for internet connectivity, and if the health of the Confluent platform is not running, it'll change the color of the LED lights. So you can kind of think of this demo as doing on-ship raw data aggregation, but also event-driven reactions where the lights are actually, LEDs are actually reacting to events that are happening on the ship. And we take this data and we use cluster linking to send it, in this case, to Confluent Cloud. Now in Confluent Cloud, we're running another instance of the Confluent platform, which is effectively, in this case, Kafka, KSQL DB, and the schema registry. And we're receiving only a copy of the aggregated data set. Because of course, we don't need to see every reading every second. So we only want to send an aggregated copy of the data because in this case here, our internet connectivity is quite unstable. And once the data is in Confluent Cloud, we're then using a Splunk connector to send that data set into a Splunk dashboard, just as an example to showcase how we can use that data in a dashboard. So let's actually see how that's running. So we can just get this video played. Okay, so here I'm just going to log into the Raspberry Pi and just check that the Confluent services are up and running. So this is just Confluent services running natively on the Raspberry Pi. They can also be run in a Docker container on the device itself, but in this case, it's just running natively on the Raspberry Pi. Here we can see that they're active, they're running, they're ready to receive some data. Next, I'm going to check the Python services. So in this case here, I just want to check that my Python services are running, and these services are just literally producing data to Kafka and consuming data from Kafka. That's all they're doing. We'll look at a producer application. So this is a Python application. It's very kind of standard way of writing a producer bit of code. But just to show you the actual line of code that's going to connect into Kafka first. So we just create a configuration into Kafka, and it's a serializing producer, which means that we're going to serialize it in Avro. We're going to get the temperature from the actual sensor, and we're going to literally just produce an event into a Kafka topic. And this will just happen every second on a loop. And now we'll see what that data looks like on Kafka. So here I've got the control center, which is just a control plane as a view into the ship itself. And here we can see the Kafka topics that are running on the Raspberry Pi. There's a few topics here. There's not that many of them. But the first one that we'll take a look at is the actual raw IoT temperature data. This is just a topic that's storing events as they're happening in real time. As we can see here, every second we get an event that's coming from the current temperature. We can actually look at the schema of the event as well. This is a function of the schema registry. This is a description of the event. It's a very simple event, and it contains the source where it came from, the temperature reading itself, and a timestamp of when that temperature was read. And this is, again, a way that we can describe the event so that we can ensure that the events meet a certain quality. Here we can see some more topics of the other data sets that are coming into Kafka. We want to do some processing with this data. So using KSQLDB, which is currently also running on the ship itself, let's take a look at the flow of data in a stream processing pipeline. This is the KSQLDB interface. Here we can see the streams that are available to look at. And we'll take a look at one specific flow, which is the temperature streaming flow. So starting off with that raw data, which is what we just saw before, here we can see the raw data events being produced into KSQLDB stream. Now, KSQLDB also has the concept of a table, which, if you're familiar with the database, is a way that you can actually query your data in Kafka, but in tabular form, right? And let's take a look at what we can use that for. So in this case here, we don't want to look at all of the events that happened, every single second. We want to use KSQLDB to materialize a view of the data and just give us the latest temperature. So here I'm back on the Raspberry Pi, and I'm using the KSQL command line interface to write a very simple select statement to view the last temperature. You'll be very familiar with this language. KSQLDB is a SQL-like language to query data in Kafka. These are the tables that I've created in KSQLDB, and I'm literally just going to do a select all from a table called latest temperature. And here I can see the latest temperature. And the thing to note about this is a table view giving me just the last event, okay? And we'll see here as the temperature changes, the query will now start showing us that latest event, that latest changed temperature. So you can kind of use Kafka to materialize data into a view and actually query it like you're querying like a relational database, right? That's pretty cool. But we can do some other interesting things with the data as well. So the first thing we want to do here is actually compare the current temperature with the temperature that was last read. So I'm just taking the current temperature and the temperature reading that was one before, and I'm just creating another event stream from that. And so in this event stream here, we'll see that this new event just gives me where in the topic my current reading is and the previous one. And this is how we'll use, this is how we'll find those events to calculate the percentage difference between those two readings. So further on in the pipeline, we're creating another stream here, which is going to calculate the percentage difference between the current temperature reading and my previous reading. That's all it does, okay? It's a very simple create stream statement, very similar to SQL language. If you're familiar with using SQL inner joins, you'll be very familiar with this. But here we get a really interesting data stream because now we get the percentage difference between the two temperature readings. We'll take a look at an example of this. Our current reading is 22, and the previous reading here was 21.9, so the percentage difference is 0.2%. This is all calculated on the fly every time an event stream has been processed. There's no back-end databases for this. It's just all running through a stream processing pipeline. And with this data, we can materialize this into some other interesting views. So here I'm creating another table. And we want to do things like, what's the maximum temperature? What was the average temperature, minimum temperatures, and what was the maximum change in temperature? And I'm taking a view in 30-second windows, okay? So if we go back into KSQL DB and we look at this next table, this temperature stats table, we can actually start to do some real-time aggregation and calculation on that data set and look at things like mins and max in 30-second windows, okay? So you can use stream processing to slice up your data, join data from other data streams, and do actual processing and calculate some statistics on that data as it's flowing in real time. We've got some window start and ends here, how many readings there was, the max temp, min temp, average, and the change in percentage. All of this data is stored in a Kafka topic. There's no other databases here. The next way we want to look at this data is we actually want to generate a warning event when the percentage change between the previous and the current value is above a certain threshold. And this event here will only be generated when that warning event happens, okay? So if we take a look at this actual stream itself, I think I've got the threshold set to 0.4% so we can actually see it changing. So if the percentage difference is 0.4%, create a new event, okay? Now that consuming application is just listening and waiting for every time one of these events happens, and when it receives one of these events, it'll then trigger the sequence of red LED lights that you might have seen spinning. This is just, again, another way to see stream processing in a decoupled fashion between producer and consumer. And of course, we can create some other materialized views. In this case here, we're just taking an average of those temperature changes in 1 minute intervals. And we're going to use this particular topic as the actual topic to send the data to our cloud environment, which we'll see shortly here. So this table here is just what was the temperature, what was the average temperature of all of those readings in 1 minute intervals. And as I keep refreshing this query, we'll see the number of readings there increase as new readings are being generated from our real-time stream of raw events. And we can see them increasing there. And that's our current average temperature. So we want to take that value, and that can be the value that we want to send into Confluent Cloud because we don't need all the raw data streams. And then the final thing that we do in this particular pipeline is we just want to convert the data from Avro, which is what it was into JSON for our upstream consumers. So in this case here, with this one-line command, we're just converting it from an Avro format into a JSON format. And we can do the same thing if we want to convert it into protobuf or back into Avro as well. Again, this is our final data stream of every event, every warning event that happened, but now it's in JSON format. So we have the two streams now that we want to send to the cloud. Every warning event and only the temperature, the average temperature over 1 minute intervals. So what you're looking at here is now Confluent Cloud, a SaaS platform. It's a dedicated cluster, in this case running in AWS. And this cluster is a fully managed cluster. We can see some data coming in here. And we'll take a look at cluster linking and how you can use cluster linking to link data sets between two different clusters. So here are the two topics that you see in Confluent Cloud. They are the aggregated data set and the temperature warning stream here. Only two of these topics are being replicated to Confluent Cloud. We can see that mirroring is active. I've got a cluster link created called from ship link, and we can see the messages start flowing through here. In this case here, this stream will only receive events every minute because it's averaging all of the temperature readings. So here we can see what the average temperature was in 1 minute intervals, which is a great use case because we don't want to see all the raw IoT data. In that case, there was 72 readings in that particular interval. Let's take a look at the cluster link itself. So this cluster link has been set up to pull data basically from the cluster or the instance that's running on my ship on the Raspberry Pi and only send these two mirror topics into a cluster in AWS. You can easily replicate this between multi-cloud environments, and you can chain these clusters as well if you have more than one cluster that you want to copy data to. And now that the data is in the cloud, we can use a connector. In this case here, I'm using two instances of the Splunk sync connector. So taking data from Kafka and syncing it into Splunk so that we can create some nice dashboards around this. We've got lots of connectors available for pretty popular sync systems. So here we can see the configuration that's required for a sync connector. So we supply the topic names, the credentials to Kafka, credentials into the Splunk HEC receiver as well. It's JSON format, some very basic, this is all basic standard configuration out of the box that you get through the connector, and then the connector is launched, and it will just listen onto every event that's happening. And then using those same events, we can then create visualizations, right? And so the whole idea here is that this dashboard will be running on the shore, and it's only receiving aggregated events that are coming from the ship. And in this case here, it's an average reading every minute. And so we're not wasting bandwidth and sending the raw data, which is stored on the ship. We're getting the aggregated data that's running, that's sent into the cloud. And in that case, we're basically saving the bandwidth. But when the internet connectivity is unavailable, that data will just bank up in the Kafka topic on the ship for when the internet connectivity is available again. That could be for hours. We can store that data on the Kafka topic indefinitely. So that data is in Confluent Cloud, it's in Splunk, and we can now do whatever we want to do with that from a visualization perspective. So that's the demo. If you're interested in setting up something similar to this, we've got some pretty cool KSQL DB recipes on the developer.confluent.io website. And you can sign up to Confluent Cloud as well. And we've got some vouchers on our table as well. Come down to our booth if you want to have a look at this in a bit more detail. But yeah, head over to developer.confluent.io and hopefully you enjoyed that. Thank you.
Thank you, Warren, for that. We've got another great speaker to come up on stage. Their name is Rohan Garg. They are an Apache Druid project committer and a software engineer at Imply. Previously, he has worked as an engineer on Trino and Apache Hadoop Yarn projects at Qubole. Welcome to the stage.
Thanks. Where is, can you hear me? Yeah, yeah. The clicker. Can I use? All right, yeah. So today I'm going to talk on the topic like best of stream plus batch when streaming analytics isn't. So as the title hints, it's a talk about streaming data and some challenges or some use cases around that. And while doing analytics, what kind of problems or solutions we can run into. So a bit of intro about myself. I'm Rohan. I am a committer on the Apache Druid project, and I work as a software engineer at Imply right now. Previously, I used to work on Trino or Presto, popularly known as that engine, and Apache Yarn. So the agenda for the talk will be first discussing a bit of data platform architectures over time, starting from warehouses to streams. Then we'll move on to what can we do with streaming data and how can we handle or consume it. We'll then move ahead defining what real-time analytics is and what can we do with it. And then we'll enter the Druid and we'll see how can it solve some of the problems that come while doing real-time analytics. Right, so starting with data warehouses. So since 70s, this has been a very popular architecture which people have used for doing data analytics. Like generally, the data was coming from operational databases and it used to get ETL'd into a data warehouse. And the data warehouse was supposed to be like a specialized system with good hardware running, and it used to have like a closed format, and the engine used to be super optimized for querying. And the things that people used to do was to do like maybe do some batch analytics, some reporting, and also at that time like data mining, etc. was very popular, which was being done on data warehouse. So the good thing was that it was a tightly coupled architecture with storage and compute. But the problem was that it had a limited flexibility, but it ran very fast and it support like some specialized use cases. Yeah, so from the last decade or so, there has been introduction of a data lake architecture, which built upon some of the problems which were observed in the data warehouses with time. So there were two aspects to the problems. One was regarding the cost. So since everything was tightly coupled with less flexibility, you mostly had to pay for the peak usage to a data warehouse. And the second problem that was there was that as apps and the data was getting more diverse, you would need to get data out of the data warehouse and put it in somewhere else to do more analytics. For example, things like ML or running some time series databases was getting pretty hard on data warehouses. So what people decided was to throw away the closed formats. They decided to introduce open formats like Parquet or ORC and write all their data from the data sources into a data lake, which is built upon some cheaper storages than what was being used for data warehouses. For example, like HDFS and cloud storages then became very popular as a source for data lake. And then you used to run a ETL using MapReduce and Spark and then re-ingest it in the data lake. So what the goodness of the cheaper storage brings in is that you can just push any kind of data into the storage and then just recompute it and then also land it again back to the data lake. So now what we get with the data lake architecture is that we get a wide diversity of use cases or apps that can use the data. So the first one is the SQL, which was more popular with data warehouses. So there have been multiple query engines like Trino, Hive, or Spark, which directly allow you to run SQL over data lake. And then there were softwares which were running MLAI, or like PyTorch and other things, which also run on raw Parquet files and can just directly ingest them and make them queryable for your model. And then there was another set of apps which are specialized databases like time series databases or graph databases. They can also directly ingest from the data lake or directly query the data lake as well. So you get a wide variety of things with cheaper storages as well, right? And I think recently there has been an introduction of a concept called Lakehouse, which tries to build upon the goodness of data lake and the performance of data warehouses as well and combine them both to bring something to the users. While we think all this is good, we think that in the future, the de facto standard will go towards streaming, because streaming architectures are more true to life and they enable better decision cycles because the data is very real time. So what we see in this architecture is that your data directly goes to an abstraction called a stream hub. A stream hub can be something like an Apache Kafka or Amazon Kinesis or something like that. And you're ingesting into the stream hub as soon as your data is generated. And then you're running your ETL or any kind of transformation that you want via stream processors. There are multiple stream processors that are available like Flink, Spark Streaming, etc. And then you ingest it back to your stream hub. And what happens in this architecture is that you get a level of indirection, whereas you can see the last thing that you can do is that from the stream hub, you can again use the data lake architecture. You can archive the data in batches and put them into a data lake, which can again then get used by multiple apps. But the two new things that you get is that there can be databases which can directly work on streaming data and that can ingest them and that can make them queryable. And the third thing that you can get is a streaming analytics system where, let's say you are running on a stream hub, there are some things that you can do directly on the stream, as was also presented in the earlier talk, that people are trying to get some data directly on the stream as well. So thinking a bit more about the streaming platform, this was a nice picture put up by Confluent, the company which steers Apache Kafka. They have been advertising this picture and they say that this is an easy way to build a streaming platform. And there are nice arrows. This picture is neat and it points to different things. And there is a data warehouse, Hadoop, and all those applications, etc. as well. But if you think about it a bit more concretely, there are multiple questions in it, which requires a bit more thinking. For example, there is this thing called monitoring. What kind of monitoring does it imply? Is it just alerting, observability, or is it some performance metrics observability that you want to do? Then there is some security. There is no idea what kind of security does that imply. Is that an application or some requirements, or is it just put to make some people happy so that there is some sort of security in the system? And then there is search and NoSQL on that side as well. And what kind of things are those? Are they applications, or do they need applications to query, and that kind of things? So it becomes a bit complex if we start thinking of a streaming platform just from the get-go. So talking about something simpler, I would like to just take this simple slide and see what we can do with streaming data. So this is a very simple slide. It says that you have an application and you have a streaming hub library, and you just put the data into a stream hub. That is a simple thing that you can do, and you have ingested your data now to the stream hub. Right. Another popular thing that happens is that a lot of times the apps, they maintain their state in a transactional database, like generally how we write our applications. And then those transactional databases provides a change stream, and that change stream is then ingested into a stream hub. There are softwares which convert those change stream into events, which can be then put into stream hubs. But that is also a very common way of putting things in a stream hub. Like once we have put data into stream hub, there are ways through which we can get data out of it and what we want to do with it. Right? So one way is to use Kafka Connect and Kinesis Firehose. They provide multiple connectors for your enterprise data warehouse and data lakes, and you can just pull data out of your stream hub and then just put it in a database, which we commonly know as a streaming data pipeline. Right? Another common usage of stream hubs is communication between services. So in the microservices architecture, a lot of services contact each other via stream hub. So stream hub acts like a pub sub for different services. One service ingests something, and the other services subscribes on it and reads something. And the goodness that comes is that you get decoupling of services, and the reliability of services increases because a failure of service one won't necessarily take down the whole service too. While this is not related a lot to streaming, but this is a popular thing that people do. So now coming back to streaming data and the analytics on top of that, if you just try to search what are the top streaming analytic products, things like Apache Flink, Spark Streaming, IBM Streams, Azure Stream Analytics, and those things come up. There are more things, like all the clouds provide their own solution, and then there is Kafka Streams, KSQL, Flink, Spark Streaming. But the question is that given all those things, what do I need to do? What can I do with those things and my stream hub? So the simplest thing that you can do is, from a stream hub, you can use a stream processor to generate some alerting and API calls. For example, in the last talk, it was explained that the Raspberry Pi was generating some kind of an alert under some situation where it turns a red light or something. A common alerting thing can be detecting attacks, frauds, or just knowing that something wrong is going or something absurd is going on in the system. Or you can do API calls where, let's say, you can get the data from stream hub into a stream processor and then do capacity planning, etc., just doing some API calls in your system. The next most common thing that you can do using a stream processor is to push the data from the stream hub and then put it into some storage. Something like HDFS or cloud storage is also a very popular way of pushing the data from the stream. Using the stream processors, you do something and then you push it into a storage. Now, what you can do with stream processors as well is that you can write a continuous query. With a continuous query, you can join multiple streams at runtime, or if you have a static set of questions which are important to you, then you can stream the data through those questions and generate some new data, which you can again re-ingest back into the stream hub. And then the stream processors, they just put it into a storage system. So now that we have some semblance of something going on and creating some queries or some processing of data in the stream hub, now let's say we want to build a real-time dashboard. Now what we would need to do is that we are doing some processing via the stream processors that is generating some state. Now we would want to generally put them into a key value store, since they are generally very fast for clients and they provide some kind of querying capabilities over the data which is stored on them. So that is what a lot of people do, that they process their data via stream processors and they have a static set of queries, etc. And then they push it into some KV stores. And then that KV store can plug in your real-time dashboard. So now you have something which refreshes periodically and produces results which you can see and feel good about. There are some stream processors, I think at least Flink does it, which provides you access to even the state which the processor is maintaining. And you can directly use that state to create the real-time dashboard. And that state access or this stream processing either can be done via like a streaming job or like SQL, which is getting more popular with the streaming processors these days. So like this is something that you can get via stream processor, and you can get to a real-time dashboard via that. So as mentioned, like these stream processors are doing continuous query, and there is an unemitted state which is maintained by the stream processor that you can directly access. And then there are KV stores where you are actually pushing your processed data or your processed queries, over which you can do simple things like key lookups or short scans or some pre-computations. So this is what kind of a real-time dashboard would look like with stream processors. But the question that we want to ask is that, like, that thing is good, but is that enough? So the problem that I want to point is that, can we do something like this with stream processors? So what we see here is that a lot of clicks are going on. People are selecting some things. People are grouping on some things. There are lines, charts, graphs, etc. Generally, I believe that it is a bit difficult to do that using the stream processors, because this kind of interactivity requires some other things which the stream processors don't provide. So more formally putting, if you want to do a slice and dice of big data streams, then you are running into a newer set of problems. Then maybe you need data for a longer time, which means that your stream processor now has to think about things like storage systems and the layouts in which the data is stored, which makes it a bit complex for them to do. Also in the GIF, you saw that there was an interactive exploration. What it means is that someone is continuously trying to interact with the data and continuously trying to fire queries, which makes it hard in terms of concurrency for the stream processors to handle. And what happens a lot of time is that you see some absurdity in your system, and you want to then look under the hood of all the reports and the dashboards. And you want to find out maybe some root cause of some good or bad thing that is happening. So that requires some drilling down and some advanced analytics that you want to run, which is a bit hard to do on stream processors. And we also want to maintain that our data is fresh too, so that we don't lose the essence of our real-time data. So a system that is trying to solve all these problems has the following challenges laid out for it. So the first one is scale, because when data is large, you need a lot of servers. You need a distributed service which can scale easily to handle the load. The speed that this engine should aim for should be a sub-second response time, because mostly these things are powering some UI, either internal or external users are trying to use it. And generally, I don't think anyone likes the spinning wheel on a UI. So sub-second response is not like a good to have thing in the system. It should be a good expectation, or like a thing that it should easily support. And then there should be some ability to do complex analytics, since like you can't pre-compute everything. So the system should be responsive in an ad hoc manner. And generally the event data is highly dimensional, so it should be able to handle hundreds of dimensions. And as we discussed, the interactability kind of introduces more concurrency, as many users would want to use that, and there are many tenants. And again, we still don't want to lose the freshness from these streams that we get. So here we introduced like Druid, which is a high performance analytics data source for event-driven data, which tries to tackle all those challenges. Since these are a lot of keywords, we'll try to go over them in a broken manner. By high performance, we mean that the query latency is low. We promise that, okay, sub-second is a real thing and a consistent thing in our database. And you can also ingest at high rates as well. So if there is a lot of data coming from your applications, you can have a central database where you can push all of them. By analytics, we want to tell that we do support complex things like ranking, group by, time trending, counting, all those things like complex aggregations. You can do all that. The data stored part means that the cluster actually stores a copy of your data. So while it is ingesting from the Stream Hub, it has to maintain a copy. The goodness that comes out of that is you get a high performance query engine. And it is based for event-driven data. So where the most common examples for event-driven data are like click streams, network flows, where let's say you have a network mesh and you want to measure how my network system is doing. And let's say if you want to measure user behavior for your application or some digital advertising that you want to do. Or if you, let's say, if you have a server fleet and you have the data which is coming on from all the servers, which are the server metrics, which is more like a time series data that you want to analyze. And then there is IoT data as well, which is similar to time series, but yeah, I mean, that is also handled. So we looked at a while back at this image, and this showed that there was this thing like stream processor, etc., all those things, and KV store for building a real-time dashboard. So Druid claims to replace that with just an analytical database, which gets a continuous load of things and does its aggregation and serving layer both inside the system so that you don't have to take care of. And then there's a SQL API through which you can query. The earlier GIF that we saw was from an implied proprietary software, which is like a dashboarding software like your Tableau and Looker and Superset. But you can plug in Druid to any of your favorite apps which you want to use for dashboarding. So like getting our feet wet into the key features of the software. So here are some of the things which represents the scalability, reliability, and the general capabilities of the system. So the database is actually column oriented, and that's how it can handle a lot of dimensions. Since generally the analytical data kind of runs out of hand in terms of breadth, and a lot of dimensions keep adding and gets put down as well. So the column oriented storage helps in the compression as well as querying part of the system. The high concurrency part comes also because you can like very elastically scale the database to support a lot of users. And by high concurrency, I mean that a Druid cluster can easily scale up to thousands of users running maybe even like 10,000 of queries per second as well. So as we discussed with that, we wanted the system to have some big data streams to analyze. So it should be scalable. It's a distributed service and it can scale to hundreds of servers. And the ingestion rate can be as high as like 1 million events per second as well. Now, the good thing that comes with all this is that you can do all this along with maintaining isolation and cost efficiency. So for example, let's say in a Druid cluster, there are multiple subsystems. Let's say one subsystem is trying to ingest something and the other subsystem is trying to querying. It is not necessary that both of them have the same hardware or the same capacity. You can just plug out the system that you want, scale it how you want it, and they all will be a part of the same system. And since Druid powers a lot of UI and customer-facing applications, we have built in a built-in high availability of the coordinator, which helps in reliance of the system. And then there are like enterprise security features, which includes like transport layer security from client to server and within the cluster as well. And then there is authentication and authorization with all the popular tools like LDAP, Kerberos, and like native authorization as well to different resources. So talking a bit about the features of the ingestion subsystem, which is a very major subsystem of Druid, you can, as promised, you can do continuous real-time ingest, and it can also handle late arriving data, which is very common with real-time data that sometimes the clients hold back the data and then you kind of push it again back. Right, and you can also actually do batch ingestion. Let's say if you have some data in your data lake, you can use any of the popular formats like ORC, Parquet, JSON, Avro, all that. And you can ingest it via using a SQL or a JSON spec. The good thing with batch ingestion is that you can also do range or hash partitioning. If you want fast querying, like the partitioning of data is a very useful thing. It helps like 10 or 20% of the query performance as well. Another good thing that you get out of ingestion is that you can do automatic compaction of data that you have ingested. So for example, what happens a lot of times is that when the late arriving data comes, it is pushed into small files, and that creates a lot of problem while querying because the number of files, etc., they increase. So you can compact them and create like a nicely structured data. Or if you want to kind of reduce the resolution of your data, maybe you want to aggregate some things. Earlier, let's say for the current day, you are evaluating your data at a per second level, but for the previous day, you want to do that per minute. So you can do that all via a compaction job. And another good thing that comes is that you can also do aggregations at ingestion time as well. So as you're ingesting, if the data is too much, you can ingest it at runtime, compact it, and then store it. And there are also like expression transforms that you can use. The query system, it provides like the SQL API. You can do that both via REST and JDBC. The JDBC one is very important for all the tools that connect, right? And by default, you get bitmap indexes and dictionary on all the dimensions, which make things very kind of performant in the sense that you don't have to materialize the data while querying it. And like a lot of times, you can do database features like late materialization and working on indexes and dictionaries to do fast computation. Then there is schema elasticity and evolution as well. So there is no relational tying of your database where you specify like a schema and you have to stick with it. And if you want to change it, then you have to rewrite all the things. So Druid doesn't provide for all those problems. You can just change the schema on runtime and the queries will just evaluate them automatically. Although join is a kind of an anti-pattern in the OLAP world, but still we provide it because we have seen enough exceptions in the production systems that we provide join. There is support for JSON columns, which are the most popular thing through which event data gets generated. And there is automatic indexing of things so that you don't have to care about how to index it for performance. And then there is actually a very extensive support for approximate algorithms as well, because generally while processing real-time data, people do want to get approximate results instead of spending time and evaluating the exact results. So there is a very good friendship with Apache Data Sketches project, which provides like specialized approximation algorithms for quantiles, double, and strings, etc. And if all this jazz is not enough, then you can also add your own aggregation functions, filters, scalar functions, etc., and easily plug in the system. So as we discussed, the use cases are mostly related to clickstream, checking your app behavior, user behavior, digital advertising, performance, network flows, and IoT. So a lot of companies have been using Druid. I think it's 10 years young now. And like people like Yahoo, Netflix, Airbnb were very popularly and are at a very high scale using the software. There are multiple telecom companies which also use it as well. And the original creator of the Druid project was Meta Markets, which was running like a derivative market over the ad tech system. So there was some testimony from Yahoo which was saying that they have billions of events which are being ingested into Druid, and all of them were getting scanned within a second. So given that all those things, if we look a bit at the architecture of the system, we can see that there is a client and there is a query node which acts like a broker between the storage system and the client. So the query node takes in your query, provides your console to write stuff that you want to query, and then it interacts to the main cluster, which is in the blue section. And as you see, all the nodes in the cluster are doing the two subsystem parts. One is indexer, which is indexing data either from streams or from batches. And one is the historical data, which maintains your batch data, which you are ingesting over the time and is served over querying, right? So every node can do both of that. And the good thing is that both the systems are not directly coupled. They interact via a bridge called deep storage, which you can set up something like an HDFS or a cloud storage. So you have the elasticity to push the data from indexers into a deep storage, and then the historical will then download data from there to serve. And then there is a master node which performs all the coordination duties, and it does the election and the high availability using Apache Zookeeper. And there is a metadata store where you put in data regarding the table or the streams that you have stored. So we discussed a bunch of things that Druid provides, and like these are some of the main reasons why these things work. Like for example, like a sub-second query is possible via indexes because they save a lot of work, and you can work directly, especially if there are strings, etc. You can directly work on dictionaries instead of kind of deserializing them and then using them. Then there is our processing engine is fully vectorized, which means that we are not spending all that problem or the time that you have in the per row processing thing. We do things in batches. Since Druid is a Java-based project, there are chances that you run into a JVM problem while doing memory management. So we have done like an efficient and a fast direct memory-based execution where you don't have to run into the overheads of Java memory and also the slowness that might come due to GCs, etc. Along with that, for aggregations ranking for all the querying system, we extensively use the dictionaries for performance implementations so that if you can do something directly on dictionary, why read the data and spend time on it? And if push comes to shove, and if we have to scan tables, that is also being done very efficiently in the Druid project. We currently use like the mmap system call of the operating system. So if your workload has some hot columns or has some data pattern, that automatically gets adapted into the mmap, and your table scan eventually starts becoming more memory driven instead of disk driven. So if we look at a bit of integration patterns that come via for Druid, we can see that the event streams are pushed into stream hubs, and you can enrich them via the stream processors and then directly push them into Druid. This is the modern architecture or the modern way how people do things. Then there is slightly less modern architecture where via data lake, you enrich data using Spark or Hive and then ingest into Druid. Those people do generally batch ingestion. So we recommend you to try this at home. You can download it from the Apache community website, or the implied distribution is also available. And if you like contributing to open source projects and if you like coding things, then feel free to come here at github.com, and you can pick any issue or open issues or work on any PRs, etc. And also we have the community, which is going on Twitter and on the community page of the website as well. Recently, we have launched a Slack community, which is getting very popular, and people come there to discuss their problems, thoughts, and solutions. So that is something also that you can check out. Thank you. I think that's it from my side. Thanks.
Thank you for that. So we're up to our final session of the afternoon or the day, our panel discussion. We have 4 people joining us on stage today. We have Nitish Matthew, Joe Race, Caroline Even, and Zanab Maleki joining us on stage today. So please give a round of applause for our panelists here.
Let's hop up on stage. Apologies for the disorganization. We're just going to get some lapel mics from the sound crew for our speakers, our panelists. So we'll all grab a seat. Can we get a few lapel mics down on the stage, please? Yeah, that's an option. Apologies for that.
Check. Here we go. Now, panel's all real quick. Crowd photo. Sorry, I'm from the States. I don't get to see that many people. So it's good to see everybody. Actually, can everyone clap really loud real quick and pretend you're really enthusiastic? You have to do it again. Wait, my camera got all messed up. 1 second. So, but you're getting warmed up. It's going to be such a great panel. All right, so 1, 2, 3. So now we'll start. Panel in a second. All right, thanks.
While we're waiting, has everyone had a good time today? Yeah. Send around the feedback form. Thank you.
I'm glad you checked the response before you mentioned it.
Would you like to do this again next year?
Absolutely.
Hi, testing? I'm a big believer in testing after everything I heard from Zainab today, so I just want to test. So, the funny thing is, just before the event, I was thinking, this is the last event, I should probably start with a joke, right? Like what every engineer did, what did I do? Went to Google and searched for best data engineering joke.
Thanks, yeah.
You know what the sad thing is?
Thank you.
I couldn't find a good one.
Yeah.
Anyway, that said, we clearly need to have some fun. So again, welcome to all of you. This is the last, but I promise it'll be the most fun event of the day. Thank you very much for holding out till this time. If it's any consolation, there is a bottle of bubbly for the best question. So hang around. My name is Nitish Matthew. I lead data engineering and governance for Afterpay, and it is my absolute pleasure and privileged to actually welcome our esteemed audience to this discussion forum. We've got Caroline, Zainab, and Joe from far away, all the way from Salt Lake City, Utah, as well. And we've got people from Perth and Sydney, even though, you know, Sydney, these are small towns compared to our wonderful Melbourne, but we'll take them. So, Caroline, Zainab, Joe, would you like to just kick off with a small introduction?
Sure. I haven't had the time to test, but it seems to be working. So testing done. That's one thing. Hi, I'm Caroline. I work for a company called Rock. It's one of the sponsors of the event. I'm a software and data engineer. Yeah, that's me.
That's a new production. My name is Zainab Maleki, and I'm a technical principal consultant at Mechanical Rock, all the way from Kansas, Australia.
Hey, what's up? I'm Joe Reese. I'm from the USA. Also a data engineer, data architect, been in data for over 20 years. Do podcasts, Monday Morning Data Chat. If you want to check that out, it's really good. You should check it out. Also, co-author of Fundamentals of Data Engineering, which is the first definitive book about data engineering. And along with the bubbly that will be given away, the best question also giving away is this last signed copy that I have of this book. So ask your questions, get rewarded accordingly. So.
Great. Thank you very much. Joe, you literally wrote the book on data engineering, right? Yeah. What could be a better question than to start off with? What exactly is data engineering?
I'm going to ask the crowd this. I'm always curious what people think data engineering is. Somebody in the general direction, what do you think data engineering is? Yeah,
creating data. If we have data, organizing and engineering, making a data asset for other people to use it nicely.
Thanks. That's really good. How about over here?
Making data available for end-to-end consumers.
Good. Yeah.
Problem solving data.
Awesome. I like these answers. So I can tell you what data engineering is not. Data engineering is not data pipelining with Spark and ETL with this or that technology. Data engineering at the end of the day is about taking raw data from source systems, doing something to make it useful for downstream consumption, typically by analytics, machine learning, data science, whatever. So that's data engineering.
That's great. Joe, just a follow-up question, right? How do you define success?
So it's interesting. In data, we always talk about providing value, right? Value is also one of these trick words where if you ask what value means, I think it's a very subjective thing. My favorite definition of value comes from the book Lean Thinking, where it's basically ultimately what does a customer find valuable, typically from a product perspective. And so success, to me, with data engineering means is your customer happy? Or are they getting what they want?
Great. I love it. I mean, is your customer happy?
Is the customer happy and you are logging off at 5:30?
Yeah, hopefully you're happy too. Yeah. But when your customer's happy, you'll be happy. So
Yeah, I mean, I'd like to add on to that, if you don't mind. And I say, as a data engineer, your customers is often internal teams within your company or wherever you work. And so sometimes your customer being happy means just, the consumer teams being happy, being able to handle the data efficiently in a timely manner without having to ask multiple questions to multiple other members of the data platform. What's the data? Where does it come from? When is it available? So, yeah.
It sort of nicely ties to many of the aspects you mentioned today morning about self-service, right? So, and I would love to get back to this beautiful phrase, elite teams, right? Elite teams lead to success, I would assume, right? What's the secret sauce? What are the things that you've seen in real life with teams which are elite?
Yeah, I'll say I've seen a lot of elite teams in software engineering, software delivery teams. And the secret is they try to decouple themselves and remove the dependencies that makes them slow. Like, for example, not having someone else to deploy their applications. They build it, they run it, they maintain it. They do the whole end-to-end ownership of their application so they don't have dependencies. or manual testing. It's slow, it takes us time. It's dependency on someone else testing our applications. So they write automated testing, they become an elite team, they can move fast.
So, but it is by definition a very rare thing, right? I mean, we don't see a lot of elite teams. Is it organizational culture? Is it leadership? What is missing that we don't see more of elite teams?
I think it's a cultural change. We see it in a lot of new teams and teams that are willing to change the ways that they're used to do things. And the ways that we're used to, it wasn't fast. That's why we're trying to look at different ways. And unless you're willing to change, you can't become an elite team.
Okay, so the team has to actually feel like, hey, this is interesting, this is useful. I mean, all of you have heard a lot of amazing things from Zainab today morning. I mean, are you driven enough to say, this is good, I need to be elite, I need to change? And that takes a little bit of inherent drive, right?
Absolutely.
Okay, thank you, that's great. And then, Caroline, just coming back to you, right? I understand you guys moved from a data lake to a lake house architecture. And what were some things you learned? What was the motivation for that change and the things that you would like to share to the audience?
Yeah, sure. I think I'm going to build on top of what a lot of our amazing speakers have been telling all day in their talks. And yeah, it's great to hear everyone's story about the way they build and create, or the way they think about, building this infrastructure that is able to manage your data, ingest it and make it consumable. And on top of that, adding security and adding governance. And there's just so many things to think about. And I think, we've heard Rogan talking about data warehouse, and it was almost a thing of the past, right? It's still very much like a thing of the present, but you can only put so much load on a data warehouse until it starts showing its limits. So data warehouse is mostly a tool that is designed for data analytics and to empower your business intelligence team to basically drive data analysis for your business. And on the other hand, data lake, until recently, were mostly really a bunch of data that's dumped on cold storage like S3, and it's hardly usable. So it doesn't have the SQL feature that the data warehouse provide that really makes it easily queryable and discoverable, and these kind of things. And so what we've built is a solution in the middle. So you think data lake and data warehouse become this lake house concept, where you put data still on cold storage, so it's cheap to store, but you add some smarts on top of it, so it's easy to query, and it has like the modern features of a data warehouse. And doing that really offloaded the pressure of our, warehouse cluster. We use AWS, so we use Redshift, in order to empower teams to basically run their data analytics fast without coming back to us and say, oh my God, why is my query not running? And why am I competing with the machine learning jobs on the cluster? And oh my God, my query has been aborted, and this kind of thing. So yeah, the lakehouse was really good in that respect.
Have you seen any benefits after the change has been done? How long have you been in production with the lakehouse?
Yeah, so it's an ongoing project, and we've been in production for almost a year now, but still adding, features on top of it. Definitely, I think one of the best outcomes was our internal customer team. The data analytics stopped complaining all the time about, the query being slow or not running at all. And also our internal team, like machine learning, being able to finally run some data-intensive jobs on S3 without impacting anyone else.
Okay, great. Thank you. We've heard a lot about data mesh today, so I've got a couple of questions to our panelists on data mesh. So Joe, what are your thoughts on the data mesh? What I would love to, you've talked to a lot of clients as part of your work, as part of writing the book, etc. Right? What is really happening in the world, and what are the messages that you'd like to pass on to the people here, right?
I think data mesh is, as I even explained to Jamak, I think it's a utopian ideal, which I think everyone should strive to move toward. I also feel like we're at an interesting inflection point with data mesh, where I feel like there's also potentially a lot of misappropriation of the term. and I think confusion about what it ultimately means. I mean, ultimately, if you go back to Zhamak's canonical definition, it's about decentralization. You basically apply the same principles of domain-driven design and microservices to data. So, but it's not a technology, right? And it's not this, that, or the other thing. And my fear is that it's going to become a religion or a cult. And so I hope that people can at least take the time to read, Zhamak's, book, Data Mesh, read the original articles. And I say, and try and say true to, I would say, what she was trying to envision, which again is just decentralization. That's all it is, right? And this is not a new concept. This has been around for decades in software. And so that's a lot of my thoughts on it. But again, I think it's one of the best ideas I've seen in decades, frankly.
Yeah. Can I add to that? I often see people getting confused about the decentralization, and they say, like, do we need to decentralize our data? Is that what data mesh is saying? And my interpretation, which could be wrong, is it's not about decentralizing your data. You don't need like so many multiple versions of data warehouses. You can have one data warehouse, you can have multi-tenancy, but then decentralize the way that you're looking at it and architect your data in a decentralized way.
Yeah, I mean, I'd go even stronger to that. Like, you really don't want to have multiple copies of your data everywhere. You want to have one copy of like what's the source of truth and being able to build on top of that. And yeah, another thing you're talking about, data warehouse, have one data warehouse. I think actually Rogan mentioned it, and yeah, I think streaming is definitely like a power tool within the data engineering field. It's very important. It is the future combined with other tools that already exist. In the way that streaming really allows teams to be decoupled and move fast efficiently. If I've got, the Kafka streams, one topic, anyone can consume from it. And if you have a schema like Avro on top of it, the data governance exists out of the box. And you also have backwards and forwards compatibility.
At the end of the day, though, I mean, it's not really like a streaming or a data warehouse or that type of discussion. Data mesh is much about, I mean, here's the deal. It's almost 100% organizational at the end of the day, right? Who's heard of Conway's Law? Yeah, right. So basically, Conway's Law describes a phenomenon where in an organization, you're going to design systems around the way you communicate as a company or as an organization. So if you're inherently siloed, decentralization is impossible, right? I mean, tell me how that would work. And so really, in organizations where data mesh could be achieved, Zhamak herself describes it as a socio-technical phenomenon, highlighting the socio part. It's an organizational thing at the end of the day, just like microservices is. I mean, microservices can't work if you have, again, a siloed way of thinking, right? And so and so again, I would say you really have to assess the organization itself and whether or not you are healthy enough to, I wouldn't say healthy, just whether you're capable of doing it or not, frankly. And the thing is, don't feel bad if you can't. Like, a lot of companies suck at microservices too. It doesn't mean you're like a crappy company. It just means you communicate poorly.
I think the word communication is very interesting. And I'm halfway through your book, and you have so many references to people should be talking more to each other, right? Not less. Self-service and independent decoupled teams doesn't mean you stop talking.
No, that's. I mean, okay. Let me ask you this: if you could automate your processes and avoid communicating with your teams, just envision what that looks like. How does that make you feel? Do you think that would work? If everything was just an API call to like every other department, right? So.
I mean, I think that's what we were talking earlier about adoption, right? If you stop communicating, that's also one of the reasons why people don't adopt the the shiny new system that you've built that's going to make everyone's life easier and faster. One of the drivers of adoption is also leaving space to the team to be able to adopt that technology. So you have to make sure that you actually communicate effectively within your priorities. Like if you set up your objective quarters and everything, you do have to leave that space to, we need to do that migration to that new technology.
Yeah.
But yeah, communication.
And can you guys think of an actual company, right? You don't need to name the company, who actually got this right and who are actually seeing the fruits of this model, this way of thinking?
Ooh, well, stay tuned on Monday morning. So I'm actually interviewing somebody who I think a lot of people claim that this company's actually done data mesh. So Monday morning data chat, type it into your phone, subscribe to it on Spotify. But the podcast, we're going to be interviewing Omar from Roche, the pharmaceutical company, about this. So it should be pretty cool. And again, this person, was vetted by the people who came up with data mesh, and also who was it that got the intro from? Was it Kent Graziano, right? Who knows a thing or two about data. So
what about you, Zenab?
Yeah, we worked with one of the clients that they're in later stages of their journey towards data mesh architecture, and other clients where they're early stages, and obviously because they're bigger enterprise, it takes them a lot longer.
Okay. Yeah. And thank you. I think that will be really good. I think if we can understand what people have already done and we can shamelessly copy, life is so much easier.
Yeah, I mean, these success things help, right? But I think it's also, how many people have heard people doing data mesh in the real world? Or claiming to, right? And so it's this weird thing where it's like people saying they saw the Loch Ness Monster or Bigfoot or something. Yeah, but it's cool because it just takes one. Can I go on a quick tangent real quick? Please. So it reminds me of a lot of discussions I had with Bill Inman, who created the data warehouse. He told me basically, like, did you know that when the data warehouse, when he first came up with the idea, it fell on dead ears. Like nobody wanted to talk about this thing at all. Like data warehousing was, it was a discussion point that nobody wanted to talk about. But it took one, and then two, and then three, and then it became the most popular data paradigm in the world. And we're all, we use it without really understanding the term, without understanding the history of it. But at that point in time, it was actually written off. And so but it took. So it's these few success cases that you really need to get it going.
I was going to add that one of the success factors that I've seen in the client that we helped them with data mesh was the sense of ownership and communications. So it was very well defined within each of the business domains that, yes, we understand data is our problem. It's not someone else's problem. Yes, we understand it. And they were willing to take the ownership, and they were willing to get on board.
Okay. Yeah. Hence the socio-technical aspect of what Jamak says, right? Yeah. And one question to you, Caroline, is let's say you built this architecture, you have things in production right now. If load were to increase by 10x, right? How would you think about the delivery model that you have right now? Would you change anything?
By 10x, you say?
Yeah.
Yeah, look, it's always a question. I think we're in a really good positions where we can really scale our infrastructure quite well. So we can do, horizontal scaling in a good fashion.
And from a data delivery point of view, right? Do you see any change and expectations from, say, the application teams? Hey, you should be sending more things yourself, you should be taking more accountability. Because I think many of us in companies struggle with that as to how do you convince people to take more ownership, that word again.
Yeah, I mean, look, like given the scale of our data right now, I wouldn't expect it to grow by 10x, by tomorrow, but, we're lucky if it does. Definitely 2, 3, 4. And I think it is a long-term discussion. You talked about communication, and it is definitely a long-term discussion with the internal teams to actually think about these problems. Also, it's not just a load on the data platform, but it's how it impacts every other team and what they've built on top. But yeah, I think I think we're in a good position if we scale horizontally to be able to increase that load. And then every little system, like for example, the Spark streaming app that we have in order to load the data from the Kafka streams into our lakehouse, we potentially would have to review that and review the memory and constraints things, but it's not something that would
No, great, thank you. So Joe, I think we are running short of time. I'll probably ask some very quick questions. Joe, you self-describe yourself as a recovering data scientist.
Yes.
Are the data engineers that bad? I mean, what's the backstory?
Well, I'm a recovering data scientist. I was addicted to data science for a long time. But you know, I found help, and now I'm a better person. So, but where does it come from, right? So, you know, I've been in data for a long time, and I've been doing machine learning before it was called, I guess, data science. It was, you know, I guess conjoined with the term, and so. And I remember, you know, throughout the 2010s, who was doing data in the 2010s? Anybody? Probably half the room. Yeah. Okay. So, you know, so I'm sure you can remember, right? Especially if you're doing data science, you'd be hired to go do data sciencey things. I mean, there was a time when data scientists were basically considered like magicians. It's like just show up and then wave your wand and like, you know, magic, like unicorns will fly and like rainbows will, crazy stuff, right? And you get to these you know, these jobs, these gigs, these companies, and they don't have any data upon which you can do the science, right? Or and then basically they say, well, you're pretty smart, you're good at data. Why don't you just build the systems that you know, so you can do your job? And I was like, I would like to do my job, but you know, when I was hired to do that, not, you know, do the prerequisite work to do it. But here we are. So that's, I think, doing that over and over again, especially in the early days of ML, where there weren't frameworks. Right? I was writing ML code in Java back in the day because I think sklearn was like brand new, and well, you know, you just had to do things in, you know, on GPUs, and everything's by hand. So we've come a long way, but yeah, it was just, yeah, that's why I'm recovering. I felt like the term had been disabused of all the. I think there's so many expectations on the term and not enough hard work that went on behind it.
Yeah, I think we are hitting the trough of disillusionment of the data scientist term in the Gartner.
Yeah, and I was like the OG of like the recovering data scientists. So that was like, I think I gave myself that term in like 2016 or something.
Fair enough. Cool.
I trademarked it too. Yeah, so, in the US.
Yeah. We've got 8 minutes. Love to get some questions from the audience. If we can pass the microphone. Any questions, anyone, for the panelists? Can be about anything today. At the back.
Just yell it out, or
Yeah.
Oh, I'm interested to know. So in 2 months' time, Gartner have got their DNA conference in Sydney, and as of today, there's one talk that happens to mention data security. I'm just interested in the back end of the Optus breach that was announced on Friday. The industry always over responds to these things. So, you know, it won't surprise me if there's a dozen talks by this time next week in that same conference. I'm just interested in your views on what the response from the industry will be, and what the reasonable response, and also the overreach response that will inevitably happen when these things occur as well.
Maybe to explain some context to Joe about what happened with the Optus data breach.
Yeah, so Optus is, Optus is
sucks for them though.
It's I believe the second biggest telco provider, and 8 to 9 million consumers, one of who is me. I also got an email 3 days of last Thursday saying your name, date of birth, your ID, everything may be out there. Best of luck. So, so that's the backstory. So this is very hot right now. So, what are your thoughts? Anybody can jump in.
I think it's a long journey in terms of data security and correcting the bad behaviors that we're doing already. I've seen horrible things in different places that data engineers or people that have admin access, we connect our dashboards and Tableau and like Power BI with system users rather than like people's privileges or like, you know, people's user accounts. And I've seen really, really horrible ways. Up until our databases, we're very careful. Like, you know, like the software databases, there are application data, we're very careful. But then as soon as it gets after it, like we do really, really bad stuff. and I think it's a long journey. Like you've got to set up security from the start into the way that you're handling data. And if you can't fix it from the start, it's really hard. And people can talk about it a lot. There is a breach going around, but unless they're willing to start fixing it from the beginning, I think it'll be a long way that we see data security being handled properly.
Thank you.
I mean, there's a reason that security has its own chapter in the book here, chapter 10. It's also one of the undercurrents because it's like, you screw this up, like you're out of a job, basically. Like, so you guys can come up with the fanciest data pipelines and modeling and all that crap. But like, if your name's on the breach, something happened on your watch or something you designed, you can kiss your job goodbye. I can guarantee you that. At least in the States. I don't know what you do here. Maybe you'll get like a promotion or something. But the other thing is too, it's like security, you're always fighting yesterday's war, right? So that's part of the problem. I'll bring it back to something at stateside, which is Uber, right? So that was basically some idiot giving up, password and username, through like a phone call or an email or something, right? So as we point out in the book, security starts and ends basically with everybody in this room, right? Like you are responsible for security, every single one of you. It's not really, I mean, definitely like lock down your S3 buckets and your servers and all that stuff, but like, don't click on stupid emails and get in a phishing campaign. Like that's how most of this shit happens. Like, Colonial Pipeline in Florida, when that got shut down, that was somebody, a random employee clicking on an email, right? Yep. Don't do dumb things, first of all. Like if somebody calls you, maybe call them back and then call their friends or their mom or something. And just ask them like, hey, did you ask for my password? But I mean, it's stupid things like, because you are all the weakest link, every one of us.
Yeah, I think with a lot of people, how many of you have admin passwords or privileged accounts? Yeah. A couple.
So wait, keep raising your hands. I want to get a photo of this.
so yeah, I think it's a lot of responsibility for us also. Any other questions?
Mic grab mics. We're running low on mics. Thanks.
Oh no.
You can just introduce yourself and say who you work for, and then.
Thank you for the sharing. So I'm pretty new to the field and I have a question. So if you guys could give one piece of advice to yourself when you first joined the data engineering field, what would that be for you to, I don't know, what advice would you give to yourself to be good in this field or to succeed?
I think very simple for me is if you are lucky enough to work in a company where you've got great peers, just draw on the knowledge from, your team.
I would say it's, especially when you're starting out, understand what your goals are, right? Understand like, what do you want to get out of this? You have a million career options, right? You can go work at Optum and help them with their security issues. They might also need a lot of people anyway. But so learning is a very interesting thing. I'm going to talk about this in my Sydney keynote as well, but there's an interesting balance in what you need to learn, right? So all too often what I see with data engineering, I can tell you how to be like a horrible data engineer. How about that? I'm going to tell you in the next 30 seconds how to be like the world's crappiest data engineer. So focus on like only understand the technologies that you're using for your job and don't bother understanding like how they actually work at a fundamental level. Don't bother understanding like the fundamentals of like, the data engineering life cycle. So, how data is ingested, how it's transformed, how it's stored, how it's served. Like avoid all that stuff and just focus on like what's directly in front of you at the time. And like, you'll be like the world's worst data engineer. And so if you can, so that's, if I invert the question, just do that and you'll be very mediocre. And if you actually don't do that and focus on the bigger picture of your field and your career and your craft, that's how you become great. Right. But all too often, though, and this is why I wrote the book, is like there's a ton of horrible advice on data engineering and how to become a data engineer. So like definitely don't learn Pig. I know there's a lot of articles that tell you to learn that. Like that's probably not relevant these days. So, or Hadoop, you don't need that.
I think I had to think about it. But one advice that I think about is challenge the norms. Always the way that things are used to be and things are the way that they are, they're not the best way. So sometimes when you are fresh and you have a fresh view of things, you might be able to challenge and find better ways of doing it.
Great question. Thank you. I think we're running short of time, but maybe we have time for one last question.
Right. Hi, I'm Letian and I work for Atlassian, and I want to thank you for the discussion and the answers. And I'm definitely not talking about my employer here, but if you come to a data organization with significant communication gap and silo problems, what would you do to fix it?
It was a question, what would you do to fix a siloed
data org with communication issues?
Oh, well, I mean, if you could solve that problem, I mean, you would you know, be like probably the world's richest person. It's not an easy question, right? I mean, it really has to come from the top at the end of the day. That's how this stuff gets done. And it has to come from the bottom though too. So kind of like this. But the problem is when you do this, what's in the middle here? That's middle management, right? And what is the incentive of middle management? Bingo, exactly. So there's an old quote from Charlie Munger, as Warren Buffett's business partner, and he says, "Show me the incentive, and I'll show you the outcome." Right? This is like the golden rule of the universe. If you just remember like that sentence alone, show me the incentive and show me the outcome, like you're able to figure out like how basically the entire universe works, at least with people. And so if there's no incentive to change the communication structure of a company, the outcome will be that you have siloed, crappy communication, and that's that. And this is actually sometimes by design. Keep in mind, this benefits people. We all want to do decentralization and a non-siloed communication, but it's like, this exists for a reason. So.
Yep. I think, yeah, like short one, you ask how and what will you do, but yeah, like you just said, why is important. So understanding why and spending time understanding why is that way may already provide some answers.
I think the last thing, one thing that helps is taking initiatives. If you see silos happening, take that initiative and break it. Like, for example, I was working for a client that each of the teams, they were doing their own thing. So I started creating these meetups and guilds to talk about, hey, look, we're doing this other way, this way. And you're doing it that way. Let's share, like, let's knowledge share and kind of learn from each other.
Right. Great. I think we're slightly over time. Thank you very much. Thank you very much, Joe, Zainab, and Caroline. Excuse me. I think we have the prize for the best question. I let
Yes,
you pick it.
Absolutely. Who do we think, Nitish, or who's going to pick this amazing prize, or the winner of the amazing prize?
You guys can pick.
So,
what is that?
It's a bottle of champagne.
From Courtesy Afterpay.
Courtesy of Afterpay.
You don't have to pay, it's free.
So is that like is it on a payment plan? Is that how that works?
Okay. Well, we always love a newcomer to data engineering, so congratulations. Thank you very much. You're welcome. All right. Happy learning. Well, thanks so much, Nitish, Caroline, Zainab, and Joe. As mentioned, we are going to continue this party in Sydney on Thursday. We didn't say this beforehand, but yeah, we will have a live stream of that event too, so you'll be able to catch Joe's amazing keynote amongst many other amazing talks. So you're most welcome to join us. So a round of applause as you, yeah. We're going to have a little after party down at the Moat. It's pretty much on the opposite side of State Library Victoria, on the other side of the building. So you just have to walk out left and left and left and get to that venue. We've got some canapes and a few dollars on the tab. I just wanted to invite some of the co-organizers to just hop up on stage to accept a round of applause from everyone. I thought they've done a marvelous job today, and it's been seamless. So Riva, Noel, Aditya, would you like to hop up on stage? You know, these things are a lot of hard work for many, many months. You know, we've probably been at this for a good 6 months or so. So round of applause. Feel free to come out in front. it's been really heartening. The response from today. We really sort of appreciate, you all showing up and just being so enthusiastic and about this community and what we're building. So thank you as well, and see you down at the moat. See you next year.